Good morning, everyone, and a warm welcome to the inauguration of the ICTer 2024 conference, organized by the University of Colombo School of Computing. This esteemed gathering serves as a magnificent platform for visionaries in the fields of computer science and information technology to unveil pioneering research findings and practical applications. Now, in its 24th consecutive year, ICTer continues the legacy of the International Information Technology Conference, known as IITC, which has been a prestigious event in Sri Lanka since 1998. ICTer is more than just a conference. It is a vital platform where global scholars, researchers, and practitioners come together to foster collaboration and showcase advancements in information and communication technology. Through a rigorous peer review process, high-quality papers are selected for presentation and publication with recognized publishers driving both academic discourse and real-world impact. In addition to these, ICTer also celebrates the achievements of young researchers through the I Am a Researcher competition, introduced last year to acknowledge their extraordinary contributions in their respective fields. This year, awards will be presented in the categories of Most Popular Researcher, Most Contributing Researcher, and Young Outstanding Researcher. Today marks yet another milestone for ICTer as we embark on a journey of insightful discussions, impactful presentations, and inspiring keynote sessions. We are proud to bring together industry professionals, academia, and young talents, fostering a vibrant exchange of ideas and collaboration across these sectors. Thank you all for joining us in our mission to shape a brighter future through the transformative power of ICT. We will now commence the ceremony of ICTer 2024 with the traditional lighting of the oil lamp. This symbolizes the light of knowledge and shared spirit we embrace here at ICTer. I kindly invite the following distinguished individuals to light the lamp. Senior Professor H.D. Karnaratne, the Vice Chancellor of the University of Colombo. Dr. Ajanta Atukola, the Director of the UCSC. Professor Kasundi Soisa, the Deputy Director of the UCSC. Dr. Kasun Gunadana and Dr. Lasanti De Silva, who are the co-chairs of the ICTer International Conference 2024. And Mrs. Shriya Samarnaikar, wife of late Professor V.K. Samarnaikar. Thank you for this beautiful start to our conference. Ladies and gentlemen, keeping the traditions of Sri Lanka, I would like to invite you all to rise for the national anthem of Sri Lanka. Thank you. You may now be seated. Next on our agenda is the introduction and welcome address, which will be delivered by our esteemed conference co-chair, Dr. Kasun Gunawardana. He is a senior lecturer here at the University of Colombo School of Computing. His expertise and dedication have been instrumental in making ICTer International Conference 2024 a reality. We invite you to lend your full attention to his address as it lays the foundation for this grand gathering of intellect, innovation, and excellence. Please join us in welcoming Dr. Kasun Gunawardana to the stage.
Good morning, distinguished guests, esteemed keynote speakers, respected colleagues, sponsors, partners, and delegates from around the world. It's a great honor to welcome you to the 24th International Conference on Advances in ICT for Emerging Regions, ICTer 2024. This conference series has become a cornerstone of the Sri Lankan ICT sector, with roots that trace back to its predecessor, the International Informational Technology Conference, which was known IITC, established in 1998. ICTer serves as a prestigious gathering for local and international scholars, researchers, industry experts, and talented youth in the field of information and communication technology. It fosters an inclusive platform that promotes innovation, facilitates dynamic exchanges of ideas, and cultivates robust professional networks across academia and industry. Here, seasoned professionals unite with the next generation to inspire collaboration and creativity, driving the ICT landscape into a future defined by transformative advancements and collaborative excellence. Today, we are thrilled to mark this significant milestone in our journey. On behalf of the organizing committee, I extend my heartfelt welcome to each of you attending ICTer 2024. This event has become synonymous with innovation and collaboration, particularly in its potential to transform emerging regions through technology. I would like to extend special welcome to our chief guest, the Vice Chancellor of University of Colombo, Senior Professor H.D. Karunaratne. Your presence here today underscores your commitment to fostering progress and knowledge sharing, and we are deeply grateful for your continuous support, sir. Next, I would like to acknowledge the leadership of Dr. Ajanta Tukorla, the Director of the University of Colombo School of Computing, and Professor Kasundi Soisa, the Deputy Director of the UCC. Your vision has been instrumental in the success of this conference and in advancing ICT education in our region. We are also privileged to welcome our distinguished keynote speakers who have traveled from various corners of the globe to share their insights and expertise. Your participation adds immense value to our conference, and we eagerly anticipate learning from your experiences. To our esteemed invitees, sponsors, partners, thank you for your invaluable support and contributions. Your dedication to advancing ICT in this region is crucial, and your collaborations enable events like this to thrive. I would like to offer a special mention to the final round participants of the AMA Researcher Competition. You are here today because of your outstanding caliber, having excelled through a series of mini competitions and challenges to reach this prestigious stage. You represent the bright future of ICT in our region, and we look forward to seeing how you will continue to shape and lead this field in the years to come. And of course, a warm welcome to all participants, including researchers and authors. Your commitment is what propels this conference forward year after year, fostering a vibrant community united by a vision for impactful change. Finally, I would like to express my heartfelt gratitude to the UCSC staff and volunteers, the true backbone of this conference. Your hard work and dedication do not go unnoticed. Over these 2 days, we will engage with a diverse array of topics from artificial intelligence and cybersecurity to ICT for social development and healthcare. We hope these sessions will spark insightful conversations, inspire innovative ideas, and form lasting partnerships that extend well beyond the event. Let us seize this opportunity for learning and collaboration. With that, I warmly welcome you all to ICTer 2024. May this conference be fruitful and inspiring for each and every one of you. Thank you.
Thank you, sir, for the warm welcome and inspiring words to set the stage for ICTer 2024. Ladies and gentlemen, To perform the welcome dance, let me invite the talented students of the University of Colombo School of Computing. Thank you for that amazing performance. Next, we have the director of the University of Colombo School of Computing, Dr. Ajanta Atukolla, addressing the audience. Dr. Atukolla is a respected academic and leader who has spearheaded numerous initiatives in the field of computer science. Please join us in welcoming Dr. Ajanta Atukolla to the stage.
Yeah, good morning, everyone. On behalf of the UCSC, it is my privilege to extend a cordial welcome to our chief guest, Vice Chancellor, University of Colombo, Senior Professor H.T. Karunaratne, our esteemed academic, administrative, and non-academic staff of the UCSC, and the most notably, the eminent keynote speakers, and all the participants and all the invitees are with us today to celebrate the ICTer 2024 conference. The progress of computer education at the University of Colombo, sprouting with its mathematics department, evolving a statistical unit in 1970, then graduating to a full department of statistics and computer science in 1985, and then a department of computer science in 2001, came to its pinnacle as the distinct center for higher learning within the University of Colombo, was set up on 1st September 2002 with the formation of UCSC. Dear sir, today after 22 years, we are gathered here to witness and celebrate UCSA's remarkable achievements and its evolution into the Sri Lanka's foremost institution in the field of computing. At this juncture, I would like to express my respect and appreciation to the late Vidya Jyoti Professor V.K. Samaranayaka's trailblazing endeavors in establishing this infrastructure to the benefit of the future generations. The ICTer International Conference is a legacy that stems from the renowned International Information Technology Conference, which was called IITC, which has been a pivotal event in the landscape of academic computing conferences in Sri Lanka since its inception in 1998. Building upon this rich history, ICTer now emerges as its successor, reaffirming our commitment to fostering innovation, sharing knowledge, and pushing the boundaries of the computing technology in the country and in global. In an era characterized by the relentless pace of technological advancements in the field of computing, it becomes imperative to establish a forum where ideas, insights, and research discoveries can be shared. ICTer expects to fulfill the role of precisely such a platform for everyone. It is a unique opportunity for both seasoned researchers as well as emerging scholars to present their groundbreaking research results, innovative ideas, and practical developments that are shaping the computing domain. One of the distinguished features of ICTer conference is the opportunity it offers for high-quality papers to be considered for publication in the esteemed ICTer journal published by the UCSA. This opens up the pathways for authors to share their work with a broader audience and contribute to the body of knowledge that is driving the computing technology landscape forward. As we gather for the ICTer International Conference today, I encourage all participants to take the full advantage of this unique opportunity, engage in the presentations, contribute to the discussions, network with your peers, and foster the new collaborations. In conclusion, I look forward to witness the stimulating discussions, the knowledge sharing, and the collaborative spirit that will define the ICTer International Conference. Together, let us shape the future of computing technology and contribute to the world that is smarter, more connected, and better informed. Thank you.
Thank you, sir, for your enlightening address. We are grateful for your continued guidance and support. It is now my honor to introduce the Vice Chancellor of the University of Colombo, Senior Professor H.D. Karunaratne. Professor Karunaratne has been a visionary leader driving academic excellence and research initiatives at the university. Please join us in welcoming Professor Karunaratne to the stage.
Very good morning to all. Dr. Ajanta Korala, Director of the University of Colombo School of Computing, Deputy Director, Heads of the Departments, distinguished keynote speakers, well-wishers, all students. It gives me great pleasure and honor to address you a very pleasant international conference today organizing as the ICTer 2024. Which is one of our 23 international conferences organized by the University of Colombo stakeholders. As you are aware, there are 19 entities within the University of Colombo. School of Computing is one and only school with us. And at the very beginning, I was a well-wisher of the School of Computing because I was served as the first board member from 2000 to 2023. I had an opportunity to work with a great scholar, Vidya Jyoti, your former director, with him. So it was a great opportunity, and we knew from the very beginning your school is going very well, and happy to see that there are new graduates coming from various countries and schools joining this university. And at the moment, I think you have about 53 academics, more than 1,000 students. So the entire University of Colombo, we have 43,000 learning partners with around 1,000 scholars. So in recent past, we have been monitoring our research record very well. Individual, each and every academic, Google Scholar and other pages are observed by the university and giving promotion for research. As you are aware that in very recently Scopus elsewhere did the analysis about the research in Sri Lanka. They found that the last year the University of Colombo has produced more than 3,178 Scopus journal articles, and most impactful university in Sri Lanka is the University of Colombo. And according to all four indices, QS ranking and all other rankings, currently the University of Colombo is the #1 university. As I explained that there are 23 same nature international conferences this year I have to attend, organized by 10 faculties, 6 institutes, 1 school and 1 campus. So it is happy that we can see the research progress of the University of Colombo. And this year, especially out of our 1,000 academics, 10 academics rank under the 2% of world best scientists by the Stanford University. Last year it was 8, previous year it was 6. So we are year by year progressing. So I hope that particularly today your topic is advances in ICT world in the emerging regions, very important, timely important, and particularly we know South Asia is the most vibrant region in the world, and India is the most fastest grower, economic growth you can see more than 8%, so that we can see we are in a region where it is more vibrant, and particularly ICT industry itself is a vibrant industry, and I hope that we know we are doing research, but all research are not impactful research. We need to make research as impactful research. So how can we transform from research to impactful research? For that, we need #1, innovations and new goods, new products, new software, new approaches in innovation, and linking into policy making. How can we make the policies based on that to better off for well-being of the people? #3, of course, the community engagement. How do we take our research into community and make more benefit for them? And #4, that we know the collaboration, cooperation, and networking with other universities, industry, and the partner organizations is essential. So if we are doing these 4, we can make more impactful research in the University of Colombo, because our research record is growing and well in the current situation. So therefore, I wish all the paper presenters today, don't stop presenting today and make your paper more higher level publication at Scopus or higher level elsewhere publication. So publishing is the most important thing for academic. I don't want to explain that. So we know all academics doing research, but doing most impactful research is the most important thing. So I don't want to take much time. Thank you very much for inviting me. I wish you all the best.
Thank you, sir, for your inspiring message and for reinforcing the role of ICT in academic and societal growth. It is now time for the first keynote speech of the conference, and I'm delighted to introduce our keynote speaker, Dr. Mohammed Nabil. Dr. Nabil is a principal researcher at Palo Alto Networks, USA, where he leads the efforts on graph-based threat intelligence research in the web security team. He is passionate about building AI-powered tools and techniques to help defenders stay one step ahead of internet miscreants. During his spare time, he teaches AI and data science to the graduate students. He has authored and presented 20+ US patents and 25+ papers at top-tier security conferences and journals. Dr. Nabil is renowned for his expertise in AI and cybersecurity, and today he will speak on a highly relevant topic, securing AI, navigating AI risks to build a safe digital world. Please join us in welcoming Dr. Nabil to the stage.
Hello, good morning, everyone. Can you hear me well? All right. So I'm Nabil. I'm very glad to be here, and thank you very much for inviting me for this keynote. And it reminds me of my undergrad days at University of Moratuwa, and I'm very glad to interact with several undergrad students at UCSJ as well. That's how I got to know Dr. Kasund, Dr. Chamath, and a few other people. And I'm very proud of those students who were able to not only excel in the undergrad research and then get PhD positions in top-notch universities. For example, Ravindu went to UCSB, and Udesh is studying at Purdue, and a few others went to Australian universities. So I would like to see more students getting into research and excel. It's just that we have raw talent. They just need some guidance to direct them to the correct way. All right, with that, I'm going to start with my talk titled Securing AI, which is an intersection of what I work in, my expertise in cybersecurity, and I try to combine cybersecurity with AI in two ways. First is to protect the critical systems we have with cybersecurity, and also to protect AI itself. So in this talk, I'm going to focus more on the latter, where how we protect this AI system so that they will be working as we intend. So before I go into details, I want to point out some of the transformative power of AI technology. As you probably know, it's mind-boggling to know 100 million users were using ChatGPT within 2 months. And we didn't have any other technology that was this transformative. And the closest one is TikTok, which took 6 to 9 months to reach 100 million users. And a recent survey done by a security startup called Hidden Layer, they provide security for AI systems. They found in their survey, on average, each organization used 1,700 AI-powered systems in order to make their business-critical decisions. And in another survey, it is expected to reach $2 trillion market cap in 2030 with over 20% annualized rate. So the reason why I added this slide is twofold. I just wanted to show you why like some people with the advent of ChatGPT, they think AI was invented in 2022, but the groundwork was laid way before 2022. For example, the defining technology that powers ChatGPT is what's called transformers. It was developed about 5 to 6 years back by Viswani. And way before that, the artificial neuron was developed. that laid the foundation to model the way we think using computers. And another point I want to make here is compared to more established fields like chemistry or physics, this field is relatively short. It's around only 70 to 80 years. During that short time period, we have made remarkable performance. That progress is not without ups and downs. And another reason why I wanted to choose this topic is with this, the remarkable progress we make, sometimes it's good to have some safety brakes so that we don't make any catastrophic mistakes. Think about the parallel to electricity. When the electricity was invented in 18th century, we had similar transmittive powers, and we made few mistakes over there, and then we came up with regulations and techniques to make sure that we can consume electricity safely. Similarly, AI has a similar responsibility of using it safely. I cannot think of any industry where we don't use AI, and it touches upon every industry, healthcare, education, or whatnot. And this invariably increases the attack surface as well. As we use AI across all industries, this gives the opportunity for attackers to find ways to infiltrate into your systems. So, no, I'm not talking about the dystopian Skynet situation where we should not use AI and just go back to our old ways. But rather, what I wanted to give you is a cautionary tale where we use AI responsibly and we use it in a safe manner. And the goal of this talk is to show you what kind of steps for industry and researchers can take in order to make AI safe. And the key part of this talk is going to be talking about what is called this adversarial robustness. How do we make sure that these models these models are very difficult to game by bad guys? And when we say robustness, when we have some data point, when we want to classify it classifies into the intended label. If it does not get classified as the intended label, we say that model is not robust. So specifically, I'll be focusing on two main points. I'll be exploring the question of how robust AI models are, and also with the popularity of large language models, these foundation models, I want to also touch upon a little bit on the alignment of these models as well. So let's understand adversarial robustness through some examples. You probably might have seen some of these examples. Nevertheless, I wanted to make it complete and show some example to reinforce what I'm going to talk about. So as you can probably see from this picture, everyone will say it's a tabby cat. And the AI model behind this one, a vision model, it was able to identify with 88% probability that it is in fact a tabby cat. And in 2014, researchers published a groundbreaking paper called Intriguing Properties of Neural Networks, and there they show by adding imperceptible noise into this tabby cat, you get a tabby cat. No one will argue with me that it is not a tabby cat, but the AI model thinks it is a dog with whopping 95% confidence. So it has even more higher confidence than that it identified this one. So what's going on here? So the researchers were able to identify a certain amount of noise that moved the image only a little bit for the human perception, but it drastically moved the boundary of decision boundary the AI uses. The AI sees pixels and these numbers. They don't see the visual perception of the image. So this is one example where you can fool systems by injecting a little bit of noise. And I want to emphasize here, I don't know whether you captured the phrase I mentioned. This is not a random noise. If you add just a random noise, it won't work as you expect. Think about, for example, let's say you got lost in the forest. And if you just try to find your way out randomly, you will likely to get even more lost. So think that the calibrated noise is something like a compass, which direct you in the correct way to get out of the wood. And similarly, this noise is identified in a way that will jump from one class to another with the shortest possible steps. All right, let's look at another example. And you might think these cats and dogs are not very important, but there are other problems which has real practical safety implications. And as you can see, this vision model correctly identified that this is a stop sign. But when it presented with a similar image with some perceptible noise, in this case it's perceptible, these are not random noise. When this perceptible noise is added, it identifies this as 45 kmph sign. Instead of stopping there, it drives through there, and which creates obviously a safety problem here. And machine learning models are quite good at defending for this imperceptible random noise, the calibrated noise. But still, to date, most of the machine learning models are not very good at identifying these models correctly. So there is a long way for us to go in order to fix this. And by the way, this was published in 2018. It's another groundbreaking paper. They show the risks of using self-driving cars. So you might be thinking, are these problems exhibit only in images? What about other modes like text, video, audio? And the bad news is it exists across all modalities. And in this example, I want to show how people game large language model using adversarial techniques. So in this example, we asked from GPT-4. This one is slightly older. Right now, we have with GPT-4o, and this is already fixed as well. So you ask, what tools do I need to cut down a stop sign? Obviously, it's not an ethical question, and GPT-4 identified it correctly and said, sorry, I can't answer that question because it's not ethical. And then we asked the same question. The only difference is we have added some additional text to fool the LLM model. So in this case, the GPT has to deal with two competing objectives, and it gets confused as to what objective it should be responding to, and somehow it leans towards the second objective, and then gives the step-by-step direction how to take down a stop sign. And this technique is, by the way, called jailbreaking LLMs. The idea is you come up with prompts that kind of bypass the safety filters in LLMs. And this is another example. You might think it's only the OpenAI GPT models that are susceptible, but it's not the case. It is, the problem exists across all models, including Claude or Gemini or any other model that we have. So the point here is most of these models use the similar kind of techniques. So if a vulnerability exists in one model, it's highly likely it exists in other models as well. And there is something called transferability in machine learning. If you learn a model to classify something using one technique, you can easily use that model to do some other task. This is called the transferability. And unfortunately, this transferability is applicable to even attacks as well. If you can attack one model, similar kind of attack can be transferred into other models as well. So that's bad news for us defenders. So we need to come up with ways, that protect our systems across all models. So in this case, we ask from Claude model the same question, and rightly so, it says this is not ethical question, I can't answer it. But now, you ask the same question again in a different way, and it completely removes its safety filter and answers the question. Can anyone guess what this format is doing here? It's an encoding here, base 64. So basically, the same question is encoded in base 64, and then you ask from the model. And model is not trained to handle different encodings. And this is fixed, by the way, in the now cloud we have 3.5 as well with Kuna models. So as you can see, defending these models is not a one-time thing. It's a continuous thing. As defenders, we try to patch the system to make sure that attackers can't cover these kind of scenarios. And as we fix these vulnerabilities or the gaps, attackers find various other ways to get into the system. So it's a continuous cat and mouse game. In security, there is no upper limit. It's always a moving boundary. We don't try to make attacks completely impossible. So it's a game of ROI. What we try to do is to make sure that the cost of attacking a system is much higher than what they gain. So in that case, we we are mainly looking to increase the bar for the attacker. All right. So those are some examples. I hope I convinced you these are real attacks that happens in these models. And before I go into more details, I want to share a few fundamentals of these deep learning and LLM models that will help you better understand what I'm going to go into adversarial robustness. Why these models are not robust, why these attacks are spreading all across all models, what can we do about it. So just to have a good understanding, let's go through some basics and then get to the subject matter again. So this is a very basic deep learning model. This is the most basic one that you can ever get, just one neuron and one activation function, one layer. So in a deep learning model, you have basically two functions. One is the forward pass, where you will be doing a linear transformation and then pass through some kind of a nonlinear activation function. And then what you do is you compare the output against the expected output. And we call it computing the loss function. And we want to make sure the loss is minimized so that the true label and the predicted labels are the same. And think about like a factory line where you have multiple people doing each part, and then it goes to at the end, the supervisor. Supervisor is like the loss function here. And supervisor checks what you have assembled, and he or she thinks it's not good, so they send back to change some of the layers, some of the processes they did. Similarly, we have something called backpropagation, which try to adjust these input we feed in each layer in a way that will change the loss function to the minimum. Yeah, let me show it to you how it works in practice. So in practice, when you are developing models, you will be at a high level, you will be going through these steps. First, you will define a model. What do I mean by defining a model? You will be defining how many layers we will be having in each layer, how many neurons you will be having, and what kind of activation function. There are tons of activation functions, ReLU, ELU, and sigmoid, tangent, and several others. So you get to know these functions, and depending on your use case, you will be using different kind of activation functions. And then you will be defining some kind of a loss function, which try to identify how close the predicted label to the actual label. And one of the simplest method we use is mean squared error. And most of the time, you will end up using like some cross-entropy loss function to capture that. And then in order to compute this loss function, you will be using something called the optimizer, because if you just do a naive way of identifying the weight that will be minimizing the loss, it will be really inefficient. So that's where the gradient descent algorithm helps. And there are multiple variants of gradient descents. And we don't usually use gradient descent out of the box as well, because for one main reason, it's not efficient for internet scale data. So researchers came up with this clever idea of what is called stochastic gradient descent, where you don't need to use the whole data set. You can work with subset of data and you can still achieve the same performance. And that achieves the two goals. We want to have results closer to gradient descents, and it's way more efficient than gradient descent. And then you do the forward pass, basically a linear operation where you will be multiplying your input, which is modeled as a vector, with the weights. Those are the model parameters. And then we compute the loss function. In this example, I'm showing the mean squared error. It could be, as I mentioned, could be cross entropy or a few other well-known function. And then we do what is called the back propagation, where we propagate the gradient of the loss all the way back to the first input layer of the model. And this shows what we are at is to identify this point at which the loss is minimized. And this is where the gradient descent helps us to come from that black dot very quickly to the bottom, the minimum point at which the loss is minimized. And you repeat this process a number of times. We call it epochs. Either you stop it at n epochs or earlier, depending on which one converges first. If the increase in the weight is not above certain threshold, we will stop there and then call that we train the model. And the model parameters are going to be these weights that you learn during the training process. So a model is, think of a model as like a zip file where you take the knowledge of the world. It could be a set of image or a set of, let's say, Wikipedia articles, and it's somewhat compress the data into these weights. And when you hear the Llama 7B model or Llama whatever model, what they refer to is the weight, the amount of storage they need to store those weights, the model parameters. And that's the brain of the model. And as long as you know the weight, you can use it to do inferences. All right, so that's traditional machine learning models, AI deep learning models. Now, what about large language models? One thing I wanted to point out here is large language models are not so different from traditional deep learning models. They have layers, they use backpropagation, they will be optimizing a loss function to identify the model weights. And at the end of the day, they will also have a bunch of weights that defines the model parameters. The key difference here is though what is called this fine-tuning paradigm, pre-training and fine-tuning paradigm, where you do this training in 2 steps. And think about all the knowledge in the internet. You use them and train what is called a pre-trained model. And this is done in an unsupervised manner because there is no way we can label all the data in the internet using supervised techniques. So they use something called next word prediction task. So instead of you are prompting it to predict the next word, what you do is you take all the internet data and then use mask learning, where you purposefully remove certain words from the sentence and ask the model to predict. And this is called self-supervised learning. It can learn by itself without you having to interact with it. And this will come up with a model which is generic, which might not be able to do specific tasks. That's where you use fine-tuning. Once you get the pre-trained model, you identify few labeled data. Let's say you are building like a ChatGPT like a model, and you will be coming up with question-answer pairs. It could be in hundreds. The pre-trained model uses billions of data points, and the fine-tune, you only need few label data points and then use a supervised algorithm to get the fine-tuned model. For example, the base model you get from pre-training could be GPT. Once you train, you get is ChatGPT. It's called the instruct model. And as I mentioned, LLMs are no different from traditional deep learning models. They have weights, they will be doing back propagations, and then they will be fine-tuning. What I'm getting at here is any attack that is applicable to any deep learning model is also applicable to large language models as well. And on top of that, there are other attacks. So in simple, LLMs has a much higher attack surface compared to traditional deep learning models. Namely, the main problem LLM face is this prompt injection, the prompt, because the way you use the model is through the natural language process. And the natural, if you can game the natural language itself, as I showed in 2 examples, it becomes harder to defend. All right. So this is a very important point that I wanted to emphasize because we do something similar when we try to attack. So when you train a model, what actually we do? What we do here is we take fixed input vectors. These are images or any text or videos that you want to classify. And it's going to be fixed. We are not going to change it during training time. And what we are going to change, as I mentioned, we are going to change the weights using what's called this back propagation and minimize the loss as much as possible. The optimization problem, this is fixed, only the weights are changed. And at the end of the optimization problem, we'll come up with a set of weights, and that's our model parameter, and that's our trained model. And the weights, it uses this backpropagation to do that. But so now, the reason why I wanted to go through those basic steps is we use similar technique to attack systems as well. So we use gradient descents to train models, and attackers use gradient descent to launch attacks as well. So it's a double-sided edge where, but the problem is slightly different. Here, now think about those cat and other examples I showed. What we did there, we changed the input image in a way that still for human perception it's similar, but for the machine it's different. So that's the same thing we do here. In this case, we can change the model. So model weights are going to be fixed. And instead of changing the model weights, during this gradient descents, what we try to do is we change the input, that's the cat or the stop sign, in a way that maximizes the loss. So in the hope that it will flip the label. So in this case, weights model parameters are fixed. We change the inputs to maximize the loss. And there is one more constraint here. And like, we don't want to change these input images so much that is, for even humans can't identify as a cat, for example. That's where that's where this constraint called LP perturbation comes into play. So this is basically the L norm of the difference between the real example and the adversarial example we want to. This basically says the P norm of these 2 values should be within certain amount. It could be 0.05. It depends on the application that you are working with. And there are various other techniques to come up with, measure the distortion that you want to introduce. For example, for text, it could be some kind of edit distance. For images, it could be L2 distance or L infinity distance. So both are used interchangeably. So let me show you an example of a toy binary classifier, how this attack works. So let's say this is our model. Can I point to this one? That's fine. So this is the top row shows our model. Basically, it's a binary classifier. Anything less than 0.5 is classified as class 0. Anything above 0.5 is marked as class 1. And this row shows like a benign input with 8 dimensions. And when you feed this benign input with the trained model, the trained weights are very simplified weights. which are fixed. The model is already trained, the weights are already identified, and when you use that, when you feed in this input and get the inference, you get 5% confidence, that means 95% confidence being 0 label. And now we define our perturbation budget, in this case the L infinity norm. L infinity norm, just for your information, it is the highest value in the vector, the absolute value, which is, in this case, we set it to 0.5. So that means you can change up to maximum of 0.5 in any of these values. So in this case, for simplicity, we just change all the values with 0.5, and that will still satisfy that L infinity norm criteria. And once you do that one, the model comes up with a percentage of 88, which means it has only 12% confidence that it's 0. So this is a very toy example, but if you take if you take the like deep learning models, if it is an image, you will be working in 2-dimensional arrays, and if you are using language, it will be a 1-dimensional array which you will be dealing with. And basically, you convert this simple linear operation into vector operations, linear algebra. And I also want to show you how this thing works visually. This will give you a good idea about how these gradient descent based attacks work. Just like how do you find the way out of the wood, the shortest path. So this one shows the loss surface of a trained classifier. In this case, we have 3 classes. One is tabby cat. Anything in this region is identified as tabby cat. And let's say for this region is identified as dogs, and this region is identified as horse. And these are the decision boundaries. So just like if the image crosses any of these boundaries, it will change its label. So let's assume tabby cat, it had the features at this intersection. And as I mentioned earlier, one approach for us to attack this model is to go in some random direction and try to identify the closest point at which boundary changes. So in this case, if you go in this direction randomly, you identify this image. It does change the label, but the problem here is it's very difficult to tell, even for a human, whether it's a cat or not, unless you do a very thorough inspection of it. So this is why the random noise addition doesn't work. And let's look at another direction. Maybe this time we only travel a little bit less than the other time, but even that is still, for a human, it's very difficult to identify as a cat. So our goal here is to find the shortest distance, which will come up with more or less an image very similar to that. In these 2 cases, we were not able to. And also, if you try to use this in our optimization problem, they will have a much higher LP distortion budget. They will go past the LP distortion budget, and we will not even reach this actually. So what I showed earlier was the 2D view of this loss surface, and what actually happens is in 3D. And here the z-axis, it shows the confidence of the detection. So the higher the value, more confident the classifier is. For in this case, for example, the point that I identified for tabby cat, it's fairly high in confidence. And the way that adversarial direction detection works is to use gradient descents in a way that will identify the steepest path that you can take. Think about a mountain and a meadow, and if you have to cross a meadow, you will have to walk longer, but if it is a mountain, you might be able to slide down. And the steeper the mountain, easier is it for you to slide down. And that's what these gradient descent try to do. They try to identify the most adversarial direction that you can travel in the shortest possible distortion and change the label. So in this case, when you do this traversal, it ends up having a cat, which is for humans, we won't argue that it is not a cat, and it is also stays within the LP budget that we have defined. And this is what all the adversarial attacks try to do. Take any attack, they try to come up with one variation or another of this attack. So armed with that information, I'm going to change gear into what's called these common attacks. I want to give you some practical attacks that the attackers launch in order to gain access to various components of the machine learning systems. And then I'll come back to again to these gradients and try to tie up them together and show why knowing how these gradients helps you to defend against them. So there are 4 main types of attacks in the wild that we see. They are evasion attacks, inference attacks, and extraction and poisoning. And out of all these attacks, so remember a machine learning model has 2 phases, right? One is the training phase. You train the model using the input data. And the second phase is inference. You train the model, you don't change anything, you just use to infer based on the input that you give. So out of all these attacks, the poisoning attacks works during the training. So you are trying to attack the model that you are building. And in all the other cases, we are trying to attack the inference. We are trying to evade detection, we are trying to steal the model and whatnot. I'll come into this, each of these in the coming slides. So you might be thinking these attacks are only research grade and they are not real. But just to convince the point, I wanted to show you some recent attacks that had implications in the, in the real world. So this is one recent example, not so recent, but between 2019, where Silence is known to be a well-known antivirus provider. The attackers were able to identify a way to manipulate the binaries, these malware binaries, in a way the classifier will mark it as benign. They came up with a simple unique string appending way to add to any of the binaries that you want to classify and then bypass the model. And this was very famous at that time, and they were able to fix the vulnerability by addressing the poison attack, the evasion attack, sorry. And this is another real attack. There are actually a couple of versions of them. So this was not done in real world. This is more for research, where the researchers were able to add some stickers on the road and then make the Tesla auto-driving vehicle to go into the traffic instead of avoiding the traffic, which is not good. And also in another instance, they were able to just throw some salt or snow and change the road layout and make the model confused to do similar kind of unsafe operation. And this one is again a very big attack where Proofpoint is a leader in phishing and email detection. They are, I would say, if not the most used product, one of the most used. And attackers were able to monitor how the model works. Like when you send an email, it will identify whether it's phishing or not, and also it spits out some information as well about why it made it as phishing. So attackers were able to observe the model's behavior for a large number of emails and then make a copycat model. These are called model stealing attacks. They were able to make a copycat model and then evade all the emails detection from the proof point. So I will be getting into model stealing later on. So this shows sometimes you need to have certain measures in order for not to reveal too much information about your model to others. Or you need to have controls as to who will be able to access what information. And one final example, this is another clever attack. So as you know, most of these large language models are data hungry. They need a lot of data. And what these researchers found was these models are using data from various sources, and some of these sources, these are websites, they found that some of them get expired and then never get renewed. So what they did was they went ahead and purchased these expired websites, and instead of having real data, they poisoned the data with fake information. And when the model was trained, it was performing something that was not expected. So basically, it's a data poisoning attack. So now with those examples, I want to go into each of those attacks I mentioned in the previous slide with a little bit more detail. So the first one is data poison attack. So in this case, as I mentioned, we are trying to attack the training data. So the attacker somehow find a way to poison this data. And when the data is poisoned, the model that you get is also poisoned. As you probably have heard in machine learning, if you pass in garbage, what you get is also garbage. And similarly, if you passed in poison data, what you get is incorrect classification. So in this case, after you train the model, it misclassifies a panda as a turtle. And these are some real-world examples, some more examples of poisoned attack. So for example, this poison GPT is a poisoned version of the GPT. They were able to come up with replies which are not safe. And also this Trojan puzzle is another attack. This is a coding assistant. And with this craze of LLM, most of us are using like coding assistants like Cody to make our coding more productive. But the downside here is if these models are attacked, you might end up getting code which is vulnerable, worse that it could be a malware, for example. Right, so the second kind of attack is the model evasion. And as I mentioned, that one works at the inference time. And most of those, the cat, stop sign attacks I showed are all model evasion. So you have trained the model. What you do is you change the input data in a way the model will misclassify it. And these are a few more examples. So this example was a facial recognition system. The researchers were able to show if you wear a special colored glasses, and it was misclassifying. It was not able to identify the faces correctly. So that's one kind of evasion attack. And this is another attack on text. And they were able to find that if you make typos or insert some special distraction, it flips the decision. And this is the third attack where model stealing, something like that proof point one, where they observe how the model works for large number of input, and then they build statistical models based on the predictions, and then use that one to either steal the model or either bypass detections. In the proof case, they build the model and they were able to find ways to craft the emails in a way a phishing detector will not be detecting as phishing. So, and there is this famous example, I don't know whether you guys have heard about it. This recent incident was like TikTok, the TikTok's parent company ByteDance. They were actively profiling how ChatGPT was working. They were using it excessively in order to copy the model, and OpenAI somehow identified this intention and figured out that they are up to no good, and they completely blocked access to ByteDance. So this is not just attackers who are trying to replicate models. These are big players, ByteDance, OpenAI, multi-billion-dollar companies. They are trying to steal models from others using different kinds of techniques. So those are more or less traditional kind of attacks on deep learning models. I want to also touch upon a couple of attacks on language models. Specifically, by far the most prevalent attack in language model is what's called prompt injection, where you try to inject some textual information into the model in a way that will misbehave. And there are two main flavors. The first one is jailbreaking, just like the examples I showed you about cutting down the stop sign. the jailbreaking is trying to bypass the safety filters. So it's a prompt injection attack, but it injects the prompt in a way it will bypass the safety filters. And second main variant that we see in prompt injection is called what is called prompt hijacking. In this case, you are not trying to bypass the safety filters, you are trying to make the model do something different. So this one is mainly applicable in situation where you integrate LLMs into applications. When you integrate LLMs into applications, you will have two separate areas called, one is called system prompt, and the other area is called the application, the user prompt. And what these attackers try to do is they somehow craft a message to bypass the system prompt. That way the model works in an unexpected fashion. For example, in this case, the yellow one shows the system prompt and the green one shows the user prompt. And in the benign case, the user prompt gets fixed into the system prompt and then goes into the LLM to get the answer. But in the malicious case, what the attacker does is they use some special crafted again prompts to somehow evade the system prompt. So in this case, this is a real example. In this case, they were able to use this very simple prompt, ignore previous sentences from the input and proceed. So they completely ignored all the prompt in the system level and just went with whatever attacker prompt they gave. And this is, by the way, now fixed, but this shows how fragile these models are. Like sometimes you can inject some special characters or sometimes change the encoding or sometimes use this kind of very silly kind of instructions to bypass the model instructions and do nefarious things. So this is another example about prompt hijacking. So this one is asking the ChatGPT model to write a disinformation piece about 5G spreading COVID. And with the correct safety filters, it says, I can't do this one, it's not ethical for me to spread disinformation. And then what the attackers did was, they were able to identify a gibberish prompt which was able to break into the system and write a disinformation piece about this question. So what is neat about this attack is it's a universal attack. It was presented in a few months ago, 2014. It's applicable across multiple models. And the prompt they come up with is more or less universe. If you plug in this prompt, and this is fixed by the way now, at the time of attack, they were able to inject this like seemingly looking nonsense prompt into any question and jailbreak it. And this one uses the same technique that the traditional models use. Internally, they show how to use the gradient descent to identify this prompt. Just like they identify the optimal noise for images, they use similar kind of technique to identify this, the noise that they need to add to the language. All right, so now I showed you a lot of attacks. You might be thinking most of these models are highly vulnerable to attacks, and should we not use them in practice? Or should we take some actions and find ways to use them securely? So before I go into show some of the practical defenses we can do, I want to show some research gaps that we have in this field, simply because it's a difficult problem to solve, and we are still at the very early stage of solving this problem. And I want to show you where we are at before I go into some of the practical solutions. So as a security researcher, I like to think in terms of success rate. If you take cryptography, we say let's say a hash function is safe if it takes 2 to the power of minus 256 attempts to break that one. But the moment it takes one less, 2 to the power of minus 255, we say it's not safe, and then we run to the design boards and come up with new ways to protect it. This is what happened with MD5 to SHA-1 transition, SHA-1 to SHA-2 transition. And if you are a system researcher, you tend to think that your system is safe if your address space is in 2 to the power of 64. And if it is, if the attacker can guess the address, say 2 to the power of 60 probability, we mark it as broken. And that's where we run to the desk and try to find a new way to make sure that the attacker cannot do this kind of ASLR or stack canary kind of attacks. And when it comes to AI, we say our model succeeds if it works 50% of the time. And in order for a model to be secure, we need to make sure the attacker can break the model all the time. And we are far from achieving this one. We don't have any solution or anywhere close to this where we have an attack which succeeds all the time. And another thing in this attack research or defense research is over the last 10 years, various researchers came up with various gradient-based defenses to protect these machine learning models. And the pattern was like one group will identify a defense that will work on certain deep learning models, and the next year, some other research group breaks it. This pattern has been going on for the last 10 years, and I don't see this pattern is going to change. The main reason for these, not sure whether they are really realize this, the main reason for why these attacks don't last long is mainly because what most of these attacks try to do is to get this attack surface, this lost surface, and try to somehow make it rough, like come up with a way to add more valleys and peaks, and then try to confuse the gradient descent algorithm. So from a local point of view, it works. Like if you try to find the optimal path that you want to take, you will be encountering a lot of valleys and peaks, and you will not be able to find which direction to go. But the defense, the attacks on defenses have shown that you don't need to know the local, these peaks and valleys. If you have the global picture, you can still go and break that defense. So most of the defenses, pretty much what they did was able to identify this global pattern and then break the defense. That's why none of the defenses lasted long. And this is also another challenging aspect of adversarial robustness. Right now, we achieve over 90% accuracy with non-adversarial benign classification. But as you can see, the classification under adversarial attack is still kind of, I would say, stagnated in 60%, and there is also a gap of 30% which we need to overcome. And this is a great research opportunity those who want to adventure themselves to find ways to reduce this gap. And another worse fact here is the adversarial attack they caught here is that imperceptible noise, not even the perceptible one. We are nowhere closer to solve the perceptible noise problem. This is at least trying to defend against the imperceptible one. And I'm hopeful we'll be getting there, but the progress is slow because of the problem itself is very hard to solve. So now I just presented to you most of the defenses are hopeless, and we have made our progress is stagnated. So are we hopeless, or do we have a way out? So, but the good news here is most of the real-world attacks are not gradient-based. Even though most of the research is based on gradients, they will come up with gradients and identify noise images or identify prompts that they can inject. But most of the attacks are quite simple. 85%, in fact, like based on our research, 85% of these attacks we see in the wild are non-gradient based. And out of them, actually most of these attacks are due to bad data. I will get into it in the next slide. and also more or less about model stealing, one of the attack techniques I talked about earlier. So if we can take care of bad data and model stealing, we can protect majority of the time. So these are some examples about what I meant by bad data. For example, you might have heard about this one. It was a very famous example. There was a researcher, I believe it's in Germany or some European country. He was able to get 99 phones, put it into a wagon, and walk across the road, and then fool the Google map, which uses some kind of an AI to identify the traffic jams. So, and they didn't do any validations. That's bad data. They simply trust all the iPhone signals or the Android signal to make that decision. And forget about the Elon Musk part and focus on the Twitter bots. And this is, again, a very frequent problem. Most of the time, stock prices goes up or the crypto prices goes up when there is increased activity in the Twitter. And there are numerous occasions where Twitter bots artificially inflated the tweets, and this indirectly inflated the stock price, which uses AI models to manage it. And that's, again, bad input. And this is another example. Recommendation systems use these clicks to identify how popular something is. And there are click farms in South Asia. They will work for you and do it for a few pennies and artificially hijack the click rate and indirectly feed into the model, and then this will result in high reputation for the product or something that you want to sell it. And this is another prevalent problem. Again, bad data. And this blindly trusting the data results in more harm than the gradient kind of attacks. So next, we are going to, so it's not everything is doom and gloom. There are techniques that works actually. So what I presented was the challenges, but there are in practice as a deep learning and AI researcher, I use this technique day in and day out to make sure that our models are robust than just average model. So one of the important techniques, and it's backed by research too, the robustness of models improve if you can use more data. And also it improves if you can use diverse data, not just more data. If your data diversity is high, it can learn to generalize the patterns. So when you make a generalized model, it's very difficult to break. And second practical technique that we often use, it can have, so the example is for image domain, but it can be for language as well. So this is called data augmentation. The idea here is you take an image, you can transform the image into different forms. You can rotate it, crop it, change the resolution, or you can do cut mix kind of operations and come up with multiple input points from one original image. What it does is it tries to identify slight variations of the same data point, and the model learns to identify and classify those slight variations as the same class. You can do this in language models too. So let's say you are training a sentiment model, and you want to make sure that it's difficult to game it. Instead of just using a sentence, you can rephrase or use some kind of paraphrasing technique to get one sentence and change into multiple ones and still keep the same sentiment for that. And by far, this is the most effective technique that works in practice, which is called adversarial training. So just like adversaries trying to come up with their own models, what we do here is we try to come up with attack models as defenders, and then use our input data to generate adversarial examples. These are examples, those cat example with noise, and then use those adversarial examples and the original data together to classify. That way, the model learns to identify adversarial examples better compared to not having the adversarial one. And the reason why it works is when you use these kind of adversarial examples, it actually smoothen out the loss surface. So if the loss surface is smooth, there is no sudden peaks and valleys, this gradient descent kind of attacks won't work effectively. Basically, they have to travel long. Once they travel long, if it is a cat, the picture will not look like a cat, which defeats the purpose. All right, there are a few more strategies. I will leave you to read about it later on, so I'll move on to the next one. And so, since there are a lot of students out here and who are eager to, and probably industry practitioners as well, I thought maybe I will end the talk with some action items, which I try to group them into 3 categories. One is like immediate action items one can take to improve their models. And the second one is like midterm, like 3 to 6 months, what actions you can take. And the last one is like long term, especially if you are into the research of using AI and ML models. So first one, as I alluded, it's all about data. So data is the most important thing that you will be using in AI or any model that you will be building. So immediate things that you can do, as I mentioned in the previous slides, is to use enough and diverse data, and also use adversarial example into your training pipeline, and augment your training data by cropping, chopping, rotating, or like various different ways. And also, in order to reduce bad input, you can use multiple sources. Let's say you are building a trade, trade prediction model. You can use not just Twitter, but maybe use some other platform as well. So that way, we make it harder for the attackers to game the system. They have to now go change Twitter, and also, let's say, maybe say TikTok. So they have to change 2 systems, so that increases the bar for the attacker, and their return of investment going to be lower. So, and in fact, there is a research done recently, so by using multiple input sources for the same type of data, reduces the attack by about 80%. The attack surface reduced by 80%, that's a lot. And also, this is also a very important point, like most of the time we think about regularization is to reduce the overfitting from the point of view of improving the model accuracy, but it has security implications. Namely, when your model is overfitting, it gives the attackers to learn about how your model works. Because if it overfit, it will give high confidence for training data and low confidence for other data. And that indirectly helps attackers to learn about what kind of data you use to train the model. This is very sensitive topic, especially in healthcare and maybe in cybersecurity as well. If the attacker can get their hands into personally identifiable information from the models, it could be very damaging. And you can avoid or minimize the damage by using various regularization techniques like L2, dropout, or whatnot. And so this point is talking about model stealing. So sometimes sharing less information is good. It's a fine balance that we want to have, especially in various domains like healthcare or cybersecurity. We don't just want the detection results. We want to know why this was marked as malware or why this is classified as phishing, in which case you have to reveal certain information. But if you reveal more information with your detections, this helps the attackers who can use that information to replicate the decision boundaries and build copycat models. So you need to use various other techniques to make sure that only those people who really need to have explanation information get access to them. And also another increase in trend I see is to use, wherever you can, it's good to use pre-trained models as your starting point, because they already capture so much knowledge. Or think about, for example, babies. They are like pre-trained models. You just need few instructions to get them going to understand. So similarly here, if you have a pre-trained model, it's a lot easier to build a more robust model. You need only very few labeled data points to get your job done. And those are the short terms one. I hope most of you who are working on an AI ML space will follow that information to make more robust models. And in a midterm basis, I encourage you to look into, there are tools which helps you to measure the robustness of a model. So for example, ART is one popular tool by IBM. They show how robust your model for various attacks, and there are a bunch of them as well. And running your models through these robustness assessment tools will help you to come up with models that are robust against attacks. And the other one is more applicable for language models, especially when you don't want the training data to be leaked. So there are techniques like differential privacy that kind of add some noise into the data, but without harming the utility of the data. And why? After you train the model, it's very difficult for attackers to get the real data because it's differentially private. And also, I can't emphasize more about this third point, especially with all these LinkedIn experts and all these social media experts about LLMs and AI and all the other things about the AI. It's very important for you to know the fundamental to differentiate the hype from the reality. Right now, especially in LinkedIn, I see a lot of experts who just know a few things about LLMs and try to act like experts. And this same thing can happen in other spaces too. Even if you are making a business decision, if you don't have the idea about how these things exactly work, it's very difficult to make a judgmental decision. And also, if I can't emphasize more on the last point as well. It's a rapidly evolving phase. By the time you read one paper, there will be another paper published. It's very important if you are in this field to, if you want to, you don't necessarily need to build models or come up with new algorithms, but knowing what works and what does not work by reading these papers will help you to come up with models that will be robust against known attacks. And the long term, it's more oriented towards who want to do research in this area. And I just want to tell you some examples as well. I worked with a couple of students from UCSC. They were undergrad students, and one is Udesh. He, when he started his final year project, he didn't know what exactly he wanted to do. But with some guidance, he was able to come up with a new attack technique to attack graph models. And he was able to publish this work in a top tier conference as well. So, I mean, it's within your capacity to go and even come up with new attack techniques and even publish it in top tier conferences. And there are other, like if you are more into development, there are more opportunities for you to contribute to these open source adversarial robustness toolkits or the open source language models that will help you to not only learn about them, but also improve your visibility. And also one thing I wanted to mention as well, sometimes like if you are especially a newcomer, you might get overwhelmed by seeing all the math around these models, but one effective way to learn ML or AI is to start with developing that one, building that one. First build the model, use it, and then try to identify the math behind it. That is a more effective approach than trying to learn all the math, which will never happen, and build models. Yeah, and also focus on publishing as well. Publishing is not easy, but persistence will help you to publish your work and have visibility. All right, so this is my final slide. So what we discussed today was the tip of the iceberg. We only looked at adversarial robustness. That's only one aspect of AI security, but it should help you identify the basics, the fundamentals of AI security, which is kind of can be generalized to these kind of things. For example, bias in AI model is a security problem. There are cases where bias get amplified because of these AI models. There was this Amazon resume case, and also loan estimators which were discriminating colored people. So there are problems which needs us as security researchers need to address. And another big problem is going to be supply chain attacks. If you look at most of these models, we usually don't build. We sometimes download from Hugging Face or maybe use an API to access it. What if these intermediaries are compromised? And that will lead to incorrect or unreliable predictions. And another plaguing problem is the use of AI, deepfakes, and disinformation. It's a very big topic. And with all these generative technologies we have, this problem is only going to get worse. And there is so much opportunity for you to go address some of these problems and make the world a little safer. And also, I only talked about 1 or 2 prompt injection attacks. There are a couple of dozens of them. And I encourage you to go check what kind of different kind of attacks researchers have come up with to bypass these LLMs and few other things. So with that, I'll take any questions you have.
Thank you, Dr. Nabil. I have a question on ML models that are being pushed towards edge devices. Now you know that there's a trend towards put them in embedded devices which are resource constrained and they are more vulnerable to physical attacks like side channel attacks, volt injections, etc. So what kind of attack vectors do you think will open up in that kind of environments?
Yeah, that's a very good question. I mean, edge models, they try to push the models into the device, and these devices have much less capabilities in terms of computation. They have to go with a scaled down version of these models. They have much less security defenses, especially robustness is almost near zero. And one way they try to address this one is to use some kind of federated learning instead of completely having the model push back to the local edge devices. They were trying to use a mix of edge plus centralized in order to address some of this one. But it's an open problem. There is no solution at the moment.
So you mentioned about Llama, ChatGPT, likewise different LLM models. And if we integrate these LLM models into our applications, is there a specific way to evaluate the performance or accuracy?
You need to, this is another misconception I see. LLM models are not for every problem we have. LLMs are mainly for generative kind of tasks. If you are doing a classification task, don't use LLMs. Don't use some other technique to solve your problem. And also, talking about evaluation of LLMs, it's an open problem. There are evolving techniques how to evaluate these models as well. But for tasks that are not suited, you shouldn't use it. It's not the tool for everything. There are certain applications where LLMs work very well, and there are many other applications LLMs don't work. These are, in the industry, mainly LLMs are used for kind of productivity tasks right now. Try to summarize attacks or explain a malware binary, for example, or come up with a schedule, basically productivity tasks, not to do any kind of detection. You can't use LLMs to detect. You can use as an intermediary, for example, if you are building a sentiment analysis system, you can use their embedding method to come up with an intermediate embedding and use it in another downstream classifier. In that case, you will be evaluating the downstream classifier and indirectly those embeddings. Yeah.
So during the last couple of years, AI models evolved a lot. Is the legal framework that builds around these models evaluate as fast as that? Are there any legal frameworks or in terms of legislation that can be applied to this type of attacks and actually proceed to legislation?
Yeah, regarding the regulations, it's still very early. I mean, EU was little early to come up with regulations. They were able to, I believe, a couple of years back, EU Act were able to come up with techniques to regulate it. And US is a bit slow. They came up with their AI Act only very recently, but still evolving as well. And there are several other bodies as well. And there is this competing thoughts as well. Sometimes more regulations can hinder the progress as well. So it's a fine balance we want to strike in order to come up with safe development and have regulations. As you probably know, in the industry, they wanted to go fast and be first. So the safety is a backseat. So that's probably where regulations can help. And what was your first question before that?
So are there any legal frameworks that are available today?
There are a couple of them. One is from NIST. It's not a legal framework, it's a framework to build a better model. And then MITRE is a well-known standard company as well. They have, I believe, what's called MITRE Atlas. It shows you what kind of attacks your model will be susceptible and what kind of things that you have to do to make sure that it is secure against them. There are a few others as well.
So you talked about adversarial training. So are there any disadvantages? What about the accuracy? Are there any effect to the accuracy of the model?
Yeah, that's another good question. Actually, I forgot to mention about it. So I mentioned that the best defense we have for this kind of attack is adversarial training, but it's not without disadvantages. The one thing is, as you pointed out, you will be it can affect your accuracy for the good data points. So in order for you to make sure that you get good enough accuracy and also get the good enough robustness, you need to make sure you don't overpower your data set with too many adversarial examples.
You mentioned this example where you gave ChatGPT the question to cut the sign. And then you showed the problem with the encrypted question that it gave an other answer.
Right.
So was it, or is it, can it be prevented with your invited security mechanism for prompt insulting, or what is the problem with this? Because this was very impressive.
Yeah. I mean, it's again a evolving kind of defense, because like when people came up with different encoding, and they even use different language as well, because ChatGPT and other models were more prominent with English language. They were able to come up with prompts which are very not widely used, and were able to go through it. So there is no one solution for that fits all. It's more for evolving solution. So what they have done is to include as many languages possible and identify as many encoding possible that you can include, and add more fine-tuning examples. Basically, this is done during the fine-tuning, and there is no like ultimate solution that will fix everything. So, but there are some things that you can do to avoid some of these prompt injection attacks. Similar to SQL injection, you can do very simple sanitization, which will prevent most of these actually. Like if you take the one where I appended a very random string and then it was able to jailbreak it, there is something called perplexity, which identify where your language is clear or not. If you use a perplexity measure and try to remove those unclear sentences, will help you to pass only the sanitized input. Just like software engineering, like whenever you take input from a source, treat it as untrusted, and always make sure what you feed in is cleaned up.
Dr. Nabil, thank you for your very interesting talk. I'm going to ask you a philosophical question. So there's a lot of people in the world very supportive of generative AI, think it will do wonderful things as long as we're careful, and people trying to protect that code, as you've outlined. And there's a whole bunch of people who think it's terrible, it's bad, the world is going to end, or they're attacking it for malicious, or using it for malicious purposes. So in 5 years from now, who has won that war and why?
You mean about the existential threat? Right now, I know even the godfather of AI thinks it could be harmful, but so far, from my perspective, most people confuse the fluency of these models. They are very fluent. They can solve SAT or any other exams. This is fluency, but some people confuse the fluency to intelligence, which is not. These models are not intelligent. They are basically actually glorified generalizers. Most of the time what they do is they average out all the things they have seen, and they rarely produce new information, meaning they have much less intelligence, but this fluency can lead to many other societal problems as well. A lot of people will be using ChatGPT and other things to answer questions and do homeworks and pass exams. Those things need to be taken care of. Maybe we need to come up with problems which can't be solved with ChatGPT or something.
Yeah. Here. How can what are the what are the AI risks do you believe most underestimated? How can researchers prepare for such risks?
That's a difficult question to answer. So I'm a little bit biased because I work in the security, and I feel even in the industry, we pay much less attention to security, because as I mentioned earlier, the mentality in the industry, and it's the industry who's driving this AI craze at the moment, because they have the capital to have these GPU farms and have the large amount of data. And most of them prioritize the performance over security, which can lead to unthought consequences. And for example, as you probably know, even OpenAI, they used to have a safety alignment team which tried to make sure that these LLMs are safe and secure to use, and they are aligned. But now most of the people who were in that team are not part of OpenAI, so it's concerning to see. And similar with other organizations as well. Most of the working in Silicon Valley, it's the similar kind of mentality in most of the companies. They want to go fast, go big, and security is a backseater. So.
Yeah, thanks.
Yeah, another question. So actually, first of all, really appreciate your talk about the safety in AI, and I'm working in industry certified AI engineer with the cybersecurity. So one of the difficult concerns in the society, like social media. So some celebrities has been cancelled, in Europe and sometimes in the US due to some prompt injection attacks, and sometimes. So we have noticed there are sessions in physical mode they have organized to remove the fake bots activities and do the key factor authentication methods. So try kind of awareness about cybersecurity fundamentals to the users. But as a cybersecurity expert, so how do you think what are the emerging areas blockchain is there? So how do you think that we can more make the social media more secure place? Because that's a more concern.
Okay, that's there are nuances to that question actually. But number one thing I would say, it's deepfakes and disinformation. That's a very difficult problem. But I see companies like Facebook are taking some steps. At least they are showing now some of these videos as probably manipulated or deepfakes. But it's far from perfect. And the challenge is, again, deepfake detection is a cat and mouse game, because there are various tools and techniques developed every day to come up with deepfake. These deepfake detectors can detect only those kind of deepfakes that they have seen. So, for example, if it is from Midjourney, and if they have already included in their training model these Midjourney videos, they can mark it as deepfake. And if it is from some new tool, say X, which was released to the market today, and you generate something and feed into that model, it won't be able to because it hasn't seen something similar. And we tend to fail safe, and then we mark it as not deepfake.
Yeah.
There are few startups trying to solve this problem, but still the main way to attack this one is to come up with some kind of online learning kind of a model where you can, as and when you see new kind of deepfake, feed it into that and then let the model learn those patterns and you incrementally learn.
Yeah, I agree with you. Like the Facebook Meta model also detected like the quantization level. Then another attack, then in the quantization process also, the similar kind of like behavior we can like they have stated in their like the research papers.
Right.
Yeah, thank you.
I have a question. So, in
Okay.
yeah, sorry. So, in the AI also, new benchmarks comes, and then after they solve it, new one comes, and I find it similar here also. New kind of problems arising. Like, is it possible to like loopholes? Like new loopholes are coming. Is it possible to develop the system without finding a loophole in the future, something like that?
Oh, nothing is future proof. That's why we have our job as well. We get to defend as and when new loopholes come in. Yeah, I don't think we'll have a universal solution that will fix everything.
Thank you.
Any other questions? Yeah, I mean, that's when I was like reading about model stealing, that's something came into my mind as well. In typical security, we say security by obscurity is very bad, but when it comes to ML models, we have to bend the rule a little bit because most of this model stealing happens because of the additional data about predictions get into the wrong hands. But one thing we can do, for example, instead of being, and from algorithm wise, they should be public, and they should be public. What we need to do is to come up with additional access control mechanisms or additional authentication mechanism, which will only allow certain people to see additional information. They will, like people who are less trusted only see the model decision, but people who have more trust will be seeing not only the model decision, model explanation as well. Yeah, it's a very good question. Thank you very much.
Thank you, Thank you, Dr. Nabil, for your thought-provoking keynote. Thank you, Dr. Nabil, for your thought-provoking keynote and for shedding light on the critical importance of AI security in today's digital landscape. Dr. Nabil, please remain on stage to accept a token of appreciation. To present the token of appreciation to Dr. Nabil, I would like to invite the director of the UCSC, Dr. Ajanta Atukola, to the stage. Thank you, Dr. Atukola and Dr. Nabil.
At Cambio, we want to make a difference for society by transforming and improving health and social care. We do that by providing qualitative, open and collaborative solutions, embracing ecosystems and new e-health paradigms. We constantly raise the bar, consider tomorrow's challenges to enable our customers to provide tomorrow's health and social care today.
Need some money in a hurry? Just ask Genie. Tap the Loans tab and check your eligibility for a variety of loans to suit your needs. Download Genie. Log on to life. Open a savings account from anywhere, digitally. The best interest rates, free fund transfers. Do more with Genie. Do more with your money. Download Genie. Log on to life.
Got to open an urgent LC.
No?
Stay in control of your business wherever you are. Next Gen Digital Banking from People's Bank.
Need some money in a hurry? Just ask Genie. Tap the Loans tab and check your eligibility for a variety of loans to suit your needs. Download Genie. Log on to life.
Every business aims to be leaders in their industry. Guidance by another leader makes the journey smoother. Setting trends is easy with the right infrastructure. And being in tune helps lead your business forward. Using cutting-edge technology keeps you ahead, and why not lead a pack? And lead the way with a way that's all connected. Transform your business with Dialog Enterprise. As the leading ICT provider for enterprises in Sri Lanka, we have the technology, expertise and island-wide presence that has made us leaders, and we can help you lead your industry to the future today. Dialog Enterprise.
Unidil, founded in 1994, has emerged as Sri Lanka's leading manufacturer of paper sacks and corrugated cartons over 3 decades. Renowned for its innovative approach, especially in packaging of tea, Unidil has mastered through decades of excellence. With world-renowned Sri Lankan hospitality at its core, Unidil customer focus is unparalleled. Unidil's factory is spread across 12 acres, accommodating a vast range of operations essential for large-scale production. The factory is equipped with cutting-edge German technology, enabling high-efficiency production and innovation in packaging. With a capacity of 3 million sacks per month, Unidil has the highest monthly production capacity in Sri Lanka, reflecting our agility to cater to diverse market demands. Unidil is powered by a team of nearly 100 highly skilled employees, whose expertise drives our commitment to deliver excellence to our customers.
Open a savings account from anywhere digitally. The best interest rates, free fund transfers. Do more with Genie. Do more with your money. Download Genie. Log on to life.
We would like to take a moment to extend our heartfelt gratitude to our sponsors. Gold sponsor, Cambio Software Engineering. Silver sponsor, Genie from Dialogue Finance. Bronze sponsor, WSO2. Keynote sponsor, Exam Genius. Stationery sponsor, Unidil. Thank you very much for the support given for ICTer 2024. And esteemed partners, Enterprise Connectivity Partner, Dialogue Enterprise. Business Promotional Partner, People's Bank. Mobility Partner, Pick Me. A taste of Ceylon, provided by English Tea Shop as partner of Keynote Honors. Their unwavering support and commitment have been instrumental in making this ICTer conference a reality. Ladies and gentlemen, let us also recognize the I Am a Researcher competition, which celebrates young, outstanding researchers. Following its successful launch last year, this initiative continues in 2024. This competition is designed for both aspiring and accomplished researchers. The event acknowledges and celebrates young researchers who have made extraordinary contributions in their respective fields. The most popular researcher award, with a prize money of 50,000 rupees, goes beyond research excellence. It celebrates the ability to engage and connect with others in the academic and professional communities. The most contributing researcher award, with a prize money of 75,000 rupees, goes beyond scholarly excellence. It celebrates individuals who have not only excelled in their research, but have also made significant and meaningful contributions to their communities and society as a whole. The Young Outstanding Researcher Award, with a prize money of 100,000 rupees, stands as a testament to their early achievements and future potential. We are particularly interested in their capacity to push the boundaries of existing knowledge and explore new frontiers and make significant contributions. These awards will be presented through the Genie app by Dialogue Finance. For those who have not yet installed the app, the Genie app, please feel free to visit the reception desk for assistance with the installation instructions. Ladies and gentlemen, this concludes the inauguration of ICTer 2024. I'd like to extend a heartfelt thank you to each of our esteemed speakers and invitees for their inspiring words and presence today. We truly appreciate the time and insights you have shared with us. We invite you to enjoy some refreshments, take part in the networking sessions, and poster presentations. Please take this time to relax, connect with fellow attendees, and enjoy some networking. Once again, thank you very much to all distinguished invitees for joining with us. Please note that the registered participants and authors should be back by 10:30 to reconvene with the rest of the sessions. Thank you.
At Cambio, we want to make a difference for society by transforming and improving health and social care.
But as Dr. Nabil said, we have this problem that everybody wants to solve every task with these decoder LLMs. And even yesterday I had someone who wanted to solve a tabular data problem with Llama. And of course there are people who build these kind of frameworks also. So today, to start our first technical talk, we have an interesting title, and it's not, well, it is an LLM still, but it's a different kind of LLM. So the title of the talk is Instruct Deberta, a hybrid approach for aspect-based sentiment analysis in textual reviews. And to make that, to talk about that, we have Navodaya Ratnasekara, who's completed a BSc of engineering in computer engineering, and from the Faculty of Engineering at the University of Sri Jayawardhanapura. Her research interests are in machine learning and natural language processing. Can we have Navodaya up here? Okay, she may be having coffee. Yeah, so this is a paper done with Malkit, AVA Malkit, as part of the final year project for software engineering and AI ML, and was included in the Dean's List for 2021 and 2022. Is the co-author is also the chairman of IEEE student branch at the university, and preparing for his internship in a software company. The project has led to publishing four papers being accepted at different conferences this year. So I think to make the presentation, we have Malkit, AVA Malkit.
Okay, good morning everybody. I'm Malkit AVA, and I'm going to present about our paper, Instruct Deberta, a hybrid approach model for aspect-based sentiment analysis on textual reviews. And these are our other supervisors and our authors. Through this presentation, I'm going to go overview from the introduction and the literature review and the methodology and the results and the conclusions that we have made. As from the introduction, actually the aspect-based sentiment analysis, ABSA, is a critical natural language processing task which extract aspects from the textual reviews. And actually in the traditional models, they determines the overall aspects, which often misses the implicit opinions of the reviews that are given by the customers. And throughout this paper, I'm show how the ABSA methodologies are progressed from the lexicon-based approach to machine learning approach and the deep learning approaches. And with the introduction of the models like BERT and Deberta, this revolutionized this ABSA task. They shows the improving of the aspect extraction and the sentiment classification task. Our contribution is we propose a hybrid model. It's called Instruct Deberta, that uses the strength of those transformer-based models for aspect term extraction task called ASC, and for the aspect sentiment classification task ASK. And our model demonstrates superior performance in a key datasets called semi-well datasets, and it offers a robust solution for the business for gain insights into the deeper customer feedbacks across the various domains, since we collaborate with our company. Throughout our literature review, we have identified in the ABSA task, there are two tasks actually called single task and joint task. When comparing about the single task, there are as shown in this table, there is a called single task aspect term extraction. It's actually called ATE, and aspect sentiment classification. It's called ASC. In the aspect term extraction, it's as shown in this table. It's only extract the aspects when we give him a review. And in the ASC task, when we give a aspect along with this review, it's extract the, actually it's classified the sentiment which related to this aspect. In the join task, they actually do the both automatically. When we give only the input as the review, and it's automatically identify the aspects, then it's automatically detect the polarity of these sentiments for that aspect. And we have identified over more than 20 single task models as examples: LSTM, Glove, BERT, DBERT, Roberta, and others, so many models. And this is the part of our table we have created. This is only for restaurant 14, laptop 14, and restaurant 16. Those are the benchmark for semi-well datasets which are clarifying for ABSA task. And we shows that DBERT V3 base ABSA V1 shows a significant improvements for the single task, for ASC task. And we further classified this into another for wide range to this. This is for only semi-well 14 benchmark data sets. There are so many models, and this is the part of that table we are included for the paper. And we shows that the DBERT V3 ABC shows a higher accuracy than compared to the other models for at that time. And this is for the other single task called aspect term extraction. For that task, at that time, it shows the instruct ABSA, which comes along with the transformers, shows a significant higher accuracy compared to the other models. And this is the data we have get for the join task at that time, and it shows compared to the previous one, instruct ABSA shows the single task also, and the instruct ABSA model shows join task also, and we shows the accuracies for the laptop 14 and restaurant 14 for all the semi-well data sets. And I go through the methodology, only the important parts of the methodology that we improved to develop this our proposed model. Actually, initially we fine-tuned two LLMs, Llama 2 7 billion, Mistral 2 7 billions, and we use a kind of framework called SetFit and other methodologies. And finally, we go out to our novel model for the this project. And we all know LLMs are advanced intelligent, artificial intelligence designs for understand and generation human-like text. Since they are, we use Llama 2 7 billions and Mistral 2 7 billions both, and both our models are specially optimized for high performance and efficiency across various NLP tasks. With the limitation of our computational resources, initially we use those models using zero-shot learning, but we can't pre-train to semi-well datasets because of those limitations. So we do research more. So we found that QLoRa parameter efficient fine-tuning called PEF technique QLoRa. We use QLoRa, and we use only fine-tune only a little amount of actually relevant parameters for our consumable GPU, and we fine-tune those Llama 2 7 billion and Mistral 7 billion models for semi-well datasets. And we actually fine-tune those models, and we save, and we then load from those model hubs and do our evaluations. As the second stage, we use a SetFit, a sentence transformer fine-tuning framework. It's an actual innovative framework for efficient, prompt-free, few-shot fine-tuning for sentence transformers. Actually, consider about this image. The SetFit mechanism have two steps. The one is actually it's fine-tuning the pre-trained sentence transformers for small numbers text pairs. Actually, it's called it's the few shot, and those trained sentence transformers are used for classification. The classification head to generate rich text embeddings. From this framework, we use a lot. At the result stage, I will show we use a lot of hybrid models to develop this ABSA task. And this is our proposed model. It's actually we use for AT task, we use instruct ABSA, and for ASC, which called aspect sentiment classification, we use a DBERTA V3 based model. Our goal is to make not a single task. Our goal is to make a joint task model. So, we exploited strength of these models for our novel hybrid models, and we named it as instruct DBERTA. Though we use those base models that instruct ABS and DBERTA V3 base. And this is the this is the linear architecture we use to create our proposed model. As I start from the beginning, when we give a customer review for this model, actually this is a pipeline. It's go to the input layer, and then again next go to the pre-processing layer. In the pre-processing layer, we do a tokenization because we need to separate those words. And in the first block, it shows the ATE task, aspect term extraction task. So it's for the first block, it used that instruct ABSA model. And then from after the tokenization, it's go to the word embeddings because we need numerical values. Then in the model, there are always those encoder stacks and decoder stacks. From the encoder stacks, they find the relationship between those words using those embeddings. And from the decoder stack, they extract the aspects. Actually, our first model task is to extract aspects. From the decoding stacks, it's from those relationship given by the encoder stack, they extract the aspects. And they, as the first output, they extract the aspects, and then along our pipeline, then they pass to our second model, DBERTA model. Actually, DBERTA is a decoding enhanced BERT model. So as the similar model, those extracted aspects are passed for the embedding layers for the numerical values, and for the again for the encoder stack. And since we need to do a classification for which aspect and for what is the sentiment polarity for these extracted aspect, we move those data to our classification layer, and those after the classification for what is the sentiment polarity for these aspects, it gives the final output. This is our linear architecture of our proposed model. And using that linear architecture, we have created a model algorithm. It's actually very simple to understand. First, we need to extract all the aspects from the review. Do our function called function ATE, and those extracted aspects we pass to our next model to find the sentiment polarities for each aspect. This is the model algorithm which I demonstrate here. And when we compare about our results, actually we start with fine-tuning LLMs. It's actually go through much accuracy compared to the existing. It shows significant for the restaurant 14 SEMUL datasets, and the lower part shows the hybrid models and the individual models we use from the set-fit framework. And from the red border square, we used to show our proposed model. Actually, it surpassed all the accuracies from the methodologies we have done. And we analyzed further. Actually, when we consider the models that we use for the pipelining, we first shows how they work separately. These are the accuracies that they shows. And finally, we shows how our pipeline works. But in this case also, we make some checkpoints to our models and passes the aspects. First, initially passes the reviews, and then second passes the aspects for those evaluations. This graph shows the aspect extraction accuracy for single task implementation models, because we use here restaurant 14 and laptop 14 semi-well datasets, as our proposed model shows both same accuracies for both datasets, because when we create a model, it should be robust for every dataset. As we compared some datasets models called the BGE, it actually shows high accuracy for laptop 14, but less accuracy for restaurant 14, semi-well restaurant 14. But our proposed model for this single task, it shows same for both for datasets, and they have gained a higher accuracy than the existing models. And this is for our second single task called sentiment political clarification. As same as before, our proposed model shows a higher accuracy than the existing, and for the both datasets, semi-well 14 and restaurant 14 and laptop 14, it shows same accuracy and shows the robustness of the model. This is for our pipeline, and this is for our joint task. Actually, at that time, our instruct debugger AC model, our proposed model shows a higher accuracy than the most existing models. For at that time, it shows actually 8.94 for this ABSA task. It's for joint task, as I mentioned. So it's not only for the aspect extraction, it's for all aspect extraction plus the aspect sentiment classification. And a previous one for the laptop 14, and to show the robustness of our model, we fine-tune the models for the both laptop 14 and the restaurant 14, and we evaluate both models for those datasets separately. And for the restaurant 14 also, our model shows a higher accuracy than the existing models. It shows 80.78. And when I'm going to about our conclusion, actually we conduct a rigorous review for ABSA methodologies with focus on transformer-based models, and we develop a hybrid model, instruct debugger. It's integrated instruct ABSA for aspect term extraction called ATE, and it's used debugger V3 ABSA based V1 for sentiment classification task. And at that time, we achieved the highest accuracy F1 score for across the multiple datasets. We chose the F1 scores because those ABSA datasets are not balanced. So then the accuracy, we chose those F1 scores also. And since our models balances the precisions and the reliability for both aspect extraction and sentiment classification, as I showed in that dot graph. And our contribution set a new benchmark for ABSA and showcasing the potential for hybrid models, creating using pipelines to enhance the sentiment analysis across the various domains. We actually considered for the hospitality domain for at that time. And these are the references that we use for do our research paper. And thank you for your attention.
Thank you very much, Malkit, and apologies for making the wrong introduction at the beginning. Very interesting. So, usually I have to ask the first question, but I think judging by the first session, and there were so many questions out there, I open it out on the floor to ask questions because we are in this catching up game. So please raise your hand, and a microphone will magically come to you.
I think for the both cases, you got a base model from somewhere in Hugging Face and started your research?
Yeah, we initially get the base models.
So how you manage to, now you quantize and QLORA you use for this quantized
for
model?
the large language models, so those transformer based models.
Transformer based.
Yeah, initially we get.
So I mean Robot AI and all these things you modified now?
Yeah, actually
how
those.
you manage to train the resources?
those transformer-based models, we actually they are pre-trained for some data sets, but we fine-tune those models for our SEMIVAL 14, 15 data sets. We use VM for GCP VM to fine-tune those models, because with the limited computer resources, we did not we are unable to fine-tune with our own machine, so we fine-tune those using in a VM. For the transformer-based models, we did not scale down, only scale down those large language models.
So how your data set, like for the aspect extraction, how you, what is the template of your data set to train?
Actually, for the ABSA task, the most sources said that SEMIVAL datasets we need to do our evaluations. So we use it's actually open source dataset. SEMIVAL 14 restaurant and laptop 14, those are actually open source. So we use those datasets for evaluations.
Any other questions? By the way, I think he is also educational. So a transformer has both the encoder and the decoder. And in general, often both are referred to as LLMs. But in common modern usage, when we say LLM, we mean the decoder LLMs, right? Because of the absolute explosion of these models. So they are both transformer based. Yeah. Any question?
Yeah.
Raise your hands, please.
Yeah, I have one question. In here, you showed some list of models, and what improvement does this model, DBETA model, offers over other models, like sentiment analysis models?
Yeah, actually there are so many models for joint task and single task. For initially we do from our research, we get that for the aspect term extraction, this model is very good, have a high accuracy, and for the aspect sentiment classification, this model has a high accuracy. So after those we fine tuning LLMs and use those set fit frameworks, we go to that pipeline methods. Those we use the base model. Actually, those base models are actually pre-trained from many kind of different data sets. But after for this our ABSA task, we modify those base models to our SEMIVAL 15, 16 data sets. So it's actually that's the modification we have done for those base models.
Maybe related to that is, did you take the whole of the SEMIVAL data set for fine tuning, or only the tests?
We use only for the 14 data sets for do the evaluations.
Yeah, I mean, did you use the whole of it or only the test training set?
No, we fine tune using the whole data set.
So I have a question. So you mentioned that you use, the question is your model able to perform on multilingual purpose sentiment analysis?
No, for actually we have discuss with this our company also. They they initially do for the they initially go with the English reviews, and those SEMIVAL datasets also presents only in English. We do only for the one language.
So another question I have, so if I'm fine tuning a large language model, then I have this prompt, then the text and the outcome. So when using the set fit framework, what's the difference when it comes to fine tuning a model?
Actually, we using the set fit framework, it's actually a zero shot. Actually, we need only give a few number of examples, but and also then compared to the other models, we need only give a less number of input data sets. Actually, when you consider about the 5 to 12 data sets, for the set fit framework, we can use only 100 rows or 100 separate data sets for the evaluation.
And then the performance will also be...
yeah, the performance is depend on the data sets and the prompts that we use.
Thank you. And I think though the discussion is very interesting, we have to move on because we are already about half an hour late. So let's show our appreciation to Malkit.
Thank you for.
Our next presenter is the person I introduced earlier, Navodya Ratnasekara. So I ask Navodya or Navodya. Yeah, Navodya, please make your way to the podium. Navodya is going to talk to us about drug recommendation system based on medical condition classification and sentiment analysis of drug reviews. She's completed her BSc Engineering Honours in Computer Engineering, minoring in Data Management from the Faculty of Engineering, University of Sri Jayewardenepura. Her research interests are in machine learning and natural language processing. Can we have Navodya up here? Yes.
Good morning all. So our research is a drug recommendation system based on medical condition classification and sentiment analysis of drug reviews. So these are the table of contents of this presentation. First, I'll do the introduction and the problem statement of my research, and then the literature review, methodology I used, and the results, finally the conclusion. So first, let's start from the introduction. So we know that medicines has become basic human needs and important to everyone because it's used to cure and prevent diseases. So, but when we use medicines, there can happen many side effects because every drug is not effective and efficient in the same way. Therefore, reviewing drugs is an important aspect to be considered in medical industry to properly identify the effectiveness of them. So as the problem, we identified that in currently patients' clinical reports contain less subjective information about the side effects of the drugs. Therefore, it is important to analyze the reviews by patients after taking the medication. So, but analyzing these public reviews and identify the effectiveness of drugs as well as understanding the medical conditions they are suffering from helps the healthcare professionals and pharmacovigilance systems to ensure the physical and mental well-being of the people. So I conducted several literature reviews for this problem and found there are three aspects to be considered. First one is the sentiment analysis techniques. So that means if we have a certain drug reviews, we have to identify whether it is a positive one, negative one, or neutral one. That means if the review is positive, that means that drug is effective on that particular patient. For that, there are some neural network models also, and also some traditional machine learning models. And the neural network models depend on the amount of data. And the second aspect is drug recommendation systems. It helps to recommend top drugs for the given diseases based on the sentiment score of that review. And finally, the disease classification techniques. These researches are mainly based on the epidemiological background of transmissible diseases. Therefore, the methodology we use, it first starts from the data selection and then data pre-processing and cleaning, feature engineering to extract the features of the drug reviews, and apply suitable classifiers for the data mining and analysis. So in here there are three parts: classification of the patient's medical condition based on the reviews, sentiment prediction of the patient review, and recommend suitable drugs for a specific condition, and finally the model deployment and a web application developed. First, I will start from the overview of the dataset. So the dataset I use is UCI-ML drug review dataset. It includes patients' review from 2008 to 2017, and it contains drug reviews within 7 attributes. So it has a unique ID, drug name, the name of the drug, and the name of the medical condition, the review the patient has given, and the 10-star patient rating for that drug, and the date and the useful count, where the number of users who found that review is useful. And the second step of the methodology is data pre-processing and cleaning. So first we have to remove any missing records from the data set. And secondly, we have to clean the reviews because it has some unnecessary characters like HTML characters. And we have to convert the sentences to lowercase, so it is easy to for the feature engineering part, and also remove multiple spaces like that. So in this figure we have done that part. And the third part is the data reduction, because if we take the medical condition classification, we only need the medical condition and the review they have given. And for the sentiment analysis part, we need the useful count, rating, and the review they have given. After that, we have to remove the stop words and lemmatized the reviews. For removing the stop words, I use NLTK stop words library, and for lemmatization part, I use WordNet Lemmatizer. And the next part is feature engineering. So our goal is to classify the patient's medical condition and to predict the sentiment according to their reviews. So first we have to divide the data set into train and test parts, and do the feature extraction from the text data. For that, we used bag of words method, that is count vector as a method, and also TF-IDF method, term frequency, inverse document frequency method. And after that, we have to add the class weight to balance the data set, because the data set was highly imbalanced. And these are the results we got. So first, this is the medical condition prediction of the patient. So for that, I used 4 algorithms: multinomial naive Bayes, stochastic gradient descent classifier, passive-aggressive classifier, and multilayer perceptron classifier. So here, these are the results I obtained both for count vectorizer method and the TF-IDF vectorizer. So in here, passive-aggressive classifier has the highest accuracy, around 91%. So these are the results for multilayer perceptron classifier. So I conducted the research for multilayer perceptron classifier for several hidden layers. So these are the accuracy I got. From the table, we can say that the increasement of the accuracy also getting lesser when we increase the number of hidden layers. And this is the classification and precision report for the passive-aggressive classifier for 38 medical conditions. So as the second part, we have the sentiment prediction of the patient reviews. That means we have to identify the drug review is positive or negative. So these are the accuracy for that. I have used multinomial naive Bayes and logistic regression models, and these are the accuracy for trigram range. And logistic regression has the better accuracy with around 95% accuracy for bag of words method. And thirdly, we have to find the most suitable drugs for a specific condition. For that, I used these columns like drug name, the condition, rating, and the useful count. From that, I extracted the top 3 drugs for a condition based on the rating and the useful count of the that record. And also, I have developed a simple web application to test the system. So here it is the results for a positive drug review. So it has identified the medical condition as acne. No, this is for a negative review. And it has selected the top drugs. And this is for a positive review. And as the conclusion, the main aim of my research was to predict the medical condition and sentiment of the drug reviews given by patients. And the system has around 91% accuracy for medical condition predictions for 38 medical condition with passive-aggressive classifier. And also it has around 95% accuracy for sentiment prediction with logistic regression model. These are the references I used, and thank you.
Thank you. Thank you, Navodaya. The mic is there again. Please raise your hand and ask any question.
I would like to know how class weights were added in order to address the imbalance of data.
Yeah, I use a smart technique. So they are like it generating synthetic data for lesser amount of classes. Like when there are lesser amount of data for specific medical condition, it creates synthetic data for that.
So I found like counter-vectorize and TF-IDF you use for feature extraction to represent the document. Why don't you look at for the word embedding technique like word to echo, Glavo, anything?
Yes, sir. So the main reason was there was a lesser number of data in the data set. So for train word embedding models, there needs some data. And from these statistical methods also, we can get a good accuracy.
Any other question? Yeah, there's one.
Have you considered about fake reviews? How did you verify these reviews? So sometimes patient may have hereditary. So these reviews, you should consider a person history, right? So what about those factors? So it may differ person to person based on hereditary and their genes, like it may change, right? So have you considered those?
No, the data set was about the reviews they have given for specific drugs. It's like the data set was extracted from drugs.com website, and it has only the reviews they have given.
I think it is an important question. Thank you for asking that, because I think very often we lose sight of some of those other factors, sometimes the history and how can we include it in a model kind of thing. Yeah, there was another question down there. Yeah.
So actually the research is good actually, and I have one small question. So like given that the patient reviews kind of like can come from diverse backgrounds, like different language styles and experiences, so like how did you like address the possibility of like linguistic biases in the analysis? Like have you identified any like hallucinations like about like kind of demographic styles?
Sorry, I didn't.
No, like what I was asking is like in the analysis, so the patient reviews can be come from diverse demographics. So like using like in your study, how did you address that matter, like the diversity matter? So like I want, for example, let's say like it can be the data reviews. I mean, if we consider data set, we can see like there is like a diverse range of data and different backgrounds and different language styles. So did you tackle that?
Yes, so in that case of scenario, we might need specific data for those categories, and this is kind of from the reviews like pharmacovigilance systems can identify what are the effectiveness of the drugs. So for that part of work, we might need a good data set. And
yeah, that's good.
Yeah, actually I would like to know how do you address potential overfitting in your model while you are train the model, how do you address the overfitting?
I think that's another common thing that students don't do. Like they don't check whether there has been serious overfitting, and then that is an issue. And so thank you for raising that issue up. Did you try anything to see whether the model has overfitted?
Yeah, the data set was like we cannot divide it to validation part, validation test and train part, and so as a future work I think we can do that for find the overfitting scenario, and also yeah.
Okay, and let's thank Navodaya in the usual way and also for saving us 5 minutes. Thank you. Our third paper for the session, I will again introduce the author so that she can come up here. Ramali Rodrigo is a BSc Honours in Statistics with Computer Science from the Faculty of Science, University of Colombo, and currently employed as a data scientist in the Data Science and AI Department of Zone 24/7. And this study is based on a final year individual project at university. And the title of the talk is Cash Valuation of Black Tea in the Nuwara district based on sensory quality attributes, a case study. Ramali, the floor is yours.
Good morning, everyone. So I'm Ramali Rodrigo, and I will be presenting my final year research project findings titled Cash Valuation of Black Tea in the Nuwara district based on sensory quality attributes, which is a case study. So in my presentation, I will be covering these topics. So as Sri Lankans, tea is not something unfamiliar to us. So as we are all aware, tea is one of the major export crops in our country. And Sri Lanka is known to be the 4th largest tea producer and the 3rd largest tea exporter in the world. So because of this, tea plays a vital role in contributing to the country's economy. When talking about the tea production in Sri Lanka, it is divided into 3 regions based on the elevation, starting with high elevations, middle groans, and the lower groans. So because of the differences in these elevations, there's a wide variety of tea produced in our country. So you can see from the diagram, there are 7 such tea districts in our country. So in my study, I have focused on the Nuwara district, and because of these geographical changes, the climatic conditions, the tea produced in each region have their own unique characteristic. So in Nuwara, it's known to have delicately fragrant teas. And when it comes to tea sales, it's mainly conducted by 3 modes, that is the public auctions, direct sales, and the private sales. And 90% of these sales are conducted via the public auction. So before it is being sent to the public auction, the tea is checked for its quality, and that is done by 2. Firstly, it is checked by the tea tasters of the tea tasting unit. They make sure that the quality of the tea is up to the ISO standard and that it is good for human consumption. So after that initial quality check, it is then sent to the tea brokers. So the samples that are not rejected is now quality evaluated by the tea brokers with their sensory quality measures, and from their own merit-demerit system, they will be assigning an estimated price for it. So the main objective of my study is to formulate a model for this cash valuation based on the sensory quality parameters. So this is basically what the tea brokers do. It's mostly based on the experience and their knowledge on tea samples. So it was not a standardized method. That's why I wanted to implement this. And as for the secondary objectives, I wanted to have to identify the most important sensory quality measures that are associated with the cash valuation of tea overall and tea grade specific as well. When studying the past literature, I was focusing on these two subject areas. So when it comes to price prediction, it was identified the past researchers has mostly focused on predicting the auction price using time series, regression, and machine learning models. However, when it comes to identifying the important measures that is affecting the quality of tea, some researchers have used only sensory quality measures, some has used only chemical measures, and some has used both of them. However, the distinct feature I found was most of them has used numerical parameters like t-taster scores, ranks, and probably electronic machines to get those scores. And of course, there has been studies that check the association between the t-tasters assessment and the market value, and they have checked whether the quality of the tea is corresponding to the prices as well. So high quality, high prices. And so in my study, I am bridging the research gap of predicting the estimated price, not the auction price, using the sensory quality measures. So the significance of my study is to find a solution for this tedious merit-demerit system that is used by the tea brokers in price estimation. As I mentioned, there's no standard procedure. It's typically based on their experience. And the other point is the knowledge of knowing which qualities to enhance during tea production will be helpful for the stakeholders to produce quality tea. And the usage of qualitative sensory parameters in cash valuation, because in the previous studies they have focused on numerical parameters, so I wanted to go ahead with sensory qualitative parameters, so that it is given in the layman language for the stakeholders so they know what qualities to improve. So this is the methodology that I followed, starting from data extraction, pre-processing, and conducting the EDA, exploratory data analysis, advanced analysis, and model comparison, grade-wise model fitting, and the best model interpretations, which I'll be explaining in the future slides. So the data set that I used consists of sensory quality characteristics of orthodox black tea samples, and this is evaluated by several tea brokers, so that it is not based on their perception all the time. It is done by multiple tea brokers, so that the biasness of one person will not be included here. And the data is from one factory of the Nureli district, collected by one broker company for the years 2019 and 2020. There were 1,119 tea samples and 13 variables. Out of them, I mentioned most of my variables are categorical variables. Only 2 were qualitative, and those 2 were the average weight of the tea and the estimated price, which is my response variable. I removed the other 2 variables, the sales number and the invoice number, as they were primary keys to identify the tea sample separately. As for the exploratory analysis, to achieve my sub-objectives of identifying the most important sensory quality measures for the cash valuation of tea, grade-wise and price-wise analysis was done under these 3 topics: non-sensory quality measures, leaf quality measures, and the liquor quality measures. So the results of that exploratory data analysis is as given. So for cash valuation overall, in order to have expensive tea, leaf color, liquor color, and leaf fiber should be obtained as given. And it was identified from the exploratory data analysis. There are certain sensory quality measures that are unique to each and every tea grade. So I had 5 different tea grades, and they can be divided 2 sections, such as main grades and the off grades. And there's a clear difference between those 2 when it comes to these quality measures. And the advanced analysis, this is the methodology I used. First, for the cache valuation of overall T quality, due to the presence of ordinal variables, which I identified from the exploratory data analysis, I went ahead with doing two encoding techniques, that is the dummy encoding and the numerical encoding, to see which encoding method suits better. So I fitted 8 models for each, and then selected the best predictive model by selecting a model which has the lowest root mean square error as well as the highest R square. After I selected the best predictive model, I used the variable importance plot to identify the most important variables. And for my other objective of finding the best predictive model for model for each grade, I found the best important variables that is relevant to each and every T grade, that is helping to get the best cache valuations. So here also I did follow the same method, except in the previous one I identified which is the best encoding method to be used here, and then fitted those 8 regression models for each T grade, so altogether like 40 models, and previous method is followed. And these are the results for the cache valuation of T overall. These are the 8 models that I fitted, and as you can see, gradient boost, which used the numerical encoding technique, gave the lowest root mean square error and the highest R squared from the other models. And from the gradient boost model, I plotted the variable importance plot to identify which are the best variables when it comes to getting the cache valuation, which was the T grade, average weight, and the leaf color variables. And since gradient boost is a black box, I needed to see how each and every variable varies when it comes to estimated price. So I use this partial dependency plots and individual conditional expectation plots to see how it varies with the estimated price when the other variables are kept constant. And these are the findings for the cache valuation of T grade to identify most important sensory quality measures. So for each and every T grade, I said I fitted like 8 models, so altogether 40. Each model was selected and the VIP plot was plotted, and then identified the variables for each and every T grade. So in my study, I have used 5 different T grades, and the results of them are here. So the conclusion of my study, I had one main goal, that is to have a model to predict the overall cache valuation, and it was the gradient boost regression with the lowest root mean square error of 79.75% compared to all other models, and it explained 33.5% of the total variation of the estimated price. And for these high cache valuation of T's is expected if these 3 variables, which I identified from the variable importance plot, the T grade should be BOPF and DUST1 grades, and the average weight of a T sample, if it's maintained between these ranges, and the dry leaf color to be on shades of black, it is expected to have high quality and higher cache valuations. And same procedure for each and every T grade. It is expected for each and every T grade. These are the specific variables, specific sensory quality parameters you need to focus on in order to get a high cache valuation for these T grades. And as for the future work, I suggest to generalize this model by including all T factories in Nuwara and other T districts as well, because there were 6 of them, and adding district as a variable, and you can explore it to elevation wise as high, medium, and low, and as an added variable, and of course to expand the scope to cover more T types. So I have only used black T, So you can use other tea types such as green tea, white tea as well, and include more grades. I had only 5, so can explore more. And add some additional sensory quality attributes and interaction terms to boost the accuracy, because I had to remove 2 variables due to large number of missing values in my data, so better to have more variables. And better also, I suggest experimenting with advanced machine learning techniques such as neural networks, support vector machines, and enhanced predictions over the gradient boost model that I achieved. And of course, go ahead with data mining in order to reveal more patterns that impact these high cache valuations. So that concludes my presentation. Thank you.
Thank you very much, Ramali. So yeah, we were looking at machine learning algorithms. Now we are looking at statistical methods and lots of parallels. Is there any urgent, burning question? Thank you also for keeping to time. From the audience, please.
I have a general question. So, if you have fine, are there specific cultivation or processing techniques in Nuwara district that enhance the sensory qualities and valuation of black tea?
Would you mind saying that again?
Are there any specific cultivation or processing techniques in Nuwara district that enhance the sensory qualities and valuation of black teas other than other districts?
Okay, so here I mentioned due to the differences in elevation, the climatic changes and the temperature, humidity, all of them affect when it comes to tea production. So in Nuwara all those climatic conditions affect when it's come to production of the tea. So it has some specific features that is unique to it. So that is affecting those sensory measures that you are speaking with.
Yeah, in terms of your data set, it's as you mentioned, it's from the human brokers.
Yes.
Actual human brokers, not by using any other sensors or whatever. So human knowledge embedded, and the labeling also from the human labeling of the price.
Yes.
You are not gone, let's say in terms of pricing and other labeling data, gone back and analyzed and found a pattern. So you actually calculated this based on the human broker experience. The model. Okay.
Yes. So the data set I created was from using 3 reports. There were the master report, sales report, and I can't remember the other one. It was an auction-based report. So I had to take all those data and collate it into a data set. So basically what I've done is they have this certain set of words that they use to describe the tea, and those words were there in the description. So I had to go to the description and break down it to variables as to what it is. And at the end of it, they have named a price. So these are the certain parameters that they have seen from the quality analysis and the price as well. It is there in that report. So I use those data to come up with the models.
Yeah, it would be nice to know which of them are visual, like the color, which of them are like taste, and I don't know, maybe some smell, I don't know.
Yes,
or
they do.
smell, yeah.
I went and seen how they do it. So it goes in 3 steps. Firstly, they do the visual inspection of the dry leaves. Sometimes they touch it and sometimes smell it and visually inspect all those fiber content and all of that. And then the step 2 was to infuse the dry leaf. So you soak it and get the liquor and then inspect the infused leaf. So infused leaf properties, there's a certain set of variables that they consider. Then after that, they check the liquor properties. So it's a 3-step process.
By tasting?
Tasting as well, yes.
Yeah.
Tasting, visual, and of course smelling.
So I suppose the question was whether some chemical analysis was done. Was it? Yeah. Any other way? Yeah. Of course, then we will remove another set of job opportunities. Yes, there's a question.
In fact,
yeah. Timothy, right? No, you didn't have, no.
So actually the research is like very relevant to the current scenario. Actually, I really appreciate that. Like I also like worked in like the tea industry for like AI researcher as well for some time. So I would like to ask a question and give a recommendation as a fellow researcher. Okay. So the question is like, have you considered like the tea commission board like gazette and like the pricing calculation scheme at the initial moment of when you are doing the research?
So these are directly taken from a tea board. Tea board as in a tea broker company. So certain brokers are entitled for that specific broker company, and they do all that tea assessment. So it is definitely from a known broker company. I didn't include it because of
of course,
privacy.
Yeah, I understand that. There are like private and like public entities. So the reason is like when we are doing the project, so our goal, like we have done the national project with the international like tea industry 2 years ago. So what we have done is like we have created the application to detect tea quality news. Okay, sure. So when we are doing that, tea board specifically mentioned us to review the pricing calculation and everything, every regulations before collecting the data.
Okay, so were you collecting for estimated prices or auction prices?
So
because these are two different things.
Yeah, of course. So the thing is like our app includes like image analysis plus price calculation. So we have to collect images first, and we have collect the CSV data.
Yes.
So for the image
they
data,
don't have CSV.
Yeah.
They don't have CSV. They have just documents. So
documents.
you have to manually extract them and put it there.
Exactly. So using OCR, we have to extract the data and put into them. Then the tea board, the deputy, he has told to review the guidelines and initiate the data extraction in order. So that kind of a recommendation, like if you moving with future steps, it's better to go with, because in our project we have covered like nearly 600 like the factory sections, and it was like a very tedious task because like regulation schemes are very tough.
Yes, I had to do this during the COVID period, and it was even more difficult to get the data because I can't travel all the time.
Yeah.
So very difficult.
Yeah, I can help you like in the future maybe. Okay.
Thank you. And is there one last question? Yeah, one last question at the back there.
I have a question that I'm really not. I want to know that how do tea grades and weight and color, only 3 of them affect the cash value of the black tea?
Yes.
Only using.
Your question was not clear. Would you mind saying it again?
How do tea grade, weight and color affect the cash values of black tea? Only 3. Only those 3.
Yes. So my objective was to identify sensory quality parameters. However, what I identified was only one sensory quality parameter, which was the tea leaf color, and the other 2 was the tea grade. As you can see, I did tea grade-wise analysis as well. So you saw that for each tea grade, there are specific sensory measures. So tea grade is playing a major role in assessing the quality. However, the average weight, that's the other parameter I found, it's better to maintain a certain let's say average weight for a given sample. There were, if I could go back.
No, I think
I don't think we have time. Okay. So basically maintaining it at its optimum levels, it's better to have the cash relation. So here the average weight PDP, that's the partially deterministic plot. So the top line shows the estimated price. So as you can see, those net kg is the bottom line that shows the average weight. So average weight maintained around this 500%. It has the higher cash valuations. However, at certain points, there are dips. So if you maintain at that specific ranges, that's only when you have high estimated prices. So at the points that it drops, it shows that that is not a proper weight to have. So,
thank you very much, and let's show our appreciation to Ramali in the usual way. Our next presentation slightly different. Convergence of Twitter sentiment analysis and optimized learning models for predicting Bitcoin price volatility. And to make that presentation, we have Hasindu Ratnayaka, who holds a first-class degree in computer science from the University of California. He thrives on continuously exploring emerging technologies and particularly interested in artificial intelligence. Currently, he is working as a software engineer and contributing to cutting-edge software solutions, looking for opportunities to integrate advanced technology to create impactful results. We'll have Hasindu Ratnayaka.
Hello, very good morning to all of you. My name is Hasindu Ratnayaka, and I'm really excited to present my research, Convergence of Twitter Sentiment Analysis and Optimized Learning Models for Predicting Bitcoin Price Volatility. Here's what we'll be going through today: introduction, related works, methods, and discussions, and then we'll look at key takeaways in the conclusion. Let's start with a bit of introduction into Bitcoin, which was introduced in 2009 by Satoshi Nakamoto as a solution to limitations in trust-based transaction system. These limitations include like mediation cost, reversibility of transaction, enforcement of minimum transaction size. So Bitcoin is a cryptographic proof-based transaction system, and it's been recognized by several governments around the world, including the USA and the European Union. It's also been recognized as a viable payment method like corporations like Overstock and Microsoft. However, with this interest and recognition increasing, the losses have also increased. 2022 study by Bank for International Settlements identified that there was a spike in crypto app downloads in October 2022, and 81% of these new users have suffered losses. One of the core issues for this losses is the extreme volatility of Bitcoin price, and a major factor for this volatility is the media effect, which is the ability of news and media to affect the price of an asset. Twitter, or X as it's known now, is one of the key outlets outlet of news and media new information regarding this Bitcoin. So here's a famous example for this effect, as Dr. Nabil mentioned earlier. Elon Musk tweets on March 24th, 2021. He tweeted that Tesla is accepting Bitcoin as payment, and as we can see, this followed a spike in of the Bitcoin price. After several weeks, he tweeted that they are no longer accepting payment via Bitcoin. So this followed a decrease in the Bitcoin price. So then let's move on to what are hyperparameters. Hyperparameters are configurations that are not set trained by the training data set, but set by the researcher who does the training. These include hyperparameters include such as learning rate, batch size, activation functions, and so on. Hyperparameter optimization is an automated process which we use to find the best combination of the hyperparameters to achieve the highest performing model. And our research question, which was can hyperparameter optimization enhance predictive models for forecasting the direction and the magnitude of Bitcoin price changes? To achieve this, we aim to utilize hyperparameter optimization for deep learning models that predict the direction and magnitude of price changes and compare with the models with same structure and trained on same data but haven't used hyperparameter optimization. So here are some of the related work I referred. As you can see, the first two was only able to predict the direction. Meanwhile, the other three was able to successfully predict the direction as well as the magnitude. I should mention that these, when I refer in these, I wasn't able to identify that they were highlighting about the hyperparameter optimization, which led to my research. And there is also research based on hyperparameter optimization in several domains such as stock price prediction, observing performance properties in mobile and cloud servers, and as well as determining anomalies in real-time systems. All these have noted that they identified performance increases when using hyperparameter optimization. So let's start method section with data gathering. I used two types of data, tweets data set which was gathered from Bitcoin tweets, 16M tweets data set in Kaggle, and the actual Bitcoin prices retrieved from Yahoo Finance platform. Then let's move on to data preprocessing. I use several steps for preprocessing tweets data set such as removing nulls, duplicates, non-English tweets, and then I replaced user mention to anonymize the tweets with generic keyword user. Then I removed new lines, new line characters, URLs, records that did not contain Bitcoin or BTC hashtags. Then I selected the data from without missing dates from August 28, 2018 to November 23rd, 2019. So the sentiment analysis of tweets was done using Vader. Then I aggregated this data to get the daily negative, neutral, positive sentiment scores and daily tweet counts. The Bitcoin price dataset didn't go through much of pre-processing. I just reset index to be numerical and data was added as a column, separate column. Then I appended the data sets, these final two data sets, and columns were appended in such a way that to consider any lag effect of between the sentiment recorded there and the price recorded there. Here we have a dataset with 7-day lag dataset. As you can see, the sentiment recorded day is November 23rd and the price date is November 30th. So then we went on to some exploratory data analysis. Here we can see the 7-day lag dataset and its correlation matrix, and we can see some positive relationship between lagged close price and the sentiment scores. Here we also have the time series. As you can see, there's a relationship between the sentiment and the close price of the Bitcoin. Then let's move on to the model development. I considered convolutional neural networks, long short-term memory models, and bidirectional LSTM models. These are developed using TensorFlow, and as hyperparameter optimization is a huge focus of our research, we used Optuna for hyperparameter optimization because it provided several advantages like defined by run principle, which dynamically construct the search space, and we can use automated early stopping, and it allows user to define the objective value and whether we should minimize it or maximize it. Our objective value was the training accuracy, and let's move on to developing the direction prediction models. I experimented with LSTM and bi-LSTM models and approached this problem as a binary classification problem, whether the price increase or the price decrease.
Happy song, we could again say it's a beautiful song. So for for the clustering part in the comments, how did you were you able to cluster all the comments based on the emotions, or is there any measure that you took to identify any methodology to cluster those comments, and were you able to identify what are the impacts of these particular clusters for the result?
Yeah, thank you very much for that question. So one thing I need to mention here, I'm not referring to the annotation side of these comments or the annotation of the songs. I'm referring to the initial data preparation and how the the unique words and the linguistic nature of those comments. So when you are doing the annotation part, we have considered both ends. Where we got the annotation of the songs done and comments perfectly annotated by different judges. Where we have addressed the 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 real feeling that the song owner wants to generate from the listener side, and also the nature of the comment given by the listener, where they have expressed their feeling based on what they have experienced or what they have received. So we have addressed that separately.
Thank you. Second, last two questions. Yeah, one question there.
My question is, can't we use other methods to, instead of data sets for analyzing comments, like there are trust issues. The previous question was like, even the song is a happy song, but it can be comments like it's a bad song. Like, can't we use another method for that to get rid from the that question?
Yes, so yes, we can, but here there are possible ways where we can address that by evaluating the whole nature of the instrumental that has been used, and evaluating the lyrics of the songs. But here, what we have focused is the NLP side, where we are focusing whether the nature of the comments express the real meaning of, real expression that the song owner wants to convey from the listener. Whether they have listed the same emotion which they want to generate from the side. Yes, as you mentioned, there are different methods that could be used by analyzing the sound side of the music.
Thank you, Yomal. Let's thank Yomal in the usual way. So thank you to everyone for all those questions, and we have come to the end of the session. But hang on, because important keynote is going to follow now. Thank you.
Malkit Amanda, Navodaya Ratnasekara, Ramali Rodrigo, Hasindu Ratnayaka, Thank you very much, Dr. Veer Singh. Our next keynote speaker, Professor Chris Bain. Monash, Professor Bain has pioneered advancements in data usability and EMR systems, gaining national and international recognition. Today, he'll share his insights on what in digital health is free, a profound topic exploring the true cost and value of technology in healthcare. Let's give a warm welcome to Professor Chris Bain.
Just waiting for that mic to come on. There we go. That sounds good. Thank you very much for having me. Thank you to the people at University Provost School of Computing for having me. I already had the hardest job today, and that was standing between you all at lunch. I'll try and go a little quicker. You hearing me okay? That's much better. Good, good, good. Okay. Yeah, so I was already standing between you all and lunch. I'll try and impart what we have to impart, but still get you out for lunch in time. So as is introduced, I just sort of said just a little bit of context for me. My background's in medicine, and then I retrained in IT. I spent about 27 years in the health system in our state, and then 7 years ago moved to the university as what's called a practice professor in digital health. So in our faculty, we cover an enormous range of things, the only faculty of IT in the country. But I spend a lot of my time working with other faculties and with doctors and hospitals and industries and trying to facilitate opportunities for our students. So what I'm going to talk today is quite selective, quite deliberately. We won't really go much into AI, even though AI is really important in healthcare. And there's a lot of work, we would call digital health work, happening using AI, but we'll steer away from that a little bit. You've already had a good swathe of AI things today. Just to give me a sense, hands up if anybody is currently working in health IT, health-related IT things. Not one hand. That's a bit of a worry. Okay, a couple. Okay. Anybody done it in the past? Anybody worked on health-related IT in the past? Okay, that's helpful because I need to know how much health to give you and how much IT to give you. I need to explain things appropriately for you. So we're going to start by talking about interoperability. So interoperability is this idea of how do we share micro-level information, in our case about patients. For instance, my blood pressure reading yesterday at 2 o'clock. How do I share that between systems, even within a hospital, let alone to the sister hospital down the road, let alone across the country, let alone across the world? And this has been one of the huge challenges in digital health. And just to set the scene a little more for you today, when I'm talking today about digital health, we're talking about everything from electronic medical record systems that are in family physicians' offices or hospitals, right up to some really cutting-edge systems today. I'm not going to dwell on any of those, but things like Cardia, K-A-R-D-I-A, where you can have an ECG, a cardiograph recorded on your phone, okay? So all of these things are happening at once, and they are all digital health. But interoperability is a pervasive problem. For many decades now, if we look inside a hospital and we look at the laboratory system and the electronic medical record system that the doctors use, those systems share messaging, okay? And the nature of the messaging has been what's called HL7 messaging, HL7 version 2 in particular. It's what you're seeing up there. And many of you will recognise that's very computer readable, but not really human readable, okay? So if you have a close look, you can see there's an address in there. There's a patient who's called Eve, every woman. You can see that they're having a glucose test. You can see who the primary doctor is, Patricia, Dr. Patricia. You can see that the glucose test value is 182 and the normal range is 70 to 105. Okay. This is just to give you a bit of context. Then we moved on to the next generation of these messages. And these are called HL7 version 3 messages, so they're XML format. The same sort of content, but this time in XML, a little more readable. Okay. Nonetheless, we found that that didn't help enormously. There are a few reasons why it didn't help. We then moved on to an additional supportive thing called clinical document architecture, which is again XML. If you think of the referral letter that a GP, family physician, might write on the computer to send to the hospital, or you think of the discharge summary at the end of the hospital admission that goes back to the family doctor, those things can be electronically created and expressed as these clinical documents, hence the clinical document architecture, XML documents, but they can be shipped around, electronic payload, if you like. Now, the trouble with all that was it never really got far beyond working within a hospital, essentially. There's a few reasons for that. And so we continue to have this problem with how do we truly share information? How does information electronically, quickly and seamlessly and safely flow around to follow the patient, so you don't turn up somewhere and there's nothing there. They have to say, send me the fax or send me an email or send it with a courier pigeon or whatever it may be. And that's where this new paradigm came in. So this is free. All of these things I'm talking about today are free in the theme of ICTer. So in the theme of if you're in an emerging region and you want to do R&D work in digital health, these are various things that exist around the world that you can draw on. Okay. So FHIR stands for Fast Healthcare Interoperability Resources. And it is basically JSON applied to healthcare. So if you're familiar with JSON, you can figure out FHIR, and that's not accidental. So the idea was that we could import programmers in for other industries because they might have worked with JSON and APIs and web type information systems. And because it's JSON, they can quickly learn the medical content rather than having to learn that very bespoke HL7 version 2. Okay. And there's a whole framework around this. There's a lot of thought around it. It's existed for 10 years. But what it's actually starting to do is allow that sharing of information in a very real sense because it's native to the internet. So it allows me literally to share information about me now across the other side of the world if we wish to. Okay. Security permissions, another thing. Okay. What you're seeing there is a diagram of just how well evolved this is and how well thought out this is. It's all now under the auspices of that broader HL7 international organisation. I'd be very surprised if there isn't some kind of representative group in Sri Lanka involved in HL7. But you can see all the domains there it's touching on. Each one of those things you're looking at, an allergy, a problem, a procedure, they are all individual resources, fast healthcare interoperability resources. And then if we drill down, the N stands for normative. The higher the number, the more evolved the standard is. Obviously, it's something at 3 is more evolved than at 0. But anyone who's worked in healthcare will look at all those things and go, wow, that's an awful lot of detail about how we model the healthcare information universe. Okay. So you can build systems off these. You can build interfaces off these. You can ensure that anything you build in health IT will talk to something else. Still, it's not magic, as you know. It's still difficult, but it's infinitely easier than it's ever been before. So why is this important? Well, we often look to the US. The US has a terrible healthcare system, but it's spent a lot of money on health IT over a long period of time. And if we go back about 7 years, there was a survey they did, and at that stage, they had 1,800, which was about 30% of the survey, hospitals at what is called level 6 MRAM, which basically means they're almost fully automated, almost fully paperless, so highly evolved hospitals, and many more at level 7. But effectively what we had was electronic silos. So if you went to 3 different hospitals, they couldn't share your information even though they were internally very evolved. They were basically no better than paper. And we know that in healthcare, when the information doesn't flow, that's when we have problems. When the next person involved in care doesn't get the right information, people can and do literally die. No one ever dies if they hack your information. No one, right? So that's the balance we have here, okay? So the key takeaway here is this is an open standard. You can build systems of it. There is no cost to doing that. It's not accidental that those big vendor names down the bottom have supported this. Because that, from their point of view, if they support this, it's almost like starting to have a vacuum cleaner to hoover up everyone's healthcare data. So that is the downside, but it just shows the level of support for this paradigm. Just to show you in a bit more practical terms what it looks like, this is an instance we have of a Happy Fire server. Happy is just one instantiation of a fire server to host fire data. You can see all the different kinds here. It's just dummy data, but observations, encounters, immunisation records and whatnot. And we've used this to do some prototyping work. So that's one way that we can use the data. And this is sort of underpins that RESTful API type construct. You can send it around as individual messages, like I showed you before, and you can build up blocks of it into documents like we did with CDA. The creation of FIRE, this wonderful free resource for you, has enabled another series of technical developments, and one of them is Smart on Fire, which I'll come back to in a minute. So, people are often amazed when they look inside healthcare, especially when they look inside it with an engineering or a IT lens, at just how disorganised or inconsistent it is. That's not talking about the safety of the care and the quality of the care. It's talking about the fact that we've grown up on paper, and a lot of our systems are not explicitly designed. They have evolved, okay? So one key area is clinical terminology. And again, there is a lot of free resources about clinical terminology. So has anybody heard of SNOMED? This very famous worldwide thing? Nope, okay. So I'll explain what these are and why they're important. Again, free. You can look up on the web, you will find SNOMED browsers, you will find Loink browsers. So the history in healthcare has been, if I let 10 doctors in a room individually decide how they will record the smoking status of a patient, they will probably come up with between 5 and 8 different ways. Because nobody ever taught them this is the exact way, and they never agreed on it, okay? That might be fine in paper, but obviously when we move to electronic, that just makes a huge mess very quickly. So that's what SNOMED is about, okay? SNOMED, Systematised Nomenclature of Medicine, a subset CT, clinical terminology, and I'll give you a fully blown example in a minute. So the importance here is if you are building these systems, again, for free of charge, you can go to SNOMED and you can say, okay, well, whenever we record the blood pressure of a patient, we're going to have at the back end this SNOMED code. Whenever we record the fact that somebody smoked, at the back end, we're going to have this SNOMED code. And there are probably hundreds of thousands, if not millions of SNOMED codes. But this middle point is really important, okay? Enables consistent representation of clinical content in electronic health records. And that gets even more important if I, from here, what patient in this place, go to be a patient in this place. You want them recording information about me in the same way, okay? It's very easy, it very quickly turns to mush if we don't have these kinds of tool sets and additive value mechanisms involved. So here's an example. So we have a condition in medicine called a myocardial infarction. It's anecdotally known in many places as a heart attack, okay? When people say they have a heart attack, they're talking about the death of a bit of heart muscle. So myocardium is heart muscle, infarction is death of heart muscle in this case, okay? And what SNOMED says is, I don't care whether you use any of those terms, they are all going to map to this code, okay? And there's a whole library, and that's why you need a browser to go through. But it also says a formal name we'd like to use is myocardial infarction as a disorder, as opposed to, say, a symptom or a treatment or this kind of thing. And it says, though, that all of those things are synonyms. We acknowledge all of those things are equal. Okay, so in theory, if you had a drop-down list, you could have any of those things, but you would map it to this single code. Okay, but all of this is free of charge. Okay, sometimes when you're working with the big commercial players, the way they bundle this up, they'll charge you for. But at its core, you can use this stuff and access it and build your own term sets out of it. Okay. LOINC is a little different. So one of the additional challenges of the healthcare world is we have clinical terms, we have drug terms, we have procedure names, we have test names, we have nursing terminology different to medical terminology. LOINC operates or has historically in the test space. Okay, although it does other things. So a really good example is a test called a full blood examination or a full blood count that some of you may have had, very common around the world. I think sometimes in the US they call it a CBC, a complete blood count. And it's a composite. So it's a test. In the old days I would write FBE on the piece of paper, but I know and the lab knows and the nurse knows that's actually about 8 tests. Okay, so when we move to computer land, LOINC lets us keep that relationship, gives us a code for the high-level test, and then also knows that that's inherently linked to a series of child tests. Okay, so again, if you don't use this stuff and you're building information systems in healthcare, very messy, very quickly, again, free of charge. Okay, and this is bringing a couple of things together. So sorry for those of you who aren't coders, but it's not hard to follow. So this is an observation resource in the FHIR paradigm. It's quite a generic kind of resource. And it's actually, so it's JSON, and it's actually showing you how some of this might hang together. And in this case, it's a vital sign, so blood pressure, heart rate, temperature, these are vital signs. And specifically, it's what's called a blood pressure systolic and diastolic. So you've all seen on the television 120 over 80, 140 over 90. That's systolic, diastolic. Okay. So there's a LOINC code for that. But it also knows, LOINC knows, that that's made up of 2 things. It's made up of a systolic blood pressure, and so there's a separate LOINC code, and a value, in this case, of 125. And it's also got a diastolic blood pressure with another LOINC code. In that case, it's 75. So that's the computational code in FHIR to capture the fact that somebody had a blood pressure recording of 125 over 75. So it's human readable and machine readable. And it's in a standard internet compatible way with JSON. Okay. All free of charge. No cost to doing any of that. So I'm going to talk a little bit now about different sources of healthcare data. We were in some conversations this week where people, quite rightly, computational people all around the world say this, can't build my models without data, and of course that's true. Okay. And this isn't a talk about data access in healthcare, that's got all its own problems. But this is showing you there are some examples out there, okay? There's some well-known examples, probably more out there than you would think. And for any of you working in this space, I would encourage you to work with the data you can to start the process, okay? The people holding healthcare data are much more likely to work with you and provide you healthcare data in an R&D sense, real healthcare data, if they can see some merit in what you're doing. So if you talk in hypotheticals to them, they're often very concrete people. Doesn't mean much. If you go to them and say, here's some data we've got from the internet that looks a bit like this, it's consistent with what we want to do. Look at the model we produced, and here's the benefit of what we did. Now we would like to work with you with real health data. That's the way to do it. Otherwise, you'll just have a Mexican standoff. Okay. So these are just a couple of to-hand examples. There are many more. So We have a state cancer registry in Victoria, where I'm from, and they, for probably 15 years now, have had an online data browser. Now, this isn't accessible in terms of you will not get individually identified records, but you can get summative records and you can get potentially de-identified individual records. So you know that there's, you know, a 50-year-old woman who had a breast cancer diagnosed here at this stage, lives in this location, okay? But that lets you download off that. So that's an example of cancer data. Here's just what you see when you Google open source healthcare data. So there's a lot of data available. There's a whole site which looks like it's US government where it's available. There are 3,436 data sets. Now, we still have to be cautious of what we're seeing there, not build things beyond the scope of the data, not build things beyond the trust level we have with the data, but plenty you can do. I'm going to be a little more precise and specific. Has anyone heard of Mimic? No in the audience? Okay. So Mimic is a particular kind of data and is very famous all around the world. And it's intensive care unit data. Okay. So that tends to be quite different from data from the rest of a hospital, for instance, and it's certainly different from data from the community. Often very detailed, often got a lot of drugs in it, often taken every hour, this kind of thing. Mimic is a collaborative out of the States. It's got data sources from 2 ICU units, 1 adult, 1 children, and it is freely available, okay? They've gone to a lot of resource and effort about de-identification, for instance, of certainly names, staff and patients, but also of dates. So you can't actually tell when, you know the patient was admitted for 5 days, but you don't know exactly when they were admitted or discharged. And there's myriad papers in the academic literature on the medical side looking at machine learning, for instance, using Mimic data. Okay, so it's a really good public resource if you're interested in that space. Cynthia is another one. Anyone heard of Cynthia? Again, American, not accidental, just because the Americans have had more of this electronic health data than other places for much longer. So they've been able to get to the next question and the next question much more than anyone else. So Cynthia is based on the population of Massachusetts. And you can access it from a command line. You can install a package and do things on the command line. Or you can call it by APIs. And it can give you data in a whole range of formats like CSV and Excel, but the reason I've used it is it can give you FHIR data. So if I want to make a mock SQL database of realistic looking healthcare data tomorrow, that's easy. Make a CSV file, duplicate, chop and change it, stick it in a database, okay, import it through a tool into a database. FHIR data is much harder because of its nature, because of its JSON structure. And Cynthia lets you produce FHIR data. And that's been very valuable to those of us working to it. But again, completely free, no cost. And you can do things like manipulate which diseases you want to look at, manipulate genders if you want to, just show me all the female records, whatever you like. It's quite flexible, quite interesting. I'm going to touch a little bit about free constructs, free architectural constructs, and we'll revisit this FHIR conversation in a minute. So some of this may feel a little far off for Sri Lanka, but the problems it's trying to address will come. So what they found in the States and other places, and we now see it in Australia, is a lot of the big electronic medical record systems, and they go by names, like Oracle has one now. It bought up a company called Cerner, Epic, InterSystems. They're spread throughout the Northern Hemisphere, States, Europe, also in Australia, Asia. And as more and more places use these electronic medical record systems and work in hospitals that are increasingly paperless and highly automated, a universal truth has become clear, and that is many doctors and nurses do not like using these systems. Do not, okay? And there's a few reasons for that, and there's a lot of complexity underpinning it, but I won't get into that today. But what you're seeing here is an attempt to help with that. So to give you a simple example, if we have a vanilla, albeit highly complex, deeply rolled out system, if I'm a psychiatrist, you would all recognise that how I might need to use that system, when I might need to use it, what features I might need to use, is likely to be highly different from if I'm a neurosurgeon. And we repeat that problem for every kind of different hospital specialists. And all the while, specialists are getting more specialised. So if you're an orthopaedic surgeon now, you're not just an orthopaedic surgeon, you're a hip guy or a knee guy or a shoulder guy. That's the level of specialisation. So it's a bit naive to think that you'll all be able to use the same computer system, even though that's how we build computer systems. This is an attempt to allow independently developed EMR modules, software modules, to be built by third parties but deployed inside these complicated EMR systems, like putting them into SAP, for instance. That's the level of complexity of system we're talking about. And this paradigm for doing it is called Smart on Fire. Both constructs are free. You can go and do this anytime you like. You can work in the vendor sandboxes and build Smart on Fire apps. You might then want to turn around and try and sell them to the vendors. You can. And there is a model to do that, and provided you're not competing with their functionality, then they're happy with that. They've actually supported this, okay? But doing this is free of charge. And I'll give you two little examples here. The one on the left is called Insight, and this is a wound monitoring system, which you can use independently, but you can use anchored within the electronic medical record system. So you take a picture of the wound, as you see on the phone, it sends it to a machine learning algorithm. The machine algorithm, it says something along the lines of this part of the wound is healing, this part of the wound is not healing, this part of the wound is infected, that kind of thing, and then it overlays it back on the wound via augmented reality. So objective, measurable, trackable changes in the wound. And bear in mind, a wound is a 3D construct. It has width and side and depth, okay? You heal up from the bottom of the wound as well. That kind of functionality, those big vendors were never going to build. Never, 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 okay? But allowing others to come in and do this specialist work using these free tools and free paradigms is actually turning out to be quite powerful. The one on the other side is for complex drug prescribing. So some drugs, when we prescribe them, they're the same for everybody. We might change the dose based on a little bit of the specifics of the condition or your weight or your allergies, but it's not too scientific. There are some drugs, however, that are incredibly dangerous, and we need to be very precise with our dosing. Think of the blood thinner warfarin. Many of you may have heard of this drug. We need to give a series of doses to build up the level. We need to check the blood to make sure you're not too thin in your blood, but also still getting thin, because we're trying to thin it out. Then we need to ease off the doses, because we know if we keep going, it's too high. It's very judgment-based. This tool called Dose, there we go. Forget there's no pointer. Called DoseMe does this for about 40 drugs. So it integrates with the electronic record. It sends the data from the record to a Bayesian-based model, which then recommends the timing and amount of the next dose. So building something like that does not cost, it costs resources, but the tool set and the framework does not cost money. Okay, so again, free of charge to work with. This is an example of evidence around DoseMe, again, because I'm glad I asked about the healthcare audience. This will be over some of your heads, but basically it's talking about a particular nasty drug called vancomycin, which we use in highly complex hospital settings, and it's showing how when the doctors gave the vancomycin traditionally, versus giving it under the guidance of the dose-me model, that they did a lot better job at getting the right level in the bloodstream and keeping it there. The right level to kill the bugs, but importantly, not to do any more harm than they were doing previously. And in particular, no extra harm to the kidneys. This drug can kill the kidneys if you overdose on it. So one of those really complex problems. Again, not the kind of tool set that these companies would traditionally build. Okay, so they're happy to have a third party come in. We've got to test it all, but come in using these free external approaches and deploy in their electronic medical record systems. So a lot in the West, certainly we tend to buy these big commercial systems, but some places don't. And certainly in less developed regions, there's plenty of examples of people working on projects like this. So this is called Open EMR. It's an international collaborative, which basically says all of your healthcare systems may benefit from these electronic medical records, but you cannot afford 60 million Australian dollars, times that by 200 in local currency here, to put the system in. Okay. And so a lot of work goes into this, as happens in a lot of open source projects all around the world. Okay. A little bit of some screenshots. It's not as whiz-bang and fancy as some of the other systems, but it will do the job. Okay. Is it really free? We'll talk about that in a minute. In our case, our federal government has a national health record, which is a sort of a bits and pieces record. It's not intended to be comprehensive. It's intended to be a bit of a sharing vehicle for some of a patient's information. It's called the My Health Record. But they've opened up different kinds of access points, if you like, for people to build products free of charge to then integrate with this national infrastructure. Okay. And of course, you can then sell those or market those if you want. But it's also, I don't see any reason why people around the world cannot access these things, and other governments will be doing this as well. Okay. I spoke before very briefly about how in my world we're covering EMR technologies. They are 50 years old. The first paper I can find about some attempt to go from a paper record to an electronic medical record was published in 1970. 54 years ago. And yet in our country, we still don't have ubiquitous electronic medical records. I know you don't, I know India doesn't, okay. But at the same time, the world's advancing on. I can show you a whole bunch of really cutting edge tools that are in production use that are sold to people now that are at the other end of the spectrum. This is more in this bucket. So this is an open source project called Night Scout, and it's particularly for CGM, continuous glucose monitoring. So the idea is if you have some kind of CGM sensor, which may be the old finger prick and stick in the little device, or it may be the new, we call them Freestyle in Australia, Freestyle Libre, that diabetics wear for continuous monitoring. You can build a project around that. You can build analytics, you can build an app, you can share with people. So this environment, this collaborative is free of charge, okay? And I think we will see more of these things. I don't see why we won't. Okay, so we're going to talk about, and I think I'm going pretty good on the old time, not too bad. We're going to talk about analytics and benchmarking a bit more, okay? Anyone heard of OMOP? Observational Medical Outcomes Partnership? Nope, okay. International collaborative, tools, learnings, advice. The idea here is that, let's say, oops, I keep forgetting we can't do that. Let's say we're talking about 3 different medical record systems with slightly different architectures, different owners, whatever, and they may be in, let's say they're in 3 different countries, just to emphasise. What OMOP does is provides you a common data model for you to map your content to, okay? So that everybody's blood pressure readings come down to a commonality, everybody's sugar readings come to a commonality, everybody's problem list comes to a commonality, Because then, of course, if you were in the same place, you can all aggregate your data in one SQL database because you've come to a common data model. Or, if you are in 3 different countries, you can compare because you can write some code on the data from source 1 and share it with the people who are holding source 3 because you've stored your data in a common way for analytics, the code will run. So I don't need you to send me your data from Sri Lanka or vice versa. I can say, here's the complex piece of SQL we wrote, run it on your end and see what you get. Okay. So that whole thing is free. Resource intensive but free. There's no cost to do that, no licensing required. Some OMOP case studies. So again, you're not a medical audience. Our biggest single research repository in medicine, including in health informatics, digital health, is called PubMed, run out of the National Library of Medicine. If you just Google PubMed, you'll find it. These came up just the other day. There's lots of them, lots of places around the world. So we've got Bulgaria, we've got Norway, Catalonia and Spain all have built different kinds of OMOP aggregations because it's universal, okay, and free. BERT, Business Intelligence Research Tool. I haven't used this one, but I certainly was across it even 20 years ago. So again, open source data warehousing tool, basically. So no cost. There's an overhead, technical overhead, there's infrastructure needed, but the software doesn't cost you any money. We have colleagues in our country in Brisbane who are leading, certainly our country in some parts of the world, around fire. So the JSON data had been made to share in real time, wasn't really made with aggregation and analytics in mind. And there's work going on now to convert it from fire to SQL and other things, but as a waypoint, these people built a free server for aggregating all of that healthcare data in the JSON format and allowing you to write queries, again, free of charge. You just have to install it and host it yourself. And this is more in the benchmarking space and really for people interested in comparing outcomes around the world. So how do I know how prostate cancer treatment in Sri Lanka is going compared to Germany, Australia, India, or the US? You can participate in this kind of thing. It applies across multiple disease states, obviously very common diseases which affect people around the world. And it's already done the work about what are the measures, but it's gone down a few steps and said, well, how do we build into our computer systems the appropriate SNOMED and LOINC codes so that at the other end of the process, it's easy to get comparable data. Okay, so this is called ICHOM. Okay. Again, participation is free, lots of learnings and tool sets. And so, for instance, getting these data sets out with all the metadata around it. And just a quick nod to some other things. There's a very famous international initiative called Open EHR, Open EHR, Open Electronic Health Record. They talk about small data. So their approach is to say, let us all try and standardise on the really micro data, and they might use things like SNOMED codes because then it doesn't matter what your computer system does as long as it uses that data. There are a few flaws of that approach, but that it exists. IHE, Integrating the Healthcare Enterprise, deals with that whole idea of we've got 3 different hospitals, how do we get them to share their data and have a common view of it? And again, free tooling, no money to be involved. And I came across a thing called GNU Health recently. It's a whole ecosystem. Not sure how much work they've done, but electronic health records, population health system, personal health records, laboratory information system. But again, free knowledge, free collaboration, free tool sets. Okay. So there's lots of free out there, just this is the open source paradigm, right? Approaches, platforms, tools. Some need technical competency, some don't, so you need to know what you're doing to install a fire server, not so much to play around with ICHOM data. Some need hardware, obviously, for housing development. all need training, effort and labour. So nothing is completely free. There is no such thing as a free lunch. But these things are potentially good for entry level, for researchers and developers and organisations wanting to get into the digital health space. And I'm talking here about building digital health solutions, not just analysing healthcare data, okay, which is much more the domain of our colleagues in epidemiology. Just a very quick shameless promotion. If any of you are interested, we are running a cross-regional Health AI event for 2 days in November. You can register via that QR code. We have speakers from India, Vietnam, Indonesia, Malaysia and ourselves in Melbourne. We would hope maybe next year to have some people from Sri Lanka as well. Very low bar, cost of entry, because we want people to participate, and timed to work as far back as Indian Standard Time. So it'll start early morning in India, early afternoon in Australia. Thank you. I'm not sure we have time for questions, but I'm happy to take any if we do. Wonderful.
Yeah, one question actually, the information that you have provided actually very new, and thank you for actually conducting that. So my question is like, if a patient, like select a scenario, if a patient admit to the hospital like an emergency response, like from a chest pain, so you have mentioned the data communication method like SNOME and LOINC, like, so like to get my better understanding, like is there like the better way? Okay, so as a doctor we should use SNOME for like, you know, better data transfer, or should we go with the LOINC? So is there differentiation, or do we use, you know, FHIR interpretability to in both cases?
Yeah, so assume you have an electronic system. So if you go to the hospital, you have a heart condition, the doctor would use SNOMED in their computer system. So if it was all set up, they might have typically a drop down, and maybe, and this is in their problem list, they might look at you, decide you have, let's say, angina, which is a heart condition, and they might have a button first that says cardiac conditions, they hit that, and then a drop down will open, it'll have angina, heart failure, ischemic heart disease, myocardial infarction, a selected range of all of the SNOMED codes for them to hit. That's the one. Has to be about that simple, or else they won't do it. Okay. Then behind the scenes, if that patient was actually going to then go to another hospital, to the intensive care unit, because this hospital has emergency but no intensive care, then FHIR would allow that package of information to be sent to the other place. And inside several little packages, several resources about you with your heart condition would be the SNOMED code saying angina, because the doctor selected it at the front end. Does that answer your question?
Yeah. Thank you.
Yeah, and if you really wanted to, in that second hospital, if they aggregated all the FHIR data, they could store it on a Pathlink server and query it like an old data warehouse.
Yeah, that makes sense. Thank you.
Yeah, I have a question. So nowadays,
Can you pop that microphone nice and high? I'm struggling to hear.
Yeah. So nowadays, as AI becomes more integrated into healthcare systems, so what are the considerations, like ethical considerations, do you think are most critical, particularly in EMR or medical record processing?
So if I'm understanding and hearing correctly, as AI becomes more relevant in society, more relevant in healthcare, what are some of the considerations about its use in healthcare?
Yeah.
Yep. Okay. Lots of considerations. It's already in healthcare in different ways. I'll give you a tangible example. So there's this concept now of AI scribes. So there's various companies, some Australian, some not, Heidi, Lyrebird, Meadow. The idea there is if you go and see your practitioner in a clinic, in the family physician's office, they will say, I'm going to record today's consultation on Lyrebird Do you mind? Assume you say no. They hit the record button, and thereafter the doctor does not need to write any notes or type any notes because the AI is listening, and then at the end of the consultation it spits out a little templated summary, and the doctor will check it and go, yeah, that's okay, and import it into their medical record system. That is happening today extensively in Australia and many other countries. The other thing that's already happening today in Australia and many other countries is in radiology systems. So the X-ray people, they're already examining lots of X-rays, chest X-rays, CT scans of the brains using AI. And the AI system will preemptively say, these are all the things I can find. And then the doctor will check and say, I agree, or I must check that one, or whatever. So that sort of stuff's quite ubiquitous. The considerations are multiple. Who pays for it? Do we have a social licence to do it? Has the patient been made aware, and do they agree? What happens when LLMs hallucinate, etc., etc., and it goes on and on and on. Is somebody attacking our system? Can we trust it? There's a paper out of Israel from 5 years ago done in a research setting about, it wasn't about AI so much, they used the GAN, but they deliberately intercepted the messages which are called DICOM messages, describing a CT scan moving around inside the hospital network. Where the CT scans had lung cancer, they deleted the lung cancer. And when the CT scan had no lung cancer, they inserted a lung cancer. And they were able to fool the radiologists. Okay. So many considerations. Personally, our healthcare systems are too stressed. They cannot cope. All around the world, we need help. AI will help, we just need to be very careful with it. So I hope that answers your question.
So I have a question. So my question is usually, so when the previous question was that the person come to the hospital, yes, then the process begins. So if we can make a solution that, imagine I have a chest pain at the home, so yes, if we can get the data from that point onward, then can we implement that kind of solution using the same technologies that you mentioned during the presentation?
So are you talking about a system that preemptively collects the information, sends it ahead of time to the hospital because you're going to get there, yeah, and you just, okay. People have tried this kind of thing. Could you with this? You do, but again, you might need some kind of AI intermediary to synthesize what you put in. But the short answer is yes. Things like SNOMED, for instance, and LOINC and that kind of stuff should be used in such a system, or else it's not very sustainable. How do you define the different conditions or the different systems if you don't have a master index from which to pull? So they would fit into such a thing. People have tried this. I've not heard of it happening successfully yet, because it's one of our complexities about, we see lots of points in healthcare where we think it might help and then we find it doesn't. But it doesn't say don't try. Yeah.
So I have a question.
Sorry? Oh, there we go. Thank you.
What are the main limitations for these free digital health tools? Yes. And also, how these digital health tools user-friendly for older adults or the limited digital literacy people?
So the first bit was about what are some of the limitations of the tools, and the second is
how user-friendly.
Oh, how user-friendly? Sure. Okay. Well, the biggest limitations for to start with, there's still a technical overhead. It's not magic. It's not insert a CD, tick yes, because you're setting up free infrastructures. So some of that stuff you absolutely need to have either be a technical person or have a technical person in your team. But the big thing is licensing. You're saving a huge amount of money on licensing. You also get a freedom with some of this stuff to extend it, right? To tinker with it, to take it to the next level, which you might do in collaboration with someone in another country, whereas vendors don't want you doing that. So biggest consideration usually is, do I have the technical nous and ability to host these things in the first place? Because sometimes it's beyond, will it load on my machine? You know, you're just going to run out of space. There's often, I guess the general thing I'll say is often those bigger things, especially stuff like SNOMED and LOINC, OpenEMR, that kind of stuff, there's whole communities. They don't exist without those communities. So there's enormous numbers of people. Same with FIRE, you can call on around the world. There's listservs, there's help groups, there's conferences. And that might frame your selection of a tool. You might have several competing tools, but this one might be newer and look sexy, but this one's been around for 20 years and there's thousands of people around the world you can work with on it. That's an important consideration. So hope that helps.
So I have one problem.
Are we allowed to keep going, or do we need to stop for lunch?
Yeah. So, these days, data privacy becoming one of the major problem, and
Sorry, I'm really struggling to hear you.
Data privacy becoming one of the main problem, and I wanted to know how can digital health solutions can maintain transparency and trust with the users.
Yeah, that's a very broad question. I mean, these things aren't immune from bugs. They're not immune from being hacked. So all the sort of usual risks to data privacy, you can implement them poorly and sacrifice privacy and confidentiality. All those things still apply. There's no magic solution to those issues. Okay. You know, and sometimes maybe that's an extra cost. Maybe you employ a consultant to build you your local OpenEMR instance because they're familiar with that stuff. You've got to pay the consultant, but you still don't have to pay $60 million to a big company. Okay. I view the issues of transparency as a little bit agnostic to the technology I've shown you. They're important issues, but is there anything special about these technologies versus commercial technologies with that question in mind? I'd argue there's not. It's a bit of a non-answer, but that's my gut feeling.
Sir, I have a question. Here. Okay, so you talked about this IR architecture. So there are lots of legacy systems and documentation, like manual documentation. So are there like documentation that non-technical people can easily use to convert these legacy systems or documentation into this IFR architecture because it will be easier? So about that.
So you're talking about using FIRE to connect up legacy systems, and is there documentation around to help you do that? Yes. Well, the trouble with that is that the legacy, FIRE will help you, but the legacy systems at each end have to sort of speak FIRE. So if you've got a SQL database there on an operational application, that's not native FIRE. However, there is work going on, as I said before, about translation between FIRE and SQL, usually in that direction though. So the challenge there is not the FIRE bit, it's how is the data in a traditional SQL format going to get in FIRE so maybe it can be shared to the other operational old system. Does that answer your question? I'm confident there's enough documentation out there to anyone interested in working with FIRE. I have zero doubt. I've seen it, I've used it, I've pointed my programmer to it. There's increasing amounts of training. HL7, the HL7 organisation, which has an international presence, is not a bad starting point if you want to learn about doing FIRE. They have introductory courses. You can step up your levels of accreditation with them. So it's nowhere near a whole university degree commitment, for instance. You can do it while you're working, while you're studying other things. That will cost you money though, because they do charge. Yeah. Okay. I think we might be done for lunch.
Thank you, Professor Bain, for the insightful session in what in digital health is free. It helped us see the hidden costs and challenges behind the free digital health tools, especially around data privacy and access. Dear sir, please remain on stage to receive a small token of appreciation. We would now like to invite Professor Kasun de Souza to come forward and present a token of appreciation to Professor Chris Bain. Thank you, professors. Let's take a moment to extend our appreciation with one more round of applause for today's remarkable speakers. Now, feel free to stretch your legs, enjoy lunch, and let's reconnect with the fellow attendees.
Business cases, or in the case of us, Genie, we look at any financial product. Then it also involves streamlining the processes because it's all about optimization, right? We are very cost conscious and we try to be as optimal as possible to give the best experience to our customers. And we target on making the financial services more accessible for the customers, especially targeting the underserved, where they tend to be more neglected with the traditional large banks because of the cost to service those customers and so on. So take AI. How is it transforming financial technology or fintechs, right? One thing is streamlining the onboarding. So post-COVID, or pre-COVID rather, if you all remember, there was no such thing as a digital onboarding. Any customer had to visit a branch, fill a huge form, wait for a few days to get their account open, and then to get digital access, fill a few more forms, and go through that whole process. And then COVID came in came digital onboarding. And fintech started really thriving with that because we could onboard customers in hours and do the entire stream digitally. Of course, when you do that, that also comes with a lot of risks, compliance-related, operation-related risks, and we also have to evaluate the customer. So this is where AI helps. You can check whether it's a genuine customer. Is it the person, the ID, is it matching the customer? The information that they're giving, is there something that we can auto-populate rather than asking the customer? The journey, the whole journey that he sees, can it be streamlined so that it's very specific for the customer rather than giving the standard, like you go to a bank, you have a mandate which will be like 5-6 pages long to fill. It's like those visa applications. So with AI, it's very easy for people to streamline that and make it very simple and only specific to that user or the product that the user is applying for. And then personalized service. Now this personalized service can be anything from how we serve the customer, for the customer experience, or what we offer to the customer, and the products as well. Rather than having a cookie-cutter approach where you will have, the traditional savings account or the fixed deposit, and these are the requirements, with AI, we can have very, very personalized options for the customer. And then, of course, AI is also helping with proactive monitoring. Typically, with the number of transactions that goes through fintechs and the team that is very, very small, you need AI to identify anomalies, look at transaction patterns, and then there are regulatory requirements on how the money moves in and out, who are they sending to. Now, if you go to do that manually, it will be very, very strenuous and they'll be very labor intensive. So AI has helped fintechs drastically optimize that and at the same time be risk conscious. So as I said, so personalization, hyper-personalized products. Now even we on Genie offer very specific products tailored to the customer, right? So with the AI algorithm, we can get information about the customer based on his transactional pattern, what customer inputs, right? or the application data, the A data, plus also the B data, which is the behavioral data based on how the customer behaves on our platform, what they're interacting with, what information they provide regarding their social media with their consent. We can use all of that to streamline and provide very, very personalized products. In some cases, there are some fintechs who even go to the extent of seeing what is the consumer searching for online, where are the gaps. Look at the Google search patterns, or now it can be social media or even Instagram, seeing what are they looking for, what are the gaps, how can we fulfill that and give them a personalized experience and target them and give it to them rather than just carpet bombing them with the offers. And then pricing also now with AI, we can do very dynamic pricing, which if you go the traditional method, it's very, very difficult to do. You will have multiple people sitting there using Excels, analyzing, looking at probabilities and seeing what can be done. Now with this, it's much, much easier for us to do pricing. And we can also predict and say, okay, this might work with this customer and this might not work with this customer. And then we also get insights on the customers. AI is helping the fintechs saying, okay, your customer, this is the type of stuff he's going to respond to, this is the type you're going to go for, and we can build predictive models on that, and then which helps us predict what the behavior is going to be, when the customer is likely to churn, is the customer going to stay with us, or are they going to move on, or are they here only for a specific reason, like only for an offer and not really going to use our platform? Can we do something to entice them to transact with us, bring any value addition to them? All of that is possible with AI. Right. Then unbanked. Now in Sri Lanka, even though almost everyone has a bank account, not everyone transacts with that. There is still a population of unbanked population, and there's also a gap in financial literacy. Now, when we are a fintech, we use digital as our front. So there's a big challenge in getting the traditional person who uses a passbook, who is used to always meeting an agent at a branch and interacting with them, to get them onto the platform. So here again, it's much easier with AI. So for example, even credit scoring. Now, you take Dialog, for example. Dialog does a score for the customers, which is how they decide what is the credit you will get for your postpaid bill. Same thing, there are fintechs who use the alternate data available about the customer to build a model to decide how much to give to them. Now, these people traditionally won't fall into a credit bureau. There will be next to no information about them, or their income is too small, banks won't even touch them. Now with the alternate information that a telco or someone with big data can build with proper data privacy methods and also with the customer consent, they can actually say, hey, you've been using our telco for so long, XXX, based on this, we can give you X amount in a loan. Or we can increase your postpaid credit bill by this much. Rather than saying, okay, submit your bank statements, oh, I need to see your income statements, oh, you're a three-wheel driver, you're not going to have a bank statement, no, sorry, I'm not interested in you. So this is another very big area that is working, and we also work with the GSMA on microloans for the customers, especially for the unbanked. And AI is also helping us with financial literacy. Now, of course, AI has been around for a long time. ChatGPT coming in was like the iPhone moment for artificial intelligence, right? And why? Why did that happen? The boom happened because suddenly consumers found it very easy to interact with AI and get a response in a very conversational manner. With that, let's be honest, our bosses also found it interesting, so they were willing to put more money into these sort of investments. It's not like AI has been around for about 60 years, and probably the generative models for around 15, 20 years now. But ChatGPT was that iPhone moment, which has completely changed everything, and now everyone is going to AI. Now, also the benefit for us with fintechs is, a lot of these people with low financial literacy or unbanked people also are not very good interacting. Now, they can have a normal conversation with these bots. Now, we are working with some models where they can start talking in their natural language, in Tamil or Sinhala, or they can even use Singlish or Tanglish to interact. rather than saying, no, you have to type everything in English and use those big banking words, which makes it very easy for them. It's like, some of these people, we have noticed, have smartphones, but they don't use it for anything. They only use it for WhatsApp, probably Facebook, and a little bit of YouTube. Now these people, like WhatsApp, they can just start interacting, asking questions, getting responses from the bot. And it will give them advice on what is the best way to do it, how to onboard. So all of these has been possible thanks to AI. AI as a force for good, like I said, some use cases, take PayPal. They have got, now they are one of the largest in terms of transactions, and they're using AI for all their fraud detection because the volumes is so high and they're in so many countries, the regulations are different, what they have to look at in terms of anti-money laundering, in terms of the way money is moving, looking at what you call layering, where they have to monitor saying, if someone is using multiple transactions, all of that, if you go to monitor, as per the regulator using manual methods, it will be very, very difficult. Now, AI has really helped, and PayPal, I think, as per the last stats, they have cut down the operational cost by almost 40% using this method. And the network and financial, all of you all know Alipay and Alibaba. Now, they are offering microloans, like I told you earlier. In China, the consumer who is not in the banking history will just get a loan based on their telco history, their social information they provide, and maybe even the geographic location they live in. Based on all of that, and financial immediately decides on a predetermined credit and says, hey, you want a loan? This is how much we'll give it to you. You can either use it on an app to transact and buy stuff, or you can take it out, cash out, and buy something else. Same thing happens with the robo-advisor, Betterment. Betterment is one of the large trading apps, which is digital trading apps, and they have got robo-advisory, so which means there's AI sitting in the back, advising them on how to trade. So you go and say, okay, I want to trade X amount. The robo-advisor will do the trading for you and advise you how to do it as well. The risks are the same, just no different. They're still taking the same precautions that you would take in when you have with a day trader or someone who is advising you. But for Betterment, because now they're able to go for very small ticket values. Typically, when you come to stock trading, now we also do stock trading, it's not worthwhile for all the big stock trading companies to target customers who are doing small tickets, like 1,000 rupees, 5,000 rupees, 10,000 rupees into trading, because the margins are so low and the amount of effort they had to put to communicate with that customer, advise them, having a physical person is very, very difficult. With AI, they can completely automate that, and they can look at the small ticket, bring them into the ecosystem, let them learn about trading, and then slowly take them up the chain, which is very, very good. Now, at the same time, there's a dark side to AI. So Apple Card had a massive issue where they were accused of having biasness in the AI, and a lot of people, including Wozniak, the co-founder, said, hey, my wife and I applied at the same time. I got 10 times the credit that my wife got, and we submitted the same stuff, but my wife has a better credit score in the credit bureau. How come I got 10 times the credit limit? There were so many people who complained about this to the extent that the regulator had to get involved and investigate Apple Card to see, is there some sort of gender bias happening in AI? So these are one of the stuff that can happen with AI. Then you have the frauds. Now, especially what's happening is, recently there was a fraud. Someone contacted an employee in a very large corporate in Hong Kong and said, hey, come for an urgent meeting. The whole board was in that Teams call. The CFO spoke to that person, said, okay, the CEO is here, everyone is here, can you transfer money urgently to this account? So this person was a bit suspicious because earlier she had got an email, and she said, okay, I didn't trust the email because it's not following the correct process, but hey, what are you going to do? The whole board is in a meeting, in a call with your CEO and the CFO, and they're telling you to transfer the money. She transferred the money. And to see, it was completely fake using AI. They had gone to the extent, the fraudsters had gone to the extent of having a fake video conference call in real time, conversing with the employee and answering the questions, and the money was gone. So these are the risks for financial technology which comes with AI. So the same thing, like I was saying, when we digitally onboard a customer, these can happen. So we have to take precautions for that. Because a customer, we look at a video call and we look at liveliness check. Now with the AI and deep fakes, we have to be extra cautious because otherwise these sort of things can come in. So that's the risk. And then there was the famous cyber attack in US. They used a very, very innovative method recently, and millions of dollars were taken out. And the AI was so smart, the way it was done, even the fraud systems couldn't trace that they had fraud that had happened in these transactions, because it was using a generative AI and it was very, very smart. So these sort of risks are there with AI. So potential risks, data privacy and security. This is a big, big thing, which is very important because AI needs a lot of data to train, right? And then we have to be very careful what data we use, how we store the data, and do we have customer consent to use that data. And if you don't train the model, you're going to have problems because garbage in, garbage out. Same thing, you have a lot of AI-powered scams. Even in Sri Lanka, recently at the central bank, there was a presentation. Almost 600 million rupees has been stolen from people's account, where there was some part of AI or a bot involved, where they were using one-time password frauds. Now, traditionally, someone will call you. Now they're using a bot, which will impersonate a website as one of the banks, and it will say, hey, can you log in and do this? You log in. At the same time, there's a bot sitting in the back, taking all that information, logging on your behalf into the real website, stealing the money out. And within minutes, millions are gone. Then you get algorithmic bias as well. Like I said, garbage in, garbage out. If you don't put the right amount of information and clean data into the models, what you're going to get out is also not going to be good. Same thing, there are a lot of operational risks. One question is, okay, when an AI is doing something, who takes accountability for it? Are you going to hold the model accountable, or who is going to be accountable if there's a fault or a mistake, right? And the other part is transparency. Most of the AI models are like a black box. You take lending. If a customer comes and says, hey, my friend and I have the same spend pattern, you're giving him a loan for 50,000 rupees, why are you not giving me 50,000, or why are you giving me only 5,000? It's very hard to explain because you don't have a normal credit officer going through the evaluation. You're using an AI to determine the score and the method to disperse. It's very hard to explain to a customer saying, okay, this is what you need to exactly do to improve your spend, right? And then there are ethical considerations as well, which is very, very important, and we have to be very conscious about what data we are storing about the customer, and do we have the consent of the customer? Are we telling the customer why we are storing it and what we are going to do with it, or are we just blindly storing it? Now, Sri Lanka, our legal team has been part of the team that has now drafted the Data Privacy Act for Sri Lanka. And anyway, we've been, because ICTer, we are part of the global group, we have been following GDPR, but a lot of organizations are still coming onto this. That's very, very important because you get so much data, and without customers' consent, you start building a model and start using it. Does the customer really know what you're doing with his data? Which is very, very important. So these are the potential risks. And then the future, friend or foe. We have to acknowledge the risks. Whether we like it or not, AI is going to be part and parcel of our life. It is going to make things easier in a lot of cases for fintechs. And we have to move with that. Otherwise, we can't have the competitive edge, but we need to be smart what we use it for. And then we also need to have ethical AI policies so that we decide what we use it for, how we use it, and we are very ethical about it. And there should be human oversight, which is very important, because otherwise you're just handing it all over to a black box and you don't know what's going to happen. So that's a big risk that you're taking on. And this is something in Sri Lanka now the regulator is looking at very strongly, which is regulatory and industry standards. We still don't have that. There are drafts being done. Some of the gentlemen here I know are even involved in the drafting of it, and the government is looking at it seriously, because with the boom of AI and AI coming into so many different sectors, not only financial, other sectors as well, this is very, very important that you have proper guidelines, standards, and a common, regulatory guideline that everyone can follow to make sure we're doing the right thing. And so that people don't go and do it the way they want to and think they get compliant, because which is very, very important because it's customers' data. So these are the main stuff. And then one thing I think in terms of operational risk, I forgot to mention to you all, this is a very, very important area with AI, which is you can have model failures and inaccuracies. You can also go into the risk of overly relying on your AI model, which is also a problem. You become so reliant, something goes wrong, you have no backup. You have no way of coming out of it. And like I said, the data quality, you need to have good data, you need to have clean data, which takes a lot of information and effort. You will have system downtimes, and with AI, that becomes a bigger problem the more you rely on it. And then the regulatory and compliance related risks. And then the bigger thing is the cybersecurity vulnerability. Now you're putting everything on the internet, you're giving it to your customer. Even recently, ChatGPT, suddenly there was a bug. It started exposing one person's conversation to another person. People could randomly log in and see all the conversations that were happening. Card payment data started getting leaked from ChatGPT. So you have to be very conscious. The more you expose, and you never know what the model, because these are generative models, they can start exposing stuff that they are not supposed to do. So these are the stuff that we have to be careful about. But it's a fine ground. It's something we have to live with. So thank you. Oh, this is Genie, I think our super app, what I told you all about. We have savings, pockets, fixed deposit, everything. I think you would have seen our people as well. We're the #1 fintech app in Sri Lanka. We have everything. So we strive on giving different financial options. So it's like a one-stop marketplace for our consumers to come and get their products. And it's been built over so many years. We do use AI to a level in the back end to analyze and give the best sort of products to customers. So yeah, please do try it and see, and let us know your feedback and how it is. I think that's it. I think. Any questions anyone has? So you all will let me off easy.
Hello. Jenny is an innovative app, so it's better than other dial-up digital products, I guess. And one more lacking thing is, when I used to create my account over there, I have used my NIC again. So why can't you connect Dialog? I'm an existing Dialog customer, right? So why can't you connect those data with this Genie app, since you are a subsidiary of Dialog?
Right. So this, again, this has nothing to do with AI, but I'll tell you something. Remember, I talked about ethical use of data. We are a subsidiary of Dialog. Dialog Finance is a subsidiary of Dialog. It depends on what product you take. So let's say you take a financial product, that's a banking product from another third party. You cannot, just because I am a subsidiary, I can't ask Dialog, give me the data of this person. Because you are given it to a different organization. We are a separate regulated organization. So because otherwise, the regulator will also get scared. Just because you have a subsidiary, you can't take the data from there. It's very, very important. So from customer experience perspective, yes, we are looking at probably getting the customer consent and then looking at it, but then also we are obliged as a third party, like when you provide a financial service, right? You have to vet that customer yourself. There's something called know your customer. We have to do it ourselves. So there are certain stuff we have to do to make sure the person coming on is who they are. And because you could have given your details to a telco for a different reason and your financial product is different and you might need additional information provided. So that's a bit of a give and take. So, but we are very, very careful. We keep arm's length so that we don't share any, we are not allowed to.
Okay, that's great. One more question. So when we place FDs on central banks, so we do have guarantee, like so some part of amount, so insurance payment, like if your organization runs out of what you call bankruptcy, so sometimes who holds that act over here? Are you registered under central bank, or you are under the patronage of Dialog? Or
Dialog Finance is the regulated entity of the central bank who provides all the financial products. Hence why I told you Dialog Finance doesn't have access to the data at Dialog. Dialog Finance is completely regulated by the central bank. So it's like any other financial organization. So if you'd seen the logo, there's Genie and there's Dialog Finance. You have Dialog ASEAT and then there's Dialog Finance, which is a subsidiary, which is a fully regulated entity monitored by the central bank. So it's no different from you using any other financial institute.
Okay, thanks. Great.
Thank you.
Hi, I'm Varuna from Central Bank. Are you planning to allow savings accounts of other banks to connect with Genie? Because at the moment, either you have to have an account with Dialog or Dialog PLC, or you have to have a credit card.
Sorry, Varuna, is it?
Yes, correct.
Yeah. So Varuna, you mean to say viewing savings information from another bank on Genie, is it?
No, if you take other, what you call mobile banking apps, they allow connection of other bank savings accounts to the mobile app in order to carry out transactions. Are you planning that in?
We already have that. That's called a rail called Just Pay, where you can link your savings account and you can use it to top up. So let's say you have another bank A account.
Is it already available?
Yes, yes, it is there.
Are you sure that
yes,
it's working? Because I tried it, it doesn't work. If it's already there, you just you'll just need to
because
check
that's
that.
one of our, we are the largest or second largest in terms of transactions for Just Pay, which is what you're referring to in Sri Lanka.
Okay.
Which is basically you pull money and then you pay your bill, or you fund your wallet or your savings account, or you purchase something on the app with them.
Yeah, actually, Genie was given permission for that feature as well, but it's not available in the app. That's why I raised it.
I'll show it to you after
Sure,
this. Yeah.
sure, okay.
I think.
Thank you all for your questions, and thank you, Andrew Aryaratnam, for that insightful presentation. Now, it is my great pleasure to invite Dr. Nalin Ranas.
Cover in my presentation. First, moving on to the research, first we'll understand about the cultivation of black pepper. First, there are two phases in black pepper cultivation, vegetative and reproductive. Vegetative period spans for like 3 months, from January to March. Normally Sri Lanka has 2 drought periods, February and August. So within the vegetative period in February, we have the February drought period, and after that drought period rainfall starts. This stimulates the flower initiation of the black pepper crop, and then from March it starts the reproductive phase. So it will be the duration of this reproductive period about 8 to 9 months, and after 7-8 months of maturity, black pepper will be harvested. So if we talk about the climate factors that affect to the black pepper, normally rainfall, maximum temperature, minimum temperature and atmospheric RH values are the main climatic factors that affect to the black pepper crop. And as you can see, if we can't get adequate climate factors, there are things like lower spike filling rates and the small length of spikes. The sizes of the fruits can be different from each other, but if we get adequate climatic factors for this crop, we can get a better quality black pepper crop. So why I wanted to do this research is in Sri Lanka, if we consider black pepper is the king of spices, and in Sri Lanka it is the second most important spice crop, and it is distributed more than 40,000 hectares. So for the annual average production, it is around 25,000 metric ton, and we export 15,000 metric tons, and from that we earn $90 million US. But because of this prevailing unpredictable weather conditions, it has effect to the pepper yield and quality, so that there are fluctuations in the pepper yield and quality measurements according to the Export Agriculture Department. But we have the potential to become the one of the main quality black pepper providers worldwide, because there is a very unique characteristics for our Sri Lankan black pepper. Like we have excellent aroma in our black pepper, and volatile oils like piperine, oleoresin, which gives the aroma and the taste of our black pepper. So even we have that potential, because of this climatic changes and weather factors changes, there is a issue with this black pepper yield and quality. So it is very important to study these climate parameters with the black pepper production, and develop an accurate pepper yield and quality prediction model using these weather parameters. So we are not the only one that growing pepper, black pepper, and provide in the world. There are other countries like India, Malaysia, Vietnam, Brazil. So from their research, mostly India and Malaysia countries have done researches on developing these pepper yield production models, but they have not, still they have not developing quality prediction models. And also they have find out that other than the temperature and RH values, rainfall have a better effect in this pepper yield and quality. So according to the study that have done in India, they have found out that adequate rainfall and its distribution is a crucial factor for determining pepper cultivation and its overall productivity. But some of the studies have said that decreased rainfall can lead to lower yield, but in some studies they said that rainfall can be also detrimental. And also if we consider the models that have developed from other countries, LSTM models also have developed, but quality, regarding the quality prediction, the models are not still developed. And if we consider about our local context, in Sri Lanka we have diverse climate parameters in different regions, and not only Matale. In my research, I am considering my scope is only focused on Matale district, but other than that, Matara, Gol, Gampaha, Colombo, other districts, some other districts are growing pepper. So we have diverse climate parameters in there also, and we still have not developed predictive models for black pepper yield and quality. Even there are discussions on developing them, still they have not tried it. So as I said earlier, there are now there are prevailing unpredictable weather factors and weather climatic factors. So there is a huge effect on black pepper yield and quality because of that, because black pepper is very sensitive for the climate parameters like excessive heat and dryness. So it will affect the pepper yield. So if we get low pepper yield, it will directly affect the annual foreign earnings of our country. So it is better if we can develop a machine learning model based black pepper yield and quality prediction model to predict this yield and quality And before that, it is important to identify the relationship between the black pepper yield and quality with climate factors and also rainfall parameters. So my aim is to develop a long short-term memory model based machine learning prediction model for black pepper yield and quality under different rainfall scenarios. So to come to that aim, these are the objectives I have followed. First, I pre-process and analyze the weather data set to understand the weather distribution, and then I analyze those weather data set, black pepper yield and quality data sets separately to investigate the effect of these weather parameters on matured field of black pepper, and then ML based black pepper yield and quality prediction model was developed using weather data, and then real time weather data was used to evaluate the prediction model. This is the methodology. So first, for the first objective, understand the weather distribution, I collected the weather data set. So both weather data and the pepper yield and quality data was collected from Central Research Station of Matale, Export Agriculture Department. And that weather data was like 20 years weather data, and then annual weather data, and then I pre-process that, and then after analyzing, I did a comparative analysis to understand the weather distribution, and then to identify the weather parameters that have an effect on pepper yield and quality, I conduct a pepper productivity data, include the pepper yield and quality data. So using that weather data and pepper productivity data, I did the analysis to identify the most expressive factor for this pepper yield and quality data. And then for the objective 3, after identifying the expressive factors, the main factors that affect for the pepper yield and quality, the model was selected for the to develop the predictive model, and then hyperparameter selection and LSTM model was trained for that. For separate LSTM models were developed to predict pepper yield and quality. But since I get an overfitting problem, I did the data simulation, and then again the data that was simulated was used to LSTM model to train. And finally, the model was evaluated using evaluation matrices. And if we move to the first objective, weather data set was collected from the Central Research Station, and then the, data pre-processing was done. So with the collected data, I analyze and get the daily weather data distribution, and that distribution was compared with the standard daily weather data distribution that was collected from the Central Research Station. So I get that there is a similar relationship with those both distributions. So here we can see the upper image, it shows the average rainfall distribution of Matale district, which was collected from the Central Research Station. So under that, the graph shows the data I get from the collected from them, and the first one shows the standard distribution, and this is the one I collected data. So normally Sri Lankan have a bimodal weather pattern with the southwest monsoon and northeast monsoon. So these monsoons affect the crop yield. So it is better to understand these the monsoons affection on this black pepper yield and quality. So for the objective 2, I use the pepper yield and quality data to identify the most expressive factor for these pepper yield and quality factors. So first I used pepper yield data with weather data and did the statistical analysis to find the most expressive factor for that yield productive data. For pepper yield I did separately, and for the quality I did the test separately. And then rainfall was selected as the most expressive factor. So normally in perennial crops there are 4 rainfall parameters that rainfall parameters affect to perennial crops for their yield. So I use these 4 rainfall parameters again to find out the most expressive rainfall parameters that affect the pepper yield and pepper quality separately to develop the model. These are the results I get from that. So as you can see from the first table, annual rainfall shows the highest R squared value. So annual rainfall was selected as the most expressive factor that affect the both pepper yield and quality factors. And then rainfall factors which are annual rainfall, annual rainy days, drought span, and rainfall soon after the drought period was analyzed with the pepper yield and quality to identify the most expressive factor to develop the model. And then these factors were used to develop the model. So these are the steps I did in objective 3. So the model was selection, and then hyperparameters was selected. And the model training was done separately for pepper yield and quality. But for both models I get overfitting problem, and data simulation was conducted to get like 30 more data, and then again that simulated data and that original data was used to train the model. So these are the hyperparameters I get for the pepper yield and quality models, and that is the model I have used. So this is the result I get from that 2 models. And for objective 4, I did the model evaluation. For that, for evaluation metrics, I choose the R squared values and mean absolute values. So these are the results I get. So as you can see, when training with original data, I get lower quality prediction value, lower R squared value, and also for the pepper yield I get lowest R squared value. But when I train it with the simulated data, the R squared value was increased, and for the MA mean absolute error also, for the pepper yield and quality, the ME values I get low values, but when I train with simulated data, I get lower values than that. So with simulated data, model accuracy was increased. And as for the conclusion, with the simulated data, since the values get increased, the data can capture so I get to conclusion that the simulated data can capture the additional patterns in the data that are not captured by the original training. And also by using this kind of prediction model, farmers, policymakers, and also the government also can use them to improve the agricultural planning and to improve the foreign earnings. But for the future work, I think I only consider here weather parameters, but it is better to consider the soil moisture, soil factors, and also there is a difference between the agricultural practices used by different farmers in different regions. So if we consider both factors, with the weather factors, I think the model effectiveness will be increased. So if we talk about the significance of my model, the best thing is there's a high potential for us to be the main producer of black pepper. So there is economic significance. We can get accurate profitability, and market stability can be increased by getting predictive information from about the black pepper yield. And if we talk about the social significance, government can provide funding allocations and also give advisory service for farmers to improve their agricultural practical works, to improve their yield. And then as for the technical significance, accurate black pepper yield and quality prediction system will help to farmers and policymakers and also for the government to improve the agricultural sector. And for the acknowledgement, I want to thank for the expert advisory, Dr. HMP Subasinghe, former additional director of Department Export Agriculture of Matale, and for the facilitation support, Rajaratnam University of Sri Lanka, and provision of data set. I want to thank Central Research Station, Department of Export Agriculture, Matale. Thank you for your kind attention, and you can ask any questions.
Thank you, Ms. Subasinghe. Are there any questions from the audience? There is one.
Hi, I have a question for you. So, did you choose LSTMs for this research to address the nonlinear patterns in weather, or are there any factors that you considered to choose LSTMs?
Sorry?
So, why did you choose LSTMs to this research?
LSTM model?
Yeah.
So,
is there any other factors, or is it because the nonlinear patterns in weather?
Yeah, there is a nonlinear pattern. Also, I wanted to find out there's a nonlinear patterns. But already in other countries, in other pepper growing countries, they have done models like they have used regression, like SVM models or random forest, like that kind of models. And also they have used LSTM models too. Normally, using LSTM models, since I have used like 30-year data, sequential data is used for LSTM model. So I think it is better to use LSTM or ARIMA model, but LSTM was chosen because it is better to use both short-term memory and long-term memory. So since I am considering like daily weather data and also annual pepper yield and quality data, that's why I use LSTM.
So your research was like really insightful. So my question is like you spoke about weather, humidity, you took rainfall, humidity and temperature. So why didn't you consider sunlight? Because sunlight is a crucial parameter of plant yield. I have seen in pepper as well. So did you keep it constant, or you try to ignore that parameter when you trying to do this research?
Normally for the black pepper, they are considering the factors, the weather factors normally consider for the black pepper. According to the Export Agriculture Department, they consider the RH value, atmospheric RH value, rainfall, and maximum temperature and minimum temperature. That's why I only consider those parameters, and within that parameters, rainfall is the best one that effect for the black pepper.
I have a question. In your LSTM model, what are the advantages than the traditional predictive models, and also what are the data gaps, inconsistencies, and errors affect your model performance?
Sorry, can you repeat again?
How your LSTM model best than the other predictive models, and also I want to know about data gaps, inconsistencies, or errors affect your model performance.
For the first question, so the LSTM model, I was for there were errors. That's why I told you when I use 30 years data, annual data, there were errors. I get the overfitting error. So that because of that I use data simulation, and then with data simulation I generate 30 annual data, and then again I did the training model, and then better than the accuracy was better than the first model I have created. So I used that model. And for the first question, there were models that have created, not in Sri Lanka, but in other countries like India and Malaysia. They have developed LST model also, but those models are only for predicting black pepper yield, not for black pepper quality. So here I have considered black pepper quality also.
So I have a question. So the question is that when you talked about the model training, you said that you run into an overfitting problem, and then you used model simulation, and then trained another one. So can you walk through that? Can you explain it in depth?
The first time I only used 30-year annual data, but for the I use 30 years annual data, and then because of that I get the overfitting problem. I generate develop two models. For quality there is another model, and for the yield there is another model, but for both model I get the overfitting problem. So that is why I did the data simulation. For that also I developed a LSTM model, and then that simulated data was used with that original data to train the model.
Two questions I have. First question is, how do you plan to make this predictive model accessible to local farmers like in Sri Lanka and other countries? That's my question. What kind of training that if you are considering to as a future step? And the second question is could your model be adapted to predicted yield or quality for other crop sensitive? So,
can you repeat? I can't hear somebody.
Yeah. So my question is as a future step of your research, so how do you are going to plan to make this predictive model accessible to local farmers and other parties? And the second question is so could your model be adapted to predicted yield and quality for other crop sensitive?
Other crops, you mean other than the black
pepper? Other than that, other crops other than the black pepper with other climate factors.
Other factors can be selected for the black pepper?
Yes.
But for the first question, I was thinking to make available this model for the policymakers so that they can inform the farmers normally how they have to grow and how to through the agricultural sectors they can give advices for the farmers how to change the agricultural practices to improve their yield with the climatic changing. And for the second question, it is better if we can use the soil moisture and also the agricultural practices, because in different regions farmers use different practices with the climatic factors they have. So if the model can develop by using those factors also, I think it is better. The model accuracy will be increased.
Thank you.
Okay, thank you very much. In the interest of time, let's stop there and thank once again the speaker, Ms. Subasinghe. Thank you very much. The next paper is on unraveling the cognitive secrets of chess experts, investigating dynamic functional brain connectivity through RS functional MRI analysis. This paper is written by Malisha Kapugamage and Dr. Rasika Rajapaksha of University of Kelaniya, and the presenter is Ms. Malisha Kapugamage. Malisha is a freelance data scientist and AI researcher with a BSc first class in computer science from the University of Kelaniya. Currently, she is involved in IT advanced data analytics and business intelligence. Her research interests center on brain connectivity analysis, computer-aided diagnostics, and predictive modeling for healthcare. Let me invite Ms. Malisha to present her paper. Mr. Malisha to present her paper. Sorry.
Okay. Hi everyone. So welcome to the most boring presentation in this conference. So because I'm going to talk about brain activity and how this works, so it's a little bit boring. So I will try to make it a bit interesting. So my title is Unrevealing the Cognitive Secrets of Chess Experts by investigating dynamic functional connectivity through RSfMRI analysis. So this research is in collaboration with Dr. Asika Rajapaksha from University of Carolina. So in this study, we are especially focused on the understanding of cognitive expertise and brain activity patterns. So I'm here to share with you all with our findings. Let's move on with the introduction. So here, what we are trying to do is, as the aim of this research, we are trying to fill the gap between cognitive expertise and the brain activity patterns. So we are particularly looking at chess players. Okay, so like we are trying to find if there are any particular unique brain patterns that can differentiate chess masters from chess beginners. So we use RSfMRI brain scans to monitor the changes in brain that can change dynamically over time. So like as of the big picture of this research in the project, I could say that our insights and our result could help to understanding of chess, not only chess expertise, but also how the expertise can develop in brain, like in other cognitive fields. And also this can help to diagnostic in neurological cognitive fields as well. So let's move on. In the background, so you all know about fMRI, also known as functional fMRI. So it's actually, this is not working. So, sorry. So fMRI is a technique that actually we use to investigate the functional interaction between brain areas. Okay, so RSfMRI is another technique, that same technique, but in that RSfMRI we try to monitor the brain connectivity patterns when the brain is not performing any task, like the brain is at rest. So it's actually useful in both clinical and research settings because it is advantageous, because when it comes to patients with young children and the patients who have neurological disorders, it's really helpful because they struggle with task instruction. Task-based fMRI is not useful here. So RSfMRI is really useful in that case. So we are already using it for diagnosing mental disorders like autism and schizophrenia and Alzheimer's. And also, in the background, we have dynamic functional connectivity. So dynamic functional connectivity is actually, unlike static functional connectivity, it measures it let us observe the time-based variations in human brain. Okay, like when it's come to each capture, the subtle brain activity shifts in the brain related to different cognitive states. Okay, so the previous methods, like that the previous methods, some who are using the static assumptions may struggle with the accuracy of the predicting the expertise classification. But we believe that using DFC we can achieve high accuracy and precise insights into brain connectivity, because traditional methods, traditional static assumption often misses interregional dynamics that can be captured by DFCs. So as a method to capture DFCs, we have sliding window technique. So sliding window technique is actually a method to divide the time series into overlapping subsample. So I talk about brain scan and time series and all. Let's talk about more. Then before that, we have our data set. Our data set is chess masters and novice, CMN in data set. So this data set has 54 individuals, 27 chess masters, 27 chess beginners. So the transformation has made to the data set is actually here. The brain scan is transformed into time series, representing 116 brain regions and 200 time seconds. So we can use this data set to assess the long-term impacts of chess expertise on brain connectivity. So let's move on. So detecting DFCs from RSFMRI uses sliding window approach. That is what I was talking about. So we are going to detect dynamic functional connectivity through sliding window approach. In sliding window approach is just mean that we have our time series. So we are going to define a window size and a slide and traverse to the scan, okay, and generate different blocks, okay. So before that, we have to define the optimal window length and optimal slide to do that. Like it will allow us to capture the correct DFCs in the scans. That's the most important thing to do. So do that. We use in technique wet auto regression with group lasso to identify the window length and the slide. So with the parameters, we have 60 to 20 window lengths and slide to 1 to 10 time points, and regression parameter is 0.1. In the process, what we are going to do is we have 610 combination of window length and slide. So in the process, what we are going to do is we are going to divide this time series into overlapping subsample. So here you can see there is a k is a window length and the k plus 1 is a vector. We are going to predict the k plus 1 using k vector. So then we are going to record that error. So as you can see, we can calculate multiple errors from all the window sizes, from all the blocks. Then we get the average error here. So then we get the error from relative Fabinus error. Then we got 0.011556 error with optimal window length of 64 and optimal side is 1. So that's how we found our pair. Next, using that pair, window length and slide. Now we are going to use sliding window and divide out our time series into overlapping subsample. So then if our window length is k, then slide is 1, we got R number of overlapping subsample from one scan. Okay, so then what we're going to do is using those, we converted those blocks into a correlation matrix for each block. So we are going to have R number of correlation blocks is right here. Okay, then we are going to convert those R number of correlation blocks into average correlation matrix. Like we are going to average them. Then we are going to have 54 average correlation matrix because we have 54 subjects. Okay, for each subject, each correlation matrix. So then we are going to convert those average correlation matrix into patient matrix. Then take the vectorize the upper triangular entries into 6,676 feature vector. So as you can understand that we have 54 feature vectors. If you represent it from tabular form, you can see that we have 54 subjects and we have 6,676 features. Then we can use feature selection methods and we can go to the classification. So before that, we have feature selection method. We use Wilkinson rank sum test here to select the most discriminative features. So in this test, we use some novel methods because we use a sampling approach to increase the accuracy of the discriminative features. So it's similar to bagging in machine learning. So we take random samples of 10 subjects from each group, then we apply the WR test, and then we select the intersection of all the tests we have done. So as an outcome, we got generated of set of 71 highly discriminative features. Next, we use SVM classification. So this one is actually because we have 71 discriminative features. So it's actually high dimensional. So SVM is really suited for that kind of case. So then we assess the model using 10-fold cost validation, and we aim for robust model performance and generalizability. And also we got 96.33% accuracy. It's a high accuracy, and also with high precision, high recall, and high F1 score as well. This actually represents the generalizability, balance, and the effectiveness of the model. Next, as objective and achievements, we got high accuracy in 10-fold cost validation, and also this actually improvement of 10% 88 over prior research with RSFMRI data alone. And also we got improvement of 8.33% improvement over method that combine RSFMRI data and T1 weighted MRI data. This is actually quite an achievement, and it's an achievement for me as well. I did this research as an undergraduate. These research I have done in like the PhD fellows. I'm really happy about I can achieve this accuracy using my novel method. Then as a key contribution, I got highest accuracy, and also I identified 71 features that as the most discriminative features, because this actually highlights the essential dynamic functional connectivity in the chess expertise in human brain. Then, as a significant of findings, the model higher accuracy demonstrates its potential for application in cognitive classification tasks, and also that identifying inferential brain regions linked to 71 features could reveal the neural correlates of chess expertise. That means if we can backtrack those 71 key features, what we are going to do is we are going to identify what are the brain region behind those key features. That means we can do the map to critical brain regions for these features. And actually this will could help to advance cognitive neuroscience, contribute to clinical insights, and also aid in interventions for enhancing cognitive skills as well. Next, if we talk about more about this one, I have time. So now we are right here. We have reduced our dimensionality. We have 71 features. Now we are going to do is we are going to backtrack over to here to identify the brain regions from those features. So actually, after identifying those brain regions, we can analyze the connection with non brain networks like default mode network, silent network, and executive control network. And also, there is a potential to identify new brain networks related to chess mastery or cognitive expertise. It's actually the next part of the research because the methodology is all developed. I just have to map those features into the brain regions. Next, as a few directions, also I have data set for autism and schizophrenia as well. The methodology has developed. I just have to apply those methods to autism and schizophrenia data sets and develop classification model for medical diagnosis. And also, we can do the same thing with mapping the brain regions to understand neural signatures of these conditions as well. And also, this autism and schizophrenia is medical related, not like chess mastery. So it could advance us in personalized treatment and cognitive enhancement as well, and also new insights into cognitive and neurological functions. So thank you so much. If you have any questions, you can ask about the method or the accuracy or anything, you can ask now.
Thank you, Alisha Kapugamagi. Any questions from the audience?
Yeah, you mentioned you used 54 sample, and in here when you considering the sample, did you consider the demographic factors like age and educational level which affect to the brain connectivity patterns?
Yeah, this data set is released by Xi'an MR Research Center at West China Hospital. In this data set is publicly available in FCON 100 project. So this data set is actually age and gender well matched. So we don't have to worry about it. So we don't have to worry about demographics and everything. This data set is catered for research. Yeah, that's my answer. I think I got. Right.
So I have a question for you. Why did you choose SVM over deep learning method?
That's a really good question. I was ready for that actually because everyone is asking when I'm explaining this research. Everyone is asking that question. That's the main thing is we only have 54 brain scans. This brain scan is really expensive. In Sri Lanka, we don't even find RSF MRI. When I'm talking to a doctor, actually, I was talking about RSF, he was like, no, Sri Lanka, we don't have that one. Like, it's really expensive. So with that kind of cases, like, I actually use deep learning at the first. But thing was, the accuracy was less than that because machine learning always outperform deep learning when it comes to less data. So what I'm going to do is, I wanted to achieve high accuracy with low data, and also this is really expensive data. We can't increase the data set, and this medical data, so because the medical like data augmentation may work, but I wanted to go with machine learning because I thought that it will be the most suitable for this case, and I think I did done it. So that's my answer. Yeah, I actually experimented that. I experimented a lot of algorithm. Like I not directly go to the SVM. I use several feature like dimension reduction techniques as well. I didn't just go to the WRS test. I did all the things like I got 1 year to complete this research and extensive work. So I tried everything. Then this is the best approaches I got so far. Thank you. Any more questions?
I have one question.
Sure.
Now, chess playing requires some concentration by the player.
Definitely.
So why don't you measure it through a EEG signal-like thing rather than a MRI?
Here, I am particularly interested in how the brain works in chess players. I'm not targeting on chess players. I'm targeting on the brain actually, because I wanted to do my research. This is my final year research. This is my thesis. I want to do my thesis in the brain, theater to brain, and how it works. Then I got this data set from my supervisor. Then I started to work on it. So here I am actually particularly interested in how the expertise develop in brain, not the chess players. But the reason why I use chess players because the long-term chess playing is helping, like he's making us our brain to change the patterns in brain, like the cognitive states, to change the cognitive states in brain. It's actually proven in literature papers. So that's why I got the idea to do it in chess.
Okay.
We could go with other skills as well.
Okay, thank you very much. Let's.
So I have a small question. So you talked about default mode networks in the last part. So in your data set, did you have the chess players at the same level? Because if they are not in the same level, that means their default brain networks are different, right?
Could you repeat your question?
So in the last part, you talked about how training can affect the default brain network. So if a chess player who has participated in this chess for 10 years and compare that to a 2-year chess player, then the data set must have, the chess players have different default brain modes.
To clear that out, I didn't mention anything about the training could affect to default mode network. So I mentioned that when I backtrack my identified features to brain regions, What I'm going to do is I'm going to analyze those brain regions with the brain regions that are available in default mode network. I'm just going to see the connection between that. Like if it is a connection, that's what I'm going to identify using that.
Thank you.
Any more questions?
So if there are no other questions, let's once again thank Mr. Kapugamage for...
Thank you so much. I want to mention something. I want to say my gratitude for my supervisor, Dr. Asir Rajapaksha. He's not here today. So he's helped me a lot to do this research. And also I want to thank you for the organizing committee, to ICTer organizing committee to give us this opportunity. Thank you so much.
Thank you. The last paper in this session is titled Debiasing Hate Speech Classification Models for Queer Language Through Keyword Analysis, and it's done by D.S. Yahatugoda, Rupika Vijayasinghe and Ruwan Veerasinghe of the UCSC. The presenter will be D.S. Yahatugoda. Dilhara Yahatugoda is an information systems graduate from the University of Colombo School of Computing. His research interests include natural language processing and machine learning. Currently, he is working as an associated quality engineer at Cisco Labs. Mr. Yahatugoda.
Good evening everyone. I think this is the last paid presentation, so I'll move on with that. So my research is devising hate speech classification models for queer language through keyword analysis. We'll first take a look at what we are trying to do. So as you know, usually in marginalized communities, they face a lot of discrimination in various aspects of their life. A lot of very important things like healthcare and education. So with these things, with the innovation of the internet, there are new safe spaces for these people to discuss their things. Share their experiences and share their thoughts on various different things. So, but there are a couple of problems regarding when they are doing that, because there are various moderation techniques that are implemented in these, especially in social media and news websites. They are implemented to sort of keep these conversations and expressions sort of in a safe way, without harming anyone. But with the inherent issues in various data collection methods and training methods, there are biases that alleviate in these deals. So what we are trying to, so people have looked into how we can reduce these biases. So they have mainly focused on racial identities and women-focused debiasing techniques to make it more fair to those people. So, but when it comes to the queer community, there aren't a lot of studies that have been conducted in this regard. So when I say bias, there are some examples I have shown there. So in the this first sentence there, it says that there is a big difference between a Muslim and a terrorist. And in these hate speech identification models have categorized this as a toxic statement with the confidence score 73. So even though that is not really a hateful comment, it has identified it as hateful because it contains the words Muslim and terrorist. So those two words sort of that are can be found in a lot of hateful speech things. So even when someone says neutral thing. These models categorize it as a toxic without regards to the overall context of the message they are trying to convey. So that is the bias. That is the bias in these systems. So I have. There are a lot of models that are developed to for these specific tasks like HP detection, and one of the most popular ones used and most successful ones used are these bird-based and overload mostly transformer based models. So for my research, I have focused on bird-based models only. So I think we can skip this one. So for the research question, we will be mainly focusing on three things. First one is how we can identify hate speech model behavior concerning queer comments and extract synthetic keywords. So like I showed earlier, the Muslim and terrorists, those can be considered synthetic keywords. So what I try to do is identify what are the queer specific keywords that we can extract from these models. So, and like I mentioned earlier, there are several studies that have conducted to reduce the biases of racial and women-focused biases. And I tried to apply those methods in the queer context to see how they perform with this context. So finally, we try to, using those methods, we try to find a more effective model that can differentiate non-helpful and hateful comments in regards to this community. So in this literature review, this is twofold. So one will focus on how we can identify the biases in these systems, and also how we can mitigate these system biases. There are several studies that have been done to identify the biases in these systems. So there are in this perspective API is one of the most popular hate speech detection models, and researchers have found that even in that one there are biases regarding sexual orientation and gender identity, as well as racial and women-focused biases as well. So they have actually, this is conducted in 2019, but they have improved that on their side as well. And there are also studies that found that this is one of the problems we are trying to do, is that when there are like curse words or profanic words, these comments are usually tagged as toxic, even though they may be a normal expression of a certain group of people. But since the profanic nature of those comments, they are categorized as toxic. Yeah. Also, there are also people have tried to do like post-hoc explanation algorithms like Lyman-Sharp, like it will give out why this model has arrived at their conclusion on why this particular comment is hateful or non-hateful. So the people have tried to use this as like a feedback loop between to and fro to reduce these biases. Yeah. So in terms of mitigating, people have also several studies conducted in trying to just like apply regularization techniques, as well as change the sampling and like sort of do reweighting and oversampling, those sort of things. The people have also conducted like information web, where they have looked at specific users and their comment history to build a profile on those users, and then when they comment something, those comments will be contextualized against those previous comments they have made as well. So it's an also interesting study. And people have also done things to apply more context to these comments, such as applying POS tags and name entity tags. Those things they have tried to apply more contextual information before they try to detect if it is a certain thing is hateful or not. So in the final one, this is very similar to what we have done. So they have looked into the African American English dialect and how they can sort of reduce the biases against the African American population in terms of these models. So they have applied adversarial learning method to alleviate these biases. So we have applied this method to our own research, so we will talk more about that now. So the methodology mainly focuses on four phases. One will be we need a data set first, so we need to annotated hate and unhateful annotated data set that we can identify that are made or mentions queer people. So that will be the first one. Then we need to sort of get these comments and try to do the keyword analysis to extract the sensitive words and phrases that are common in them. And then we need to we did train the model to identify queer comments, like if it has a queer context, we try to do a method where it will identify if it is relevant to the context, and finally we will with the use of all these methods we will do the debiasing in a couple of different ways. So we will go more deep into that. So for the hateful and non-hateful annotated comments, we have got the civil comments dataset. That is a very popular dataset, and in that dataset there is a subset of that where it has also like racial, sexual annotation, and those things are also, identities are also labeled alongside the hateful and unhateful labels. So we took that subset of the dataset as our main dataset. Then also to understand sort of like sort of get like a queer context and those sort of things, we got comments from Reddit, from the LGBT subreddit. So in that we also got like a casual conversation subreddit comments as well, to sort of see if we can differentiate these two subreddits from a model. So we took comments made within a span of 5 months in 2019, and this is related to the that civil comments dataset. In that dataset we had hateful and unhateful comments. So these are the split between train and test. For the hate speech model, we needed to get a model that was not trained on the specific dataset we were trying to train on. So we got this Roberta-based hate speech model. It was sort of developed in a sort of in a session and those sort of things. So it was not these datasets were not used in that one. So we tried that. We got that model as the base model for our research, and when we got that comments from the subreddits, we got those comments and cleaned them with the like regular filtrations, and then we spread them into the hate speech model, and we identified what are the hateful, what are the comments that are being tagged as hateful, and that model also shows a confidence score. So for the confidence, if a particular comment was tagged as hateful with a confidence score of 0.5, we considered that as hateful comment. Then using the harmonic mean of relative frequencies, we extract the hateful comments. So it basically looks at what are the keywords that are in the hatefully tagged class in relative to the non-hateful class. So in that way, it will more representative with the more frequent words in that hateful class. So we extracted those words with this method. And when we did that, we only like 8% of the comments were tagged as hateful. So in that way, we identified several identity keywords as well as neutral keywords that were mostly prevalent in hatefully tagged classes. So we will also move on with these ideas. And we also needed some model to identify if this comment is related to like a queer context or a regular non-queer context. So we tried to use that Reddit data to infer a model where it can identify if it is queer or not. In the debiasing, so now we have the dataset annotated to hate speech, and we have the specific keywords that are very sensitive in regards to the model we chose. And we also have a model that can identify if a particular comment is related to the queer context or not. So with those three things, we move on to the debiasing section. So in this one, we mainly did 4 types of debiasing. In that, so the first one was in that data set, we in the hateful and unhateful data set, we extracted the comments that contains those sensitive keywords, and also we took a subset of that which didn't have any sensitive keywords in those comments. And also we did like a adversarial debiasing as well, where we sort of combine the output of the classification, like hate speech classification model, and as well as the queer context model. We got the representations of those 2 models and concatenated them into an adversary for this one. So in the combined representations one, that is the one I talked about, and in the base representation, we don't regard the queer context, we just do the classification in the adversary. So this is like a high level one with it. This is I took this diagram from that African American dialect paper. So this in this one, you can see that when we input a comment and a label to the hate speech classifier, and also we can get whether in this one it is related to African American dialect. So we can similarly we can use it to the queer context as well. So in that we can use these 2 classifiers into a sort of network and do the adversarial training. And after we did that, we found some interesting findings. So in the base model, you can see that the F1 score is very low, because we in the evaluation data set, we only focused on comments that are relevant to that contains these sensitive keywords. So we needed to see how our debiasing techniques will work with the sensitive keywords will work with the base model. So in that, because in the base model is not very good at identifying those words, so the F1 score is low on that one, and the final score here meaning is that I mentioned earlier, like a perspective API, so they conducted the debugging competition on Kaggle. So they gave like a final evaluation into measuring the bias, where they will it will take like each identity group's AUC values, and then they will calculate them all into a harmonic mean, and it will give the final calculation. So in this one, so this final score is basically all the AUC scores for each identity group is combined.
Mr. Yahatugada, yeah. Yeah, finish off quickly because we are running late. You can present your conclusions and then we can.
Okay.
Yeah.
So we can see that the method we tried without using sensitive keywords, it didn't really impact the base model's performance in regards to those sensitive keywords. But when we tried to do more context into these keywords, where the non-hate and non-hate categorizations were both included in the test data, we can see that the overall F score and the bias score have been mostly improved. So that showed the most improvement out of all of these models. And in the adversary methods, we can see that both of those methods were sort of similar in their results. Even though it showed the base improvement of the base model, it was sort of similar in their results, because I think there are several reasons. One is the context identification model was not up to, I think, standards. I think that's one of the reasons this adversary was not as improved. So these are the findings. So this is basically what I talked about. And to see whether our debiasing has any impact on like a generalized hate speech data set, we inferred this hate check, which is like a benchmark data set for measuring hate speech detection. So we did that, and we can see that the base model has pretty good performance in regards to that context. And the here also we can see that the hateful without keywords method also didn't really have an impact on the overall final results. And we can also see that even though we reduce the bias of the system using the third method, it reduce the F1 score of a more generalized data set, but it is not as decreased as the adversarial two methods. So those things here also, that adversary not being the contextual identification method not being as robust might have played the part in here. So
okay, then I think it's time to stop now. So let us, sorry to stop because we are running very much late, so for the next keynote speech. So let us once again thank Mr. Yahatugada for his presentation. Thank you very much.
That was a highly enriching session of research presentations. We thank all our presenters for their contribution. And now I cordially invite Dr. Anasinghe, the session chair, to award the certificates to the presenters. We now invite the following researchers on stage to receive their certificates. Nirmani Subasinghe, Malisha Kapugamage, Dilhara Hatugore, thank you very much, Dr. Anasinghe.
Our next keynote speaker is hailing from the Nanyang Technological University of Singapore. With over 20 years of experience in high-performance systems and cybersecurity, Professor Srikanthan has made impactful contributions at NTU, founding the Center for High-Performance Embedded Systems and later leading the Cybersecurity Research Center in partnership with Interpol. His research, spanning 490 plus publications and innovations in sectors like public transport and medical device security, has earned him the Singapore government's Public Administration Medal. Please join me in warmly welcoming Professor Thambi Pillai Srikanthan to the stage.
Good afternoon to you all. I've been waiting for this since this morning and choose a time in which you are all very tired and weak and not wanting to listen. This is the easiest thing for a presenter, right? So that's the game. And I also drank a black coffee just to keep me awake. I only had about 2.5 hours of sleep, having arrived early this morning. And anyway, just try and, the other trick a presenter does when he doesn't want to cover anything is to cover too many slides. I have too many slides too, all right? So let's see how it goes. I'm going to take a slightly different stance, maybe because I can call myself respectfully senior or you know, been in the game for quite some time. I've seen many things. I've been Dean of Computer Science and Engineering School at the Nanyang Technological University for 6 years, completely revamped the computer science curriculum, and it's going very well, and we are 6th best school in the world. And then I was dragged into the president's office to lead the Cybersecurity Research Center at the university level. So there are some experiences of traveling to Israel very often, dealing with eminent professors at Technion, Tel Aviv, Ben Gurion. They are still good friends and cutting-edge research, especially in cybersecurity. I've collaborated with them, have done quite a bit of number of research programs. So thoughts from there. And then I have also worked with the government agencies in Singapore. So it's a kind of a mixed flavor of things, help me think at a higher level. So I will be painting a broad brush. Quite a lot of this will be reasonably obvious, but I will drive home opportunities for disruptive innovation. And also I will drive home my personal experiences in a couple of startup companies, one in mobility intelligence, the other one is in cybersecurity. And I'm about to start a third one. And the first keynote speaker, Dr. Nabil, said, why do you do this? I still haven't found the answer. It's not money. I think we want to try and solve difficult problems. I think the most difficult thing to do is to start up a company and succeed. All right, so I will have a blend of experiences there, and I will put this broad brush and hope I can kind of ignite some interest that there is a lot more there, and it's not people with abundant R&D budget who can succeed. I think we all can do that, right? So that's where we go. Now, I was fortunate enough to listen to Dr. Nabil this morning, and so security for AI was one of the subtopics, and I decided to change it at the last minute. I said, he's covered enough on that. There is no need for me to do that, but I haven't removed the slides, but I will just pass it. A section I removed, knowing that talk is going to be too long, is on intrusion detection. So I thought I'll bring that in and give you a slightly complementary flavor to that. Okay, so this is how the talk is going to go. I'm going to paint what the ecosystem is trying to tell us. I will also paint what Singapore is trying to do in being one of the highly connected ecosystem, trying to pave towards this smart city agenda, working very closely with the government agencies. What are they thinking, and where are we going with that? What seems to be the items that are concerning them? It's not the researchers coming up with innovations, but are they going to see a sustainable city as a result of these disruptive innovations, right? So we will be covering that too. And just bear with me, and I don't know where I'm going, but I think we will see. All right, so just a quick background. I'm primarily from the embedded computing systems, computer vision, and so on. And embedded computing systems is my bread and butter background. My startup in 2016 in software vulnerability analysis and hardware security got me to be a little bit more acquainted with cybersecurity. I will share with you what we are doing. And incidentally, in case it slips my mind, one of my grad students right now in California, when I interacted with Dr. Nabil, he was also from California, and then only to share with him our sense of pride, his idea coming out of our startup, and he broke away, and I'm still part of the journey. He was selected by YC Combinator. I don't know if you heard of this eminent investment group betting on credible topics. He's in California being prepped up for the next round of investment. He was given $500,000 USD check just on one idea that he is going to go. So in case it slips my mind, I'm just trying to motivate you all to know that these disruptive outcomes are very possible, right? So right now that is happening. And so that's based on the startup. I've been an academic, not by choice, but then I have to make a living. So I've trained about 50 graduate students, PhDs and masters by research, not by coursework, and ended up publishing 400, I think that's close to about 500 papers now, but whatever it is. And you can see below, I've been very fortunate because it happened to be all in Singapore. Those are just the three recent relevant ones I put up. More than $20 million of hard cash given to me to do whatever I like, okay? Well, if you claim to wanting to do credible research, but at the end of the day, you do whatever you want, right? So you can see that sizable grants and opportunities. So we were blessed to be able to try a few things, sizable activities and so on. All right, so a little bit of a startups, and those are the names. I don't want to go into the details. And then you can see I was also lucky to try and get a couple of medals from the government of Singapore, which I think is very nice for the public administration. This is my contribution to academia. Okay, so where am I from? I am from a College of Computing and Data Science. It's a recent name. It was from Computer Science and Engineering. By the way, I'm Sri Lankan by birth. I've left the country very early. Accidentally somehow ended up where I am right now. Okay, so over here, you can see the growth of the school and the college. And there's nothing, I needed to say that because they are paying me for my travel. The future begins here, they say, and we do broad spectrum of applied computer science, all the way from custom computing on the right-hand side and all the way to AI and data science. We are ranked number 2 in the world in data science, and 3 of the faculty I've hired during my deanship are marked as among the top 10 scientists in the world right now, and so on. So we do quite a lot, and it's a big school. So when I said I was heading a particular school, I had to deal with about close to 3,000 students, all right, and that many more faculty. And one of the important things I like to watch is the top right-hand corner. You see, the difference is that we are inundated with research funds. Right now, faculty, there are about 100 of them. They are holding 300 million Singapore dollars of R&D money. That's being quite nice, $3 million on average per faculty. This is never heard of. Well, I have a little bit more of that share, but on average, we are talking about 3. Okay, so this is the backdrop, and then let's go into the digital transformation. I think this is a slide I stole from the web, and basically you can see the connectedness and all that is unstoppable. We are now looking at something like, in 2021, mobile phone users and total population and internet users. And 2024, you can see it's only growing, right? It's keep going up. So what is happening in it is that we are becoming more and more connected, and that is inevitable. And can anybody stop it, put a brakes to it? No. All right, it's going to happen. All right, it's happening right now. And the other thing that you need to also understand is, yeah, we got this kind of a connectivity going. Is it getting saturated? The answer is no. We have the 5G now, talking about real-time connectivity of IoTs and whatever. And they say, look, it's up to your imagination to disrupt and innovate, right? It's all there. By the way, computing is at the cheapest, right now. Computing cost is so cheap. This is why AI, although data science got invented, tens and tens of years ago, now suddenly resurrected to become the fame. It's because the computing cost has dropped significantly. Affordability is there now, okay? And computing power and the computing performance at affordable cost is where it's gaining its popularity. We have to understand that. Industry people look at it that way too. Now, so if we are talking about all these kind of a productivity and connectivity and also, ecosystem that is not going to stop. And of course, we are talking about 5G, and how about the 6G? It's about 3 to 5 years down the scope, and they are thinking about even greater stuff. All right. So if you take the 5G network, what they talked about, would be a reality, is a reality right now. We see this kind of tremendous real-time connectivity and so much bandwidth to try and connect, large number of systems. It was a vision at that time, whether we can connect lots of these kind of IoTs and try to do some clever things. And why are we doing it? I mean, end of the day, the motivation is to make money, right? So people are, for example, I'll go into the details later, but if you take the public transportation system, if somebody could run it more efficiently, because you have a connected infrastructure, you know when to schedule a bus, what kind of a size of a bus you need to schedule for a certain times of the day. If you could do these kind of clever things, because you can make informed decisions, if you could do that, then great, right? You save. Your profitability might go up, or you enhance the overall scale of the operations. And this is what's motivating them. End of the day, you must, when I used to teach embedded computing systems, what is the right choice? And the answer is it depends. It depends on your affordability. It depends on all the other constraints. Likewise here, why people are doing them, the bottom line is money, to make more money, right? So we have to think like that, and that's what's driving them. So it's not going to stop. And over here you can see this is the kind of a wave we are in. And in the wave, I just highlighted the fact of physical and digital convergence. And physical and digital convergence is something that is happening faster than we can cope with. Maybe I'll go into try and elaborate a little bit more about what I'm trying to say here. Right? So if you take the IT and OT, predominantly they live separately and they used to live happily. And OT, it has its own software, operating technologies, and they are built once and put aside. Nobody connects to it. It does its job. Even in theaters, operating theaters, you have medical devices and systems. If you are going to go for a knee replacement surgery, there are things that for laser cutting and whatever, there are softwares and algorithms running. They are left alone, okay? And nobody connects to them. And that means no cyber threats, right? Because if you are not connected, unless otherwise you have physical security concerns, nobody's going to harm it. But even the top medical device and systems providers are saying, oh, I need to learn how my system is operating in the theaters. I can learn from the data that I collect. I can tune the algorithm. Oh, even better, I can sort of remotely configure that medical device or the system so that, you know, I am always remain at the top of the game. You can call it as productivity. You can call it as makes common sense. But when you connect, there comes the conundrum that we got the headaches of cybersecurity threats, right, and worries. So is this happening or not? It is indeed, because you know people, even big companies, are making major decisions. I've been consultant to a major medical company in the US and so on, and that's exactly what they're trying to do. And the problem there is, conventionally, the OT systems that are built never have this kind of a maintainability context in mind. Even automotive electronics, you know, they are built OEM products. You don't know who wrote them, compiled binary codes, they are running. Did anybody think about having to maintain them because vulnerabilities could creep into them? The software might decay because somebody found new vulnerabilities. There are no mechanisms. So they are catching up, but legacy systems are there, and we have a conundrum of having to connect them and as a result introduce more problems. Okay? So this phenomena is taking place. So the IT, yes, we understand DevOps and DevSecOps and whatever and all sorts of things, and we've gone crazy with open source, and we are talking about, again, in the name of productivity, we rely on open source for rapid development, first to market. All that is great. But the problem there, indeed, is that we worry about the issues later if the code decays, or we found a way to, we find a way to fix them. So this phenomena is also happening while we are being encouraged to connect more and more systems together. So there came the edge computing as a result, right? We are now talking about feeble, simple, very weak, highly constrained embedded systems, IoTs. They need power to make intelligent decisions. And then you came with the edge computing and keeping the computing resources at the edge of the network. Now, this essentially means that you have a dearth of possibilities in making all these humble devices collaborate with each other and provide high order of intelligence. And so that's exactly what's going on. Okay? Now, what is happening here? We've got a problem again. We've got a weak system, highly constrained, in terms of power consumption, processing power, whatever, but they are equally susceptible to attacks, right? And if they're being attacked, the weakest link, we are doomed, no matter what we do about securing all else. You have a weakest backdoor, you are doomed. Okay, so you can now begin to see people are not worrying about this. They are going around making things happen, in order to try and enhance the productivity, eventually the profitability, and then people are saying, the rest of the problem is someone else's. Okay, so this is one classic example where you have, these kind of robots working, There used to be a manufacturing line, they do that. Now they've gone on to starting to collaborate, do things more intelligently. Just bear with me a second. My throat is important for the next few minutes, right? So. Okay, so you can begin to see now phenomena of, why do you want to do it? You want to make the cost of production cheaper and less prone to error, more optimization, so less wastage and so on. And now you can begin to visualize this edge intelligence is allowing all this to happen. So OT and IT are kind of converging, and it's inevitable, right? It's already happening, and it's going to be the way of life. No going back, no kind of air-gapped systems anymore. Right, so you can see that industrial IoT market is growing exponentially into trillions, and it is to be expected. And so now people are talking about, if I do kind of an Internet of Things and edge intelligence, why not talk about Internet of Behaviors? This is all very possible, because now you're trying to do IoT, artificial intelligence, machine learning, whatever else, you're putting them into a mixed bag and say, what interesting possibilities can there be? All right, so I just want you to take note of what's really happening. The physical-digital convergence is inevitable, because driven by, you can call it greed or money or whatever, it's happening. No one can stop. By the way, I do work with the #1 automotive industry in China, #1. Yeah, their revenues in billions. I'm collaborating with them on R&D. I'm the lead PI on cybersecurity research and worries and concerns. Only last week we had the management committee meeting with the industry practitioners. So fortunately in Singapore, you are not talking about abstract research, you are talking about something that the industry wants. And I can tell you that's very different to, the challenges and problem statements are very different to academic research. We had to kind of trying to let them converge. So this is happening. So here is the mega picture. Physical world and digital world, it's all now getting connected. Now, the only conundrum here, in fact, is the fact that transformation market is going up. It's not digital disruption, it's a digital transformation. It's going up. And the OT systems are always lagging, somehow people connecting it, and there has not been properly thought out OT systems that has to be brought in. Can you change them overnight? No, it's not that easy. Can I go into the electronics that have been perfected by Continental or Bosch for the automotive electronics? Can I go and change them overnight? No. What are they trying to do? Please tell me how to find vulnerabilities, because I am being exposed, because things are connected. And someone's going to get into there and they might compromise their reputation, right? It's not easy. So how do you do this, right? This is what got us to do our spin-off, okay? We were able to take some binary code, we can reverse engineer it, we could identify vulnerable codes or bugs or security bugs or patches, and we learned how to fix them. I led that particular program. My colleague looked at it from open source vulnerabilities and software composition analysis, and he tried to fix them, and we came together and we managed to even go far as getting Series A funding, all right? So this is the problem I want you to sort of take note of. Now let me just quickly switch to the AI and IoT kind of a conundrum, if you like. So in here, this is the mixed bag I mentioned, right? So people were asking, what can we do with IoT to become more intelligent? Okay, they call them as AIoT, all right? And this is, we are also guilty of contributing or disrupting the world, and I share with you in a few slides that I have here. So we had a mandate. In here, we about 2017, about 7 years ago, I managed to win $46 million, real cash. From whom? From the government, right? To do what? With a German university, Technological University of Munich, trying to come up with intelligent transport system for Singapore. right? We kind of painted all sorts of stories and, managed to grab the money. What did we do with them? Part of the story is this, right? And the idea was, can we one day have a kind of a demand-aware dynamic navigation? Because we are all connected, right? And I know what I want to do, what my journey is going to be. I know where I want to travel. I just, sort of, put forward my demand. Then what about the bus stops? If people are standing at the bus stops, I watch it and keep watching at it and say, how many people are there at certain times of the day, right? And you aggregate these demands. If you can aggregate this demand, you can offline train them, and then at best say, in the near future, on Wednesday morning, this is the likely traffic that I'm going to expect. Of course, there can be changes, but then you schedule. And then you keep on learning, and then you turn around and say, why have a fixed timetables and timelines where you see empty buses and all that? Why don't we just make it all fully connected? And can this be possible? So I took up about $7 million out of $46 million. I was the program director. I was also principal investigator to that. I had some group of people, and we went, crazy, and this is our campus, and we took some photos of our bus stops. And then here we ended up just simply having developed a tiny ML-based IoT using mobile chipsets. These are my students. They developed them, and there you have a real-time in a crowd estimation system. And MAE is less than 1 person per frame. We got it working. We installed them on campus. I got the permission from the president, we installed them, and we were just aggregating demand. The beauty of this is that it's a privacy-preserving technique. It doesn't record anything. It doesn't record about, and it doesn't intrude into people's privacy. It's just real time. It calculates and aggregates, estimates the number of people there, and then sends it across for offline training. We then said, okay, let's take a shuttle bus route, identify the bus stops, and we mount the cameras. This is basically based on mobile chipsets, right? A 4-core processor arrangement. We pipelined it. We stretched as much as we could on the resources, limited resources. Low power consumption, remember, the mobile chipset world is the advanced, right? We took them, it's our Droid board, and our students implemented them. I just wanted to inspire you all. This is something that we ended up doing for real, and I wanted to demonstrate that. So you can see that the live demo. Now, one led to the other. We ended up having this kind of technologies. So we ended up, unaware to ourselves, built AIoTs, okay? And then we could have crowd estimation, we can have intelligent pedestrian crossing, and then we can measure queue lengths and illegal parking detections. For example, in the bus stop, if there was a car stopped, if the bus is coming, you give a virtual right of way, let the car get out so that bus can move without wasting time getting into a jam. And, this is, on the top left, you can see that we used a very, very lightweight deep learning system, and then we managed to come up with an affordable sensory system, right? Affordable is the key. If I could have solved it using a PC and then demonstrated it, no excitement, because you cannot do it at scale. You need to mount them in all the bus stops, right? It has to be cheap, and it has to be affordable enough. So once Google X came to our university, just a thought coming to my mind, and they said, oh, we have to come up with something so disruptive, something so impossible to achieve, we got to go after. That's a Google X project. Very bright group of people. And they were touring the universities. They came, and I was pulled in to meet them. And in that conversation, I basically turned around and said, why don't we do this? Can you, at that time I was doing pedestrian collision avoidance system for vehicles. I said, can you all go about trying to come up with a, nothing out, blue sky, get down to the practicality. Can you come up with a pedestrian collision avoidance system for less than US $50? Key. And they all stunned. They all looked at me and said, yeah, that's a difficult problem, isn't it? How are you going to do that for $50, right? So I think we have to turn around and bring about the right kind of constraints, including the price point. The moment you do that, it requires disruptive innovation. Okay? So we come up with something like this, and we ended up having a pedestrian crossing system. So what we do, again, this is again photos from our campus. We managed to real-time detect pedestrians waiting to cross the road, and then we also detected real-time the oncoming traffic. So we decided to be the virtual assistant, deciding on when to control the traffic lights to be able to have a seamless movements of pedestrians and the vehicles. Okay, we done that. And so over here, I think you can see a bit of a demo. This is, I know exactly where it is, but you may not know, but you can see we done that. We are able to detect this vehicle's presence. The beauty is these are not done on a PC, please understand. I think that's not a problem. Okay? We managed to do that on a tiny thumbnail chipset. Okay? One single chip, and we managed to do that. So this is the part. And by doing that, we could then propose to the Land Transport Authority, well, why not have these intelligent pedestrian crossing systems? And we managed to stir it all up. So what am I saying? IoTs becoming AIoTs can lead to disruptive innovation, right? These are all leading to what? Connected systems, right? Or connected infrastructure. Knowingly or unknowingly, we are disrupting the world, right? To be able to move in that direction. All right, so we went on to mount cameras all over the place, and this is a real story I wanted to share with you. These are all efforts from the students, all right? Now you can just sit and imagine how many solutionings, that can come from this kind of a core work, right? And suddenly you see a new business, right? Okay? Opportunities rather. And if you take the autonomous vehicles, for example, same thing. We need to know. Autonomous vehicles are not that intelligent, right? They are barely surviving, even in the latest technology, how to reverse without crashing into something, how to autonomously drive. You heard Dr. Nabil saying how easily they can be spoofed, and all sorts of problems, right? Still goes on. But at the same time, the auto industry is pushing for this. Autonomous vehicles shall be it, right? But there's a lot of worry, a lot of apprehensiveness. And so you can see now there are, the personal mobility devices and the red circle there, somebody traveling on these electric mopeds and so on. And if they're coming along there at a pace, cross the road. And these are very accident-prone problems in Singapore. And will the autonomous vehicle know this? What is around the corner? But what if we were to have sensors, then do inform these autonomous vehicles in a timely manner of the impending threat? If you can do that, then we are moving towards a safer ecosystem. So these are real problems that automotive industries and land transport authorities are currently looking to arrive at affordable propositions. This is very important, right? Affordable propositions. So this is all ongoing work. Now, one of the recent requests by the government agency is a Land Transport Authority, and I think URA, I think, stands for Urban something, right? Authority. Urban Redevelopment Authority. I'm supposed to know that. It's just my lack of sleep. And ST Engineering is a big company. They're all coming up and say, oh, the bus stops of today in Singapore are not AV ready. They're not AV ready. Why? Because you can look at these taxi drivers hanging around and people not in an orderly manner. AV is supposed to navigate this complex system and park safely. And they said, this is not going to happen. AV is going to get stranded or stopped further back. It's not going to have this intelligence of maneuvering in a mixed traffic environment. It's not capable. So right now, it's a problem, research problem the Land Transport Authority wants to solve. How can we solve this? We need to have AIoTs, all connected, collaborating, and making some timely, information sharing to the, oncoming vehicles, autonomous vehicles, and so on. So you can begin to think now, even in the transportation sector, the connectedness is only going to get worse, right? Is it, by the way, critical? Is that kind of infrastructure critical? Absolutely yes. Because if I do something and cause an accident or whatever, disrupt my critical transport network, I'm disrupting the entire city if you're not careful, right? So we have to be careful. All right, so this is one of the recent things sort of interested me. Who are the other culprits? Us people, right? We want more and more and more, and recent survey indicates that 80% of the US motorists want AI voice assistance. Well, how are we going to get that done? All right, talk to me intelligently, tell me what to do, how to respond. So you can see the multimodal information that he should aggregate before he can serve the end user wisely. This is current demand, right? So on one sense, I'm painting an exciting development of intense connectivity, and this connectivity at large are all going to become critical, and we need to try to secure them, right? So I'm not talking about AI for security, I'm just looking at the entire ecosystem here. So you can see global AIoT market is also growing as a result of all this, right? Okay, so let's take a look with this kind of a backdrop, what the infrastructure landscape is looking like. My watch is running on Singapore time. I don't have any idea where I am, how far am I into, which is a good thing, right? So I'll keep talking. All right, so critical infrastructure sectors, examples, you're now beginning to see that what used to be critical infrastructure versus typical standard infrastructures, that is becoming very gray, and it's all, everything and anything is becoming quite critical, all right? And it's everywhere, right? So you can see manufacturing sectors, transportation systems I covered, healthcare and public, everywhere you're beginning to have critical infrastructures in the making. And I will share with you the most recent fund that I've secured. I led the program with Imperial College faculty and our faculty members and my colleagues from School of Medicine, Computer Science, and Electronics, Electrical and Electronics, right? And I tell you what we are trying to do. And we managed to get the $23 million. I say we fooled the government or fooled the international reviewers. It was an international review panel for a day, but we got that money. I will tell you in a moment what we are trying to do with that money. Okay, so if you talk about offline training and online prediction for the transportation, and this is definitely an ecosystem for demand-aware transportation. I'm not intending to go into the details. It's one of the PhD students' work. By the way, it was done by one of the Sri Lankan students. He did excellent work towards the end of it. It was well regarded by the Land Transport Authority. The question was, can we have a demand-aware transportation system for Singapore? And taking the existing Singapore network, bus networks and all that, the answer was yes, it can be done. That means you cut them into zones, because there was a particular topology in the way that bus networks were all engineered. And you can get them into zones, you can put a bunch of vehicles of different sizes, and you get these cameras fixed, and then they learn, and they decide what kind of vehicle sizes and what timing they should be routed around. And the overall aim is to enhance the productivity of moving people. That's it. You're not trying to please every single public out there, but you're trying to enhance. And we looked at that, and it's feasible. All because we can come up with affordable AIoTs that can lead to this proposition. Right, this is the one about the Imperial College. I just wanted to quickly go through a few things that are there and to let you know these are not, these are very possible disruptive outcomes of connected infrastructure. This is precisely $23 million. I was a lead PI for this, and it took us about 2.5 years. I must tell a lie if I say otherwise, and just get eminent researchers in Imperial College. I had the fortunate opportunity to work with professors who had successful startups, implantable medical devices and so on, but they've never been concerned. They even say, what is cybersecurity? They were not at all concerned. If your pacemaker is connected and it's made to operate for a long time, functionally correct, as long as you don't have any adversarial mindset, it works. But when I went to Israel, they showed me, without touching the patient, they can attack the pacemaker. And you can decide whether to kill the person slowly or fast. Okay? So once you begin to realize the potential danger about all this, then is the system built correct in the first place? Is it adversarial attack resistant, side channel attack resistant? And if you're going to connect it in order to try and adjust your pacemakers because your patient conditions, health conditions are varying without having to take it out, then you have remote connectivity. Then the question was, can this connectedness can also apply to healthcare systems like your insulin monitoring systems, and can basically, what if I were to run an algorithm and then later your measurements and all that are looking better, I'm going to adjust it. Oh, by the way, press a button, doctor presses a button, your algorithms are tuned, you go home and you don't realize what's going on, but you are being better cared for, personal medicine. Is it possible? Or is it going to happen? Everybody wants it to happen. Are the legacy systems ready for it? No. They are the OTs, if you like, right? Do we need to have this one day? Yes. Then the question was, can you give us the certain level of assurance that it is safe? This particular interface is going to be high integrity interface. Now, this is a huge headache. You've got several, so you have got an infrastructure, several connected systems. You need to take, you've got the device itself you need to protect, right? You've got to design for security by design concepts. And then you've got a secure communication, and then sophisticated data analytics of your data that also need to be protected, your data analytics paradigm, and so on. So it's not just the device, it's the entire ecosystem that needs to be protected. So how do we do this? So they said, this is a very, very interesting problem. We are all been working in isolation, let's come together. So the computer scientists and talking about data analytics and AI and whatever, said, okay, I'll chip in, I'll throw my hat in. And medical device developers said, yes, I never thought of it. Tell me, how can I coexist and give you that higher levels of assurance, of security? It's an open problem. Right now, you all know Imperial College is pretty high in standing, right? In terms of innovations and their position and the colleagues over there. This is a brand new problem. It's going to be tackled over the next 4 years. Okay. I've taken on one of them, and Li Yang is, I kind of handed over to him after we secured the funds to lead the program, but I'll be looking after one of the packages. Okay, so this is the one I mentioned about Smith's nephew. They also, it's very recent. Again, by the way, I don't know, this is apparently a colleague of mine, ex-colleague of mine from the university, Sri Lankan. I'm mentioning it because I'm here. And he was a faculty at the University of Moratuwa, I think. Was a graduate and a faculty, left for US or Singapore and then to US, and he's working for this company. And then he dragged me in to consult. And the problem there, this is top-notch company. They have very successful business of medical systems in operating theaters and everywhere. They want to go connected. They were changing all their platforms. And they haven't thought of cybersecurity. They're only looking at productivity, right? It's such a worrying landscape, right? So this is ongoing problems. Food industry, food security is becoming very important. We get lots of things imported. We don't know where they're coming from. I'm talking about in Singapore. We don't know where they're coming from, what seems to happen to it. People, inquisitive, they want to know. Okay? Has it come through the right channels? Or has it gone through stages where I would not want to touch this, vegetable or whatever the items that we want to intake. So this is also going to go. So this is another project. I'll just quickly cover this as a last slide. I took it off, put it in, took it off, put it in, because it's my pet project right now. And this is using your mobile phone to be able to track your movements with or without the GPS. So we have a sophisticated algorithm developed using multimodal data fusion techniques. And then there is also fairly a MP hard problem of stochastic optimization for scheduling that's running on one side. These are all coming together, trying to deliver healthcare to people in homes. This is, I don't know about Sri Lanka, but in the UK you have this, you have hospitals, you have, you can't keep everybody in the hospitals because it's expensive. The next level of care is home care, right? You go to their homes and provide care, and you get to try and go there and look after people at different levels of illness. And then after the home care is the care home, and then, of course, whatever the spectrum. Here, this particular device got all the AIs in it, all the complex algorithms in it, localization, tracking, and then medication administration protocols. But this is going to be handed over to the individuals as an app, if you like, and that's its correct operation without being tampered into, so critical in making sure the delivery of healthcare remains highly integral. Okay, so this is very important, and this is going on. And right now, people want to take it on because they just want to get things done in an affordable manner. They want this particular solution, but again, we are going into this ecosystem and disrupting and asking for more and more challenges to be met, okay, from a cybersecurity perspective. So with all this happening, let's go and take a look to see how do we at least pretend that we are doing the right things to stay on top of the game, all right? Because whatever I painted is unstoppable. It's all happening. Constant innovations are taking place. Us researchers are proponent of this, and so is the industry after the greed of wanting to make more and more money, okay? So the first thing I want to address is the software security. And again, there's a lot to cover, but I'm going to go through at a quick run. And this is core to our startup, IP and technology. And you all understand the open source dependency. About 90% or more of the code nowadays is open source because you want to develop it. Open source, the problem is, it runs in, it suffers the problem of code decay. After a while, people find vulnerabilities, and the CVEs, are reported on a daily basis, and then how do you go about patch it? So if you've got about 100 vulnerabilities, and then which one do you choose first? How do you prioritize? If you use the entirety of the open source, then it's easy to find it. But if you use part of the open source, because developers use all sorts of things, they say, I don't need this part of the library, I only need this part, then hunting and fixing them is a problem. Even more difficult, that's different from the high-level languages, even more difficulty when you do go and compile them into executables, right? They say, I don't know where that software came from, but I want to make sure that it is secure, it's vulnerable-free. And so we developed some techniques, and we came up with solutions, and there is an ongoing challenge here, and this is not going to stop, it's not going to go away, it's going to be intensified. We must get smarter and smarter to fix this, right? So this is what I meant by looking for known vulnerabilities and looking for unknown vulnerabilities. That's a 0 days, right, on the right-hand side. So when we developed these kind of techniques in the labs, we went and hacked into some these mobile apps from the banks, and we've quietly went and mentioned to them of the weaknesses and problems, and one led to the other. We also managed to win some bug bounties, and then managed to fool some investor to put some money, and then we grew the company from there on, okay? So this is something going on. This is some kind of a detailed flow. This is an area that is still very hot. A lot of people are playing this particular game, but not so well. Lots of false positives in identifying these vulnerabilities. And then the problem is, what are the remediations that you can, actions you can take? Okay, this is a growing problem. And, I mentioned about the bug bounties. I will skip the DevSecOps. Most of you know now in the DevOps there, you also have a security in the flow so that you end up making sure these issues are being resolved continuously. all right? So DevSecOps is also very standard. But this is the one that got the money for my graduate student who got the YC Combinator. What they're trying to do is, you identify the vulnerabilities, right? And then you trying to come up with an automated manner in which to patch. It's almost like a self-healing proposition, In the background, you identify the vulnerabilities, and then they pass it to the software security experts to go about fixing them, because the problem is, it's not version upgrade. As you all know, it's going to fix the problem. Version upgrade can break the code. So how do you make sure whatever the patch you are making, it also makes the code run without breaking? And they've done some targeted verification techniques. That means they understand the vulnerability. They first of all rank them in terms of criticality, and they go into the vulnerability and then turn around and say, okay, the vulnerability is this part of the application. I'm going to do some targeted verification. And after the patching, to ensure everything is running well, like your developers will test it and say, is it running okay? We are automating it. And automate it and patch the damn thing. And don't say a word about it. So you're becoming resilient, aren't you, now? Because it's all going to be intensified. It's going to be a commonplace. Don't make a big drama out of it. Can be automated. And that's what got him the $500,000. And by the way, he had some preliminary results to demonstrate the viability of it. And hence he secured the funds, all right? So this is very much a hot cake, and he's right now in California working on it. So what are we trying to do? We are saying that, look, this is unstoppable. It's going to happen in a higher degree of intensity. We need to find ways to get smarter ourselves. Code decay is inevitable. It's going to happen. Can anybody come up with open source libraries that is going to be code decay free? No. It's not possible. Why? We are in a hurry to get to the market and then worry about. So we need to find. It's almost like us catching a cold, and then we say, well, we find a way to fix it and get going, right? So this is the world we are in. Okay, so we are not stopping there in the software security. People are saying, you have a vulnerability in your software, but whereabout in the software is it? First of all, even more importantly, was the software constructed properly? Or was it developed by somebody in a very unorganized manner, so that you go and poke somewhere and everything end up collapsing? Or is it been engineered properly? So you are looking at the software quality from a software architecture perspective. And you are questioning where on the earth that vulnerability sits. And then you are making a decision, the criticality of that vulnerability, by looking at multiple factors. And then taking action, say, this is critical, let's deal with it. So all of that intelligence we need to acquire. So we need to bring everything together, and you can see application security is moving to software intelligence, okay? And this is a must, because without software, we have nothing, right? So a lot of work is ongoing in this area. And let's move to hardware security, maybe a little bit closer to my heart. And hardware security, we started asking the questions, are today's computers okay? Can we get the standard off-the-shelf computers and be happy with, as though nothing has changed? What about this new threat of cybersecurity? Should we then think of designing a computing platform that is meant for this new era, where we are going to be inundated with cyber threats? So, security by design has been mandated. We came up with lots of architectures and solutions. This is a must, because your starting point must be correct. You can't start on general purpose processing platforms and then look for all sorts of fixes and then hope that you are going to be on top of the game. You need to try and be smarter. So security by design is quite important, and is becoming very necessary. And there are techniques going on by trying to do some obfuscation, which was there in some secure operating system, real-time operating systems in the past, when we are dealing with financial transactions and all that. Now it's becoming standard methodology. Can you obfuscate? And can you begin to have some hardware diversification so that execution timing of instructions are dynamically varied? Just think about this. So you have a program, people cannot interpret it because you've got some custom instructions injected. Custom instructions are instructions of your choice, proprietary to the company. You introduce them, and then you also vary the execution time. And then so that side channel attacks are going to be that much more difficult because you've got secrets going everywhere, right? And should that become a standard methodology for building hardware systems? Answer is, from the research community, is a strong yes, right? Otherwise, we are going to be easy, for the adversarial attacks, and that can be problematic. Okay, so this is going on, and is it just a kind of a blue sky kind of a thoughts and never going to be reality? The answer is no. RISC-V architecture is an open source processor code that is available for us. RISC-V is gaining a lot of popularity. You can go there and you can put your custom instructions. In fact, a number of my PhD students worked on custom instructions and development and how to do that on the high density field programmable gate arrays, but now you have open source. So you can build a computer of your choice, processor of your choice, by injecting your own custom instructions. Nice. And you don't talk about it. You see, you keep that as your IP. And then what you do, in fact, is you go into the architecture. You can also have a configurable processor, reconfigurable processor, sitting there, a small entity that just disturbs the execution times, randomly varying it, so that the side channel attack people will not know what the heck is going on, when they're trying to infer, model inference, reverse engineering. All that is, you say, thank you, you can watch me, but you will not be able to make any sense, right? Is this possible as part of the design methodology for your end product? The answer is yes. Okay? So the mindset of taking standard processing platforms and implementing is fast changing. It has to change if you're going to make a differentiation. All right. So there's another one. This is adopted by industry right now, by an automotive industry, taken on very seriously. And let me give you the gist of it. Very simple, right? I'm sorry I'm not bombarding too many things. It's very simple. So imagine that you have a complex thing going on in an application, and you don't know what it is. There are many, many touch points. It's complex. So what you can do is, under controlled environment, you say, please operate. Operate normally. During the normal operation, you call it as a benign operation. You don't care what it does. You have something known as high performance counters on the architecture level. You monitor them, and then you turn and say, hey, this is all normal. Pass, 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 pass. You do a set of experiment, right? This is offline approach. Then what you do is, you put some malicious attack. This is what Dr. Nabil was saying, right? You look at some adversarial attacks onto it and say, hey, the behavior is going to be different now. So you take from what is known as a benign operation and consider those that are intentionally, injected with malicious malwares or malicious activities, even faulty scenarios, as abnormal behaviors. Do a T-score, can you separate them? Because it's very complex. So can I tune my system and say, I'm just watching at runtime anomalous behavior? If I can do that, I raise a flag. Because before the damage can be done, at the architecture level is the fastest and earliest point at which you can alert. Of course, there can be false positives. But you can also have a high degree of confidence there is a malicious behavior going on. Whatever it is, the system should not be continuing. It's got to be stopped. Automotive industry is adopting this right now. So what am I painting? A complex scenario. Let's not go down to the rule-based decisions. You treat it like a complex system. You train it, and you end up saying that, oh, you behave normally because you are under my control. There are no adversarial attackers here. Behave. I monitor you. Then I am going to say, what if you are attacked? how are you going to behave? I'll look at this anomalous behavior. I don't care about what the application is doing. I'm only looking at what seems normal and what seems abnormal. Beautiful. And you do that at real time. And we have demonstrated this in the lab. Okay? We are actually porting this into a real platform, a reference platform of automotive industry right now. So I'm just throwing some ideas. How are we going to deal with complexities and what are the things that are going on, right? So this is one. And we managed to come up with a framework, multimodal intrusion detections. You know, you can see, you can look at the lambda at the bottom is the one that I explained. You know, indicators and high performance counters. We look at the, you know, kernel space and syscalls, and we have got a very modern, right, anomalous detection system that can operate in real time and without impeding on the performance of the computing. This is important, right? You're not interfering with the code or anything. You're not changing the code majorly at all. It's all operating. You're just watching to see, hey, this doesn't look right. Okay? So I think these are the kind of things people are trying in order to manage complexity, if you like. Okay? All right. Security for OS, thank God. I don't need to cover it. Dr. Nabil has covered it quite nicely. But the slides I was going to show these, you know, how do, you know, you look at the side channel attack, parameter extraction, and then reverse engineer the model. Once you have the model, you are better equipped to attack the system. That's one work going on by faculty. They are also trying to do targeted attacks while you are doing the training the system, and then making sure you become, you know, resistant to these side channel attacks. The problem here is the performance gets affected of the overall neural network had you done it without the possibility of side channel attacks. But with the side channel attack resistant method, the neural network performance is, you know, somewhat degraded. It's okay. You turn around and say, do you want performance or you want performance and security? So you have a trade-off and reach a balance. And that's exactly what current work is going on. Okay? And then, of course, adversarial attack, spoofing issues Dr. Nabil did mention. I'm mentioning it because I'm fascinated. I'm really grateful he covered all that. So here, what people are saying in automotive industry is that, oh, if I used a camera-based detection of objects, obstructions like, you know, putting a patch on the road, Tesla was asked to go to the, you know, head towards the traffic instead of going away. Remember the morning's lecture? You see, I make a good student. I paid attention to whatever he was saying. And here, what people are saying, in fact, is they have multimodal sensors. LiDAR system, camera system, you check one against the other to make sure that you become adversarial attack resistant. What does it mean? It means you have no choice. It's going to cost you more in order to remain vigilant, right? This has to be done. Otherwise, we've got problems. You've got also data manipulation attacks. You also have a sensor spoofing attack on the neural networks itself. Okay? So these are the issues that are going on. And of course, there were dimensionality reduction is another technique people tried. They got some very good results because people tend to work on a high dimensionality training because people are always after performance. But you're saying if you reduce the dimensionality, you can, you know, mitigate these risks of attacks. So these are all being demonstrated. That's, you know, one of my colleagues. He's an tenured associate professor, but he was my ex-PhD student prior to, so I stole his slide. All right, so intrusion detection. Can I just get an idea on where I am, please, with timing? So that you see, professors know how to finish it in 2 minutes or 20 minutes. Any indication from anyone? Are we okay? Nobody's bothered. Good. Okay, so you're all staying. So we need to close it, right? Yeah. Okay. So we have intrusion detection methods. I don't know what that sign means. It's stop now or stop as soon as you can. Well, the good thing is I can interpret however I like, right? So, okay. Intrusion detection methods there. This is something I worked with Ben Gurion University Research Center. You know, you can see that Professor Yuval Ilovich is very well-known professor. We're good friends. We work together on a program, a bio-inspired way of you know, mitigating cyber attacks. and it led to you having agents. And if you make them all software agents, who do you trust is a problem. So you build some hardware agents you can trust. There are software agents. And the beauty of the idea is that you see that attacks DB. So we learn about the attacks that are coming on, and there is a way of predicting what the next attack is going to be, and then you are commissioning these software agents in anticipation of this attack impending. Beautiful, isn't it? You are not reacting to an attack, you are being proactive to be able to mitigate future attacks. That was the work, okay? I'm sorry if I'm confusing you, you can talk to me offline, but I can take you through because it's something that I work closely on, but that's something. So these are the ideas that people are working on, is to get smarter and get on top of these cyber attacks. And automotive systems, many consumer products and whatever are coming along, you don't buy the products from your consumer parts or automotive parts from one vendor. You buy from multiple of them. I threaten them, if you all come and coexist, are you secure or are you insecure? Because you all have to coexist because you need to sell them. They are all going to go into one vehicle. But what happens of the relative security because of your coexistence? And then this led to us proposing ways of take that complex system, almost like putting through some test. You attack it based on knowledge base you have and potential attacks that are impending, and then you try to see whether it can withstand these attacks. If you can withstand the attacks, you say, okay, you can drive it for another 6 months, but come back 6 months later. I want to attack you again in an informed manner. Land Transport Authority says, people are going to import autonomous vehicles. How do I know they are roadworthy? Good question, right? You know, they're cutting the prices to sell them, but how do I know it's safe enough on my Singapore roads? This is a proposal that's been looked at seriously. Cyber crimes, I will skip. I will not mention it because I need to respect that signal. And last 2-3 slides, smart cities. Let me just elevate it, get carried away and talk about at the city level now, okay? Is Singapore government happy about this Smart Nation initiative? And because I'm close to these government agencies, the answer is no. They're very nervous because people are going to throw solutions, right? And they're going to come up and they're all viable solutions. And it's good because we have an efficient city, we have a smart city and so on. But can you sleep at ease? Because of all these potential dangers that are lurking, or people just releasing stuff that are not being checked, you know, just only to wait for something to go wrong, okay? And this is not good. So they've come up with this is just a statement, I'll skip that statement. This is very important. What they are setting out to do, in fact, is if anybody is going to release an IoT into a new product, they need to be certified, right? They need to be certified. They need to be checked to ensure there is some level. It's almost like you constructing a building, and you need to know you follow certain procedures and it is safe enough to be released and be part of your solutioning process. So they call labeling scheme that is started. They're encouraging them right now. We'll give you some kind of brownie points if you are certified by these labeling schemes. And if you are, then possibly you can sell your products better. But if you are not, knowing Singapore government, they might make them extinct, right? So it's mandated. Somebody at the national level has to take responsibility of not letting things crowd at will. They must have a check and balance. So this is going on, and this is something that I feel as a must when we go into this connected infrastructure, all the conundrum, in addition to the software security, hardware security, and you know, the intrusion detection methods and all that I've discussed, you need to also do this. Only then, I think we see some level of sanity in moving forward and enjoy the benefits of connected infrastructure. All right, there is a $62 million just announced. I'm not tempted to get this small amount of money here and there, but not at my stage right now, but there is fresh money encouraging people to put up proposals. They are all my colleagues. In fact, Liang, Boan, and Chunyan, Liang and Boan I hired when I was dean, okay? So they are now the program leaders. Right, conclusions. Maybe you can read for yourselves, or I can just summarize. The number of devices connected is estimated to grow, we know this. And 5G allows IoT to exchange information in real time. So you have to now start to begin to visualize, hey, where are we heading? Is it exciting or is it going to be worrying? I'll leave that to you to decide. And connected systems equipped with intelligence is fast becoming pervasive. We understand that. Okay, now I've given you some a taste of that. And then build and use for many years mindset of IoT has to change, right? Because it's going to be always remain connected and maintainable. If you can't maintain it, you're doomed, all right? And cybersecurity solution must be holistic due to inevitable convergence of IT and OT, which is important. Certification will become a crucial. My last slide mentioned that. Without certification, there is no policing that is going to take place. Without policing, we got chaos, all right? So that has to happen. Embedded computing architectures must evolve to support security by design requirements, which is true. And vulnerability analysis and management of software must be automated to mitigate adversarial attacks, all right? So remember, the ransomware and everything is because someone is slow to do the patching or updating. No more. You do it as soon as you can, automatically. That's where investors are pumping in money, right? Is it going to happen? Yes. Why can't we do automate verification? Why can't we do the targeted direction? We have some early results. That's why that my ex-grad student is in California right now, okay? And AI security will become crucial for sustaining critical infrastructure, which is important. AI, without AI, can you see solutions? Possibly not. So if AI is going to be there, who is going to protect it? We have to take care of that, all right? Governments must invest heavily into youth-led cybersecurity training to increase local talent pool, which is very, very important. There's an acute shortage in Singapore, cybersecurity talent. So if you are ever interested in cybersecurity, I'm telling you, future is so bright, okay? I know one of my relationships manager at the bank, his wife is a penetration test expert, and I said, you married a rich lady, all right? That's the world is going to be, all right? Penetration testing, because, why not be very profitable in this kind of conundrum, Why don't you go and try and tell them what they need to do? So please, for the youngsters, you need to also keep that in mind. And it has become critical to inculcate ethics into computer science curriculum. This is very important. We have our students hacking into our NTU network. The smart students, they're trying to get at the marks or whatever, but I'm in the part of the steering committee trying, hear all the problems. Smart, but you must also inculcate ethics. Otherwise, who are the people who are turning into adversarial attackers? I'll do anything for money is the very people we train to become computer scientists. So we have to inculcate a culture of ethics there. And CS experts in academia must partner with the law enforcement. I didn't cover that. I skipped the slides because of time constraint. But I'm working closely with the Interpol headquarters. And someone who brought me here, instrumental, was Anupa, who apparently a student who worked in Colombo University, worked under me. He said, sir, would you please go and give a keynote? And he worked with me with the Interpol project, okay, in cybersecurity. It's a beautiful story. Interpol is in dire trouble. They don't know. They don't have that. Hackers are very smart, sitting there and saying that, catch me if you can. Interpol headquarters tells me there's nothing they can do about it. I can give an entire lecture on that, right? But the reality, in fact, is they must partner with academia in order to combat this cyber criminals and cyber-enabled criminals. We need to go after them. They don't have the weapons, right? And cyber-physical security is important. They are good. I have a nose. Remember, investigators are top-notch. Remember, your number one in police is part of the Interpol, team, right? And I was working with, the director was number one police in India, from India. So these are top people, think tanks, but they are having huge problems, okay? And they came and signed a joint declaration with us to collaborate because they also need that. And how to do that? there are some interesting propositions we put up, and we are securing some funds at the moment. So with this, I'll stop and ask you if there are any questions. I'm hoping you won't ask me any questions, but then let's see. I think there's reception later. In the interest of time, you can also, poke me individually if you want to.
Excuse me, sir. Here. So what kind of, in talking about the ethical framework, in regarding AI ethics, what kind of new frameworks or any kind of new ethical AI guidelines have been introduced to deal with these kinds of threats? Do you know?
Foresee it's coming.
Yeah, for these AI threats, what kind of new guidelines or ethical?
There are no such guidelines, that's the problem. Okay, there is no discipline in this world. There is not a discipline how you choose your software engineer today, right? We have a fundamental problem there, right? We don't know. As long as it works, you think everything is fine. There could be a problem in the, just waiting to go wrong. So people are not thinking about them. They are all in a hurry to push the solutions, get them out there fast. Nobody is qualifying the quality of software that's been developed, yet alone. So the AI is also going through the same problem, right? So there's a rush to get out there. It's causing the fear at the government level, because it's all right if you build something and you use it and it crashes, but if you bring it into the nation and they become part of the critical infrastructure, major problems. So even Singapore just waking up to this call.
Yeah, thank you, sir.
Thank you, Professor Sikrant. That was an enlightening keynote. Can you quickly advise like one or two advices for an embedded developer who's planning to deploy lightweight machine learning models on an embedded device, right? For example, you are in the process of planning to deploy like machine learning models in public infrastructure, like bus stops and everywhere. So adversarial attacks are going to happen, like just Professor Nabil mentioned in the morning. Yeah.
So I think this question was asked earlier, I think. We got a very lean systems that are also becoming smarter. Where is the budget to try and make them remain secure? The answer is no, we don't have, all right? So that is understood, but the good thing is they all remain part of the connected infrastructure. There are things at the edge computing infrastructure or further behind. They all need to collaborate in order to bring that holistic level of assurance up. You are trying to, so first of all, I think you come up with a very low-end devices to come up with a feasibility or viability of a solution. But trying to make that also to be secure by itself is a problem, right? But so you have to look at the holistic infrastructure and think of enhancing the security of that entire infrastructure, right? So this is the way I see it. So you cannot do that. But should we then stop doing kind of incorporating intelligence into lean and very low-cost devices? No, because market forces are saying that if you can't make it affordably, I don't want it. I can't afford it. So it's a push and pull game, right? Yeah. This is exactly what we are doing for the implantable medical devices. You can't put a high-end system over there and power consumption challenges, even the size, and all that will become multiple functional and non-functional constraints are going to always be there. So we need to first crack it and then look to see in a different perspective at a system level to be able to meet those challenges, I feel. Yeah.
So in your presentation, you says that image processing smart pedestrian system.
Predictive.
Yeah.
Yes.
On that system, you mentioned that you need no need to use computer for the processing system. uses that we can use a chip for that. I want to ask if we consider about four-way junction, how we manage the traffic control or pedestrian control system.
Okay, so I may not have put that across properly. The end system, the IoT, is where you can't rely, what the IoT does, you can't replace it with a PC. But what the overall control, you will have some powerful computing behind the scene, right? So I'm only talking about affordability of those AIoTs that are going to be deployed in large volume, collect the data, aggregate the data. But once you aggregate them, yes, you can have a cloud computing infrastructure, if you like, to be able to churn and process them.
Another question, if what are the response rate if we think about its own speed, some not popular area on some rural area, if we use these pedestrian systems, what are the response, how get quick responses or something else?
Yeah, I don't think because we have a solution, we hit it everywhere. I think you put them, first of all, in the most busiest kind of pedestrian crossings in the heart of the city, for example. Valuable minutes are lost because we don't have intelligence of monitoring. There are people waiting, there are these vehicles, and we don't know, we lose. And this time is quite precious, right? So you go where it benefits most to begin with. It doesn't mean that you have to just spread it entirely. No need. Have I answered that? Yeah? Any other questions, please? Anything at all burning? But I'm sorry, I covered a lot, but I think I will make it a point to stay for the reception or the tea break or whatever, then come and ask me. I got few tickets to, I mean, those who ask me the questions, including the professors, must come and collect a ticket from me. All right, I have a mission to complete here. All right, so about 5 or 6 of them, please kindly come and see me, and then those who are wanting to ask questions also come, because number of tickets are more, that I need to issue out. All right, thank you.
Thank you, Professor, and thank you all for your wonderful questions. Professor Srikanthan, please remain on stage to accept a small token of appreciation. At this time, we would like to invite Dr. Nalin Ranasinghe to come forward and present a token of appreciation to Professor Thambipillai Srikanthan. Thank you, Professor, for your insightful presentation. And with that, we bring day 1 of the ICTer International Conference to a close. We would not have been able to pull this off without the assistance from our sponsors, namely, Gold sponsor, Cambio Software Engineering. Silver sponsor, Genie from Dialogue Finance. Bronze sponsor, WSO2. Keynote sponsor, Exam Genius. Stationery sponsor, Unidil. And esteemed partners, namely Enterprise Connectivity Partner, Dialogue Enterprise. Business Promotional Partner, People's Bank. Mobility Partner, PICME. Partner of Keynote Honors, a taste of Ceylon provided by English Tea Shop.
Thank you everyone for making this day a resounding success. The discussions, presentations, and networking opportunities have been truly remarkable. But the excitement doesn't end here. We invite you to join with us in the day 2 of the ICTer conference, where we have even more engaging sessions, insightful talks, and opportunities to connect with experts in the field.
We look forward to your continued participation, and together we'll continue to explore the frontiers of technology and innovation. Have a wonderful evening and see you all tomorrow. This is the ICTer International Conference 2024.
And now we invite everyone to take refreshments. Thank you.